Yeah, hi everyone, welcome to PrepFusion. So, All India mock test, our full length All India mock test was conducted with the name was KillerX. Now, in this video, we need to see the video solutions. So, for all the problems, we are going to see the video solutions. But let's talk about the question paper. As of now, when I am recording this video, as of now, the examination is not conducted yet. Okay, I am recording this video before the examination only because we need to post it as well. No, so that's why. So as of now, the examination is not conducted, but I have set up the question paper. Like 90% of the problems have been set up by me only. So looking at the question paper, what I feel is that uh, I guess roughly around 500 people should be attempting it live. Roughly around 500. Okay. And out of these 500, only 25 will be able to score 50 plus marks. This is what I feel. Although I will see the analysis, I will see the results, and then we can talk about more. Okay, but as of now, looking at the standard of the question paper that I have set up now, based on that, I feel that only 25 people will be able to score 50 plus score. This is what I feel. Okay, I know the question paper is a bit lengthy. The name is KillerX, right? KillerX. So question paper was killer. But let me tell you one thing: if you feel like that question paper was lengthy, the questions were having a lot of calculation, then just see the solution once. You would realize that calculation was not that large. You were needlessly putting so much of time in the calculation. Smartly, you could have done the calculation. So you would get to learn a lot of new things that I can guarantee you. My suggestion from my side would be, or my request would be that you put 4 to 5 hours in analyzing this particular question paper. Whatever the question that you have attempted, how you attempted, how much time did you take, sir, in this particular question, how I could have reduced my time, or how I could have got it correct, why I got it wrong. All these things you analyze this question paper taking 4 to 5 hours, at least 4 to 5 hours. Okay. So at 2 p.m. we are uploading this video. I would say take 4 to 5 hours of time to analyze this question paper. Whatever the mistakes you have done, what you are learning from this question paper, and a lot of quality problems are there. From each problem, you will get to learn a lot of new things that I'm telling you. Along with that, I'm recommending the video as well, that this particular video you can watch to make your concepts better. So that is also there. Okay. And along with that, once the results will be announced, everything would be there. So we will also see the results, and we will be coming live at 7 p.m. today. Okay. We will be coming live at 7 p.m. for the complete discussion that how much marks the topper got, how much marks the rank 10 guy got, what was the marks of rank 1, 2, 3, 4, 5, 6. So all these I will tell you, and then I will tell you based on your score, where do you stand. You can ask, sir, this much marks I got. Sir, let me know where do I stand now. What I can do, what I can do to do better in the gate examination. Sir, what would be your suggestion? So whatever the things that you want to ask, you can ask, and we will talk about the difficulty as well based on your reviews. Okay, so all these things we will talk about at 7 p.m. live. We will come and full discussion. I will tell that this much, this particular subject was tough, this particular subject was easy. From here, more questions were there. Everything we will talk about. Okay then. Yeah. So let's see the solutions now, and let's meet at 7 p.m. Okay. Yeah. Thank you very much. Let's get started with the first question.
Consider a 5-digit number A, B, C, D, E formed using digits 1 through 5. Okay, so they are all, each digit is used exactly once. That means each digit is unique, and the following conditions are given. A is less than C, B is greater than E, D is less than B and less than, okay, so these are the conditions. Then what is the value of B? So A is less than C, right? And I can see C is here. That will not help me. And A is less than E as well. So A is both less than C and E. Okay, this is one thing. B is greater than E. So B is greater than E. So B would be lying somewhere here. Okay, but B is less than C actually. B is less than C. So if B is less than C, that means C has to go here, right? So actually in this kind of questions, always try to solve with the best, like where most of the information is given. So C would lie here. Okay, because C is greater than B and D is less than B. So D can actually lie here somewhere here. Okay. So it seems like C is the highest. Okay, because I have total 5 digits. C is the highest. B is the second highest. That is for sure. B is the second highest. So B would be certainly 4. Okay. B certainly would be 4. Again, if you are confused, again you satisfy whether this particular inequality is satisfying all your conditions. So A is less than C, yes, A is less than C, true. B is greater than E, yes, B is greater than E, true. B is less than C, yes, B is less than C. B is greater than D, yes, B is greater than D. E is greater than A, yes, E is greater than A. So whenever you are confused, first form the relationship inequality and then you check the conditions where your formed inequality is actually correct. Is it satisfying all the particular conditions or not? So here 4 would be your correct answer because B is the second highest number. I have 1 through 5, so 1 2 3 4 5. 5 is the highest, 4 would be the second highest. Identify the option that has the most appropriate sequence such that a coherent paragraph is formed. P. As a result, many of them were forced uh, to abandon their plans midway. This does not seem like a starting point. They believe that the journey would be simple and success. Again, no. However, the harsh terrain, again, no. When the announcement of a new trade route was made, countless merchants set out immediately in search of quick profits. So this seems like a good starting point. Okay, so I see an option B and option C, S is the starting point, right? Then I have either Q and R. So I will read Q and R. So they believe that the journey would be simple and that success was guaranteed. However, harsh terrain, lack of resources, and unpredictable weather soon proved otherwise. So you can see, like, of course, your option B is totally matching your sequence, right? You can read the last statement as well. It will totally match your sequence. So it's very simple. Option B is your correct answer for the question. Consider the relationships among A, B, C, D, E. Okay, so A is the father of B. So let me draw the tree diagram or family diagram. So A is the, let me change the color. A is the father of B. So B is here and A is here, right? And A is a boy. So I can write A as plus. So plus basically for me means boy and minus basically means for me, minus basically means that it is a girl. So A is the father of B. I don't know what is the gender of B. C is the wife of A. So A and C are wife. So this double arrow basically means they are married with each other. D is the son of B. So D is the son of B. Okay. D is the son of B. So D certainly is a boy. E is the sister of D. So if they are sisters, then I will not do that arrow wala thing. I will just do this. So D E is the sister of D. The following statements are made based on the relationships given above. C is the grandmother of D. C is the grandmother of D, certainly yes, because C is also mother of B as well, right? So if they are father sons, I can actually get an arrow. So if C is the mother of B and E is the daughter of B, then certainly C would be the grandmother of E. Certainly that is correct. Sorry. Oh yeah, same thing. C is grandmother of both D and E because they are both brothers and sisters. So this first statement is certainly correct. A is the grandfather of E. Again, this statement is again correct, right? Because we can see B is the father of A. Sorry, A is the father of B, and B is the I don't know what is B. Either B can be mother or father, does not matter. But ultimately, it is either father or mother, right? So A is grand father of E. That is certainly correct. B has only one child. No, B certainly has two childs, right? You can see B has a son D and B has a daughter E. So B has two childs. So statement 3 is incorrect. C has only one son. So according to the information given us, C has only one son. Okay. I will not be able to comment whether C has only one son or not, uh, because what is the problem here? The problem is I don't know the gender of B, right? B can be the girl or daughter. Sorry, B can be the girl or a boy. So if B is either a girl or a boy, so C can have only one daughter. That is also another possibility. There are two possibilities, right? C has only one daughter or C has only one son. So there are two possibilities. So I cannot surely say that this statement is 100% true, right? There are two possibilities. So both 1 and 2 are true. Okay. So option A will be the correct answer for this question. Based on the conversation, below, identify the logically correct inference. Even if I had been informed about the meeting in advance, I would not have attended it. So even if, like Arjun had been informed regarding the meeting in advance, still Arjun would not have attended the meeting, which is the correct inference. Arjun was informed about the meeting in advance. Does not seem like it, because Arjun is saying even if I had been. So he wasn't, right? Even if he was, then he would have not joined, but it's not like he was informed, right? He's saying even if I had, right? So he was not informed. So Arjun was not informed about the meeting would be your correct answer for this question. A stationery store sells four distinct types of pen. So I have four distinct pens. So P1, P2, P3 and P4. Now a customer can buy any number of pens of each type. So basically I can buy P1 four times, right? So 4P1 I can do, or 3P2, 1P1 I can do. So any number of pens, there is no limitation. And the order in which the pens are selected does not matter. Let's say first I choose 1P1 and then I choose 1P2, then I choose 2P1, right? And for example, let's say first I choose 3P1 and then I choose a P2. This order and the previous order, whatever I explained, those are the same. Order does not matter. If the customer wants to buy 3 pens, so I want to buy 3 pens, in how many different ways can the purchase be made? So basically I have three box to fill, right? I want to buy 3 pens. In how many different ways can I purchase? So he will say, sir, I will select 4C3, right? Because order does not matter. I will select 3 pens and that will be my answer. And you will be wrong, because this will only consider the case when I'm choosing all the 3 pens to be distinct, right? This does not take into account that I can choose P1 thrice, correct? So this is the case that is certainly true. 4C3 is certainly one of the correct answers. That is, I can choose case 1 where all pens are distinct. All are distinct, right? So that means basically I will have P1 here, P2 here, P3 here, right? Or I can have P2, P3, P4, something like that. So when all three are distinct, so out of 4 I have to choose 3, right? It will be 4C3. That's very simple. Now things change here. As soon as I move, I change the case. What case I make? So let's take another simpler case, right? Or let's take a bit of difficult case. The case is that 2 pens will be same. Here all of them were distinct, right? 2 of them will be same. So let's say 2 of them is same, right? So basically now be very careful. Okay, be very careful. You cannot simply use this. This is used only when the number of boxes that I need to fill are equal, right? So I have to choose 3, so it will be 4C3. But here I'm just giving you a example scenario. I have chosen P1, right? So P1 will be chosen twice, and then I can choose any other pen, let's say P2. So this is also a valid way to buy the pen, right? Because I can choose a single pen any number of times. Like this, I can have P2 here twice, and then I can choose P1. That is also another possibility. That is a different arrangement, correct? So how do I do this? How do I solve this? So what you do, first you select a pen. First you select a pen which will be bought twice. So let's say I have total 4 pens, right? Out of 4 pens, I select a pen which will be bought twice. Then in this particular box, right? So I hope you understood the example. So to choose a particular pen, right, out of 4 pens will be 4C1. Now, what is the option that is left in this particular box? How many ways can I fill this particular box? How many ways? It is 1C1, because I have to choose one pen and I have only one option. If I have chosen here P1, then I will choose P1 here. If I have chosen here P2, then I will choose P2 here. Like that, right? Again here, what will happen? Now, how many options are left? 3 options are left, right? 3 options are left. Out of how many I have to choose? 1. So total, what will be the answer? This will be 12. Now you might have a very good doubt, sir, we could have done it like this, because you are saying 2 pens are same. Yes, you are correct, you are saying 2 pens are same. Then sir, what you could have done is just select 2 pens, right? Out of 5 pens, just select 2 pens, and one of the pen will be repeated, P1 P1, and the other pen will not be repeated. That's it. Just two, because we're ultimately we're choosing 2 pens. You are correct, but this particular thing, right, and this particular thing, both are different. Both will give you different answers. Here, what I will get, it will be 5 into 4 upon 2, that is 10. Correct, 5 into 4 upon 2, that is 10. So not 5 into 4, sorry. This will be 4C2. I have 4 pens, right? Sorry. Four into 3 upon 2, that is 6. So what is different here and here? The difference is here, let's say one selection, right? P1, P1, P2, and the selection P2, P2, P1. Are these different? Yes, these are different. But in this case, you are choosing 2 pens, right? So you can either choose P1 and then P2, or you can either choose P2 and then P1. Are these same? In this particular case, when you are using this formula, I hope you have studied PNC. In this particular case, because arrangement does not matter, they are the same. They are the same, right? Because we have considered only one case for this, because they are simply swapped. So be very careful while using this PNC formula when your boxes to fill in is more, right? And like it's a bit different. So do it step by step. Do it step by step. So that's why it will be 12, not 6, because the reason being P1, P1, P2 and P2, P2, P1, these two are different arrangements. But in this case, these two are same arrangements. Got my point? Now, either two of them can be same, right? All three are distinct, and obviously the final case, the easier one, where all three are same. Correct. So when all are same, so what is 4C3 basically? 4C3 is basically nothing but 4. So when all are same, that essentially means that in all the boxes, the same pen will be there. So if I choose one pen, right, and I fill it up, so in the other one, I have only one option, 1C1, 1C1. That's it. Correct. So yeah, it's not that difficult. 4C3. I'm just thinking one thing. 4 to 4 pens, I choose 3. Arrangement does not matter. Yeah, they're all listing, right? 4 by second arrangement. Yes. Okay. Yeah. But technically, like you have to choose only one pen, right? And then you have to repeat it. So it will be 4 as well. So your overall answer would be what? Overall answer would be 4 plus 4 plus 12, that is equals to 20. And trust me, if you see the solution of this question, right, anywhere in the internet or something, you'll always get a formula. They will always show you a formula. They will not tell you how this was solved, right? I have told you the method how to solve. So your answer would be 20 for this question. If stone and water are coded as such, then which of the following is the most appropriate for plant? Okay, so there are 4 options that you can see. I have not copied the options. What essentially you will do, you can see what are the common words, right? I can see that I have in this word, I have A. So A is coded to, if you see, Y. Okay, and I have also N. N is coded, so A is coded to Y. N is coded, I can see N is coded to Z. Sorry, N is coded to L, right? And your T, if you see in the second letter T, T is coded to R. Okay, so I see that the last 3 letters must be Y, L, R. Okay, last 3 letters must be Y, L, R, and that I can see only in option. Like I don't have the options here, but I have kept the option as C, where the last 3 letters are Y, L, R. So that will be your answer. But if you want to understand it more thoroughly, what you can do, you can obviously write down the numbers, write down the positions, and you can see the pattern. The pattern here is simply -2, right? So with all the letters, I'm subtracting 2 digits. So if let's say for the first letter it is S, right? So S, if I subtract 2, I will reach here, that is Q. So you can see the coded letter to be Q. So you can follow the same pattern for all the other letters, and you will just subtract 2 from each letters, right? So you will get your coded word. So here option C would be your correct answer for the question. In the given figure, ABCD is a square of side 3 centimeter. So ABCD is a square of side 3 centimeter. AEFG is a rectangle where E is the uh, point that lies on the side BC of the square. Side FG of the rectangle passes through the corner D of the square. The sides of the rectangle are parallel to the sides of the square. uh, Sides of the rectangle, I think this statement should not be there. Sides of the rectangle are parallel to the sides of the square. What are they asking? They're essentially asking me what is the area of the rectangle AEFG. That is what they're asking me, right? So this is 3 centimeter. This whole thing, it is a square, right? So this is also 3 centimeter, correct? Now if I have uh, let's assume these to be my theta, correct? So this is the base, right? And what would be this side? So my tan theta, do I need tan theta? Do I really need tan theta? I'm just thinking about that. Okay. uh okay, this will be so this is how, what angle? This is 90 minus theta. 90 minus theta, and this is 90, right? And so this whole this angle would be what, 180. Sorry, hold on. So yeah, what will be this small angle? This will be 180 minus this angle, right? So what is this angle? It is 180 minus theta. So this angle is also theta only. So add all these angles. Do I get 180? Yes, you get 180. If you add all the angles, you will get 180. So angle of a straight line is 180 degrees. So this will be theta. This will be again 90 minus theta, correct? This will be also 90 minus theta. Like, what do I want? I essentially want, so this particular side is how much? Let's assume that this side has a distance of x. So this will be how much? This will be 3 minus x, correct? This will be 3 minus x. Okay. I'm just trying to get any information regarding the sides. Okay, this is 90, this is 90. 90 minus theta. Now this is also 90 minus theta. This is also 90 minus theta. This will be theta. This is theta. This is 90. Right. So this will be how much? This will be again 90 minus theta. If this is 90 minus theta, this is again theta. But what will that help me achieve? If I know this theta angle, what will it help me achieve? So this is, let's say, okay, let's assume that this whole is x. Let's not assume that, and let's assume that this whole thing is y, right? So 3 cos theta would be y. Okay. Okay. So this is x, right? It is a rectangle. So here this is the hypotenuse of this particular triangle. So x into cos theta, x into cos theta would be equals to what? Would be equals to 3. What about here? So this is my hypotenuse here, right? This is my hypotenuse. So this is what? This is 3, right? So 3 into cos theta would be equals to what? My y. What do I have to find out? I have to find out the area of the rectangle, that is x into y. I have to find out x into y. So what? Okay, they are very talented. So your x is what? X is 3 upon cos theta. And what is your y? Y is your 3 upon, hold on, y is your 3 cos theta. So your areas are actually same. So x into y would be simply equals to 9. So the area of the square and the area of the rectangle are actually same. So option B would be your correct answer for the question. Two cyclists A and B start simultaneously from point O from 9 a.m. onwards. So two cyclists A and B are starting at 9 a.m. onwards. Cyclist A travels south at a constant speed of this much. Cyclist B travels west at a constant speed of this, but halts for some time after riding for 1 hour. If both the cyclists are at same distance from point O at 10:45 am, how long did cyclist B stop? So essentially what they're telling me that both the starting point is same and they are essentially measuring the distance. So let's say if this is my north, right? So we are starting, okay, hold on. If we are starting from point O and we are moving, cyclist A is moving to north and cyclist B is moving to west, correct? And they have not mentioned anything regarding cyclist A. So assumption is cyclist A does not stop. Sorry, cyclist A is going to south, not north. So if cyclist A does not stop, how much distance has A covered? So it will be speed of A into the time, right? What is the time? Time overall is how much? So this is in hours, how many it is? So we are starting from 9 a.m., right? So it is 1 hour and 3/4. So it is simply 1.75 hours. I hope you got the point, right? How I have getting 75, that is 45 upon 60. Essentially converting this minutes to hours. That's all. So 1 hour, 1.75 hours. So this would be 20 into 1.75. So it is actually 9 upon, no, not 9, 7 upon 4. Am I correct? If I do 7 upon 4, what is that? That's 3 into 7. Yeah, 7 upon 4 is correct. So this will be equals to 5, that is 35 kilometers. So B also has to cover the same amount of distance because essentially it is just a straight line. We're measuring the distance. They're telling me that B also has covered the same distance from point O. So B also will cover the same distance, right? So for how much time B needs to travel to cover this distance, because the remaining time has been wasted in taking rest. So we can directly calculate it. So it will be SB into TB will be equal to 35. So TB would be equals to 35 upon SB. SB is given as 24. Right, that is equals to 35 upon 24. That is 1.4583. So essentially it means 1 hour and 0.4583 hours, right? So if I want to convert this into minutes, 0.4583 into minutes. So if I want to come back to convert to hour, what I did 45 by 60, right? I will do the opposite now. Essentially I will multiply this 0.45 into 60, that will convert this into hour, into minutes, sorry, into minutes, right? So I hope you know how to convert from hours, minutes and stuff. Now B travels for this much minutes, right? And they are telling me that they are at the same distance at 10:45. So how much, so what is the amount of time for which B can take rest? Because certainly in this whole duration of 1 hour, or let's compare this particular thing, right? In this whole duration B needs to travel, right? So what is the rest amount, what is the rest period? Because in 1.75 hours both of them must reach the same point. So the difference being the rest period, right, x would be equals to 1.75, right? That is at 10:45 am minus 1.45, because B travels faster, so B will reach this distance faster, but certainly B also takes a rest, right? That's the point. So B rests B takes a rest. So the amount of rest would be total duration minus the duration of travel. So this would be 1.75 minus 1.75 minus 1.4583, this into 60, right? I will convert this into minutes. So it will be approximately 17.5 minutes. This will be your answer for the question which is present in option B. Many students will make a mistake that they will assume this, right? They will just convert this 0.453 into 60. That is wrong, right? So yeah, don't do it. So they will assume that, okay, I have only traveled for 1 hour 27.5 minutes, and like they will make some mistake. Don't make the mistake. Actually, what is the total duration? Total duration is 1 hour 45 minutes, right? Total duration is 1 hour. Here, from here also you can do 1 hour 45 minutes. So what is the difference duration, right? That is what you have to compute. That is 17.5 minutes. This will be your answer for the question. A postgraduate applicant applies to two universities, University A and University B. Based on her profile, she estimates the probability of receiving an admission offer A to be 0.7. Okay, so probability that A event will occur, right? Receiving admission on university, like, yeah, receiving an admission in A would be 0.7, receiving an admission in B would be 0.5. Let X denote the probability that C receives admission in both universities, basically A intersection B, right? That is X. Then basically the most appropriate range of X shall be equals to what? Now I don't know anything regarding A and B. Are they independent? Are they not are they dependent? I don't know anything, right? So how can I compute the range? So what is PA intersection B? So we know this formula, right? PA union B is equals to PA plus PB minus PA intersection B, right? So essentially your X is equals to PA plus PB minus PA union B. Okay. Now, what does A union B mean? So if this is my Venn diagram, this is my A and B, right? So I certainly know what is my PA and PB value, right? So let me put those values. PA is 0.7, PB is 0.5. So this will be 1.2 minus PA union B X. Can you tell me what is the maximum value of PA union B? So if this A union B covers the whole Venn diagram, that is 1. If you cover the whole Venn diagram, it will be 1, right? That is the maximum value of PA union B. So X would be equals to X minimum, right? Minimum value of X would be equals to 1.2 minus 1, that is 0.2. So I see the minimum range that is present only here. That is a minimum, right? Minimum, because PA union B will certainly be always less than 1, less than or equals to 1. Okay. So it will be always less than or equals to 1. So if I'm subtracting something less than or equals to 1, then this value will only increase than 0.2. So X will always be greater than 0.2, that is certain. But how do I compute the larger limit? So we got the lower limit, right? How do I compute the larger limit? So PA union B is this. Of course, PA union B, it cannot be 0. I have chosen the maximum value, that is 1. It can be somewhat less than 1 as well. Now, what is the, do you know what is the minimum value of PA union B? PA union B. The minimum value. Do you know what is the minimum value? So the minimum value would be actually equals to minimum of PA comma PB. Why so? So basically this can be a possible scenario, right? Sorry, not minimum, maximum. Where A is totally inside B. So what will be PA union B? It includes both. It includes both A and B, right? So I will have to choose the maximum of PA comma PB, right? So maximum of PA comma PB in, like, basically I'm just choosing a case where PB is highest. Okay, so basically my A is totally inside B, right? So there can be another case as well. What will be the other case? Other case would be this one, where my B would be inside A, right? This can be the case. What is a PA union B? That is PA only, right? Because B is already inside A. So PA union B would be PA, and here PA union B would be PB. So basically, essentially, I am choosing the highest value. Highest value. So the minimum value of PA union B would be actually maximum of PA comma PB. So that's how you can conceptually understand it. So here this will be actually equals to maximum of PA comma PB, that is actually equals to 0.7. So your X max would be 1.2 minus 0.7, that is 0.5. That is the highest value that you will get. You will not get anything above it, right? So X will vary from 0.2 to 0.5. So option B is certainly correct. Okay, it will not, because you will have to see that this is the minimum amount of value that you will get. Okay, why this is the minimum? I have given you the total explanation why minimum. And when you're getting this minimum value, right? So this negative is minimum, that means your X will be maximum. Okay, just the opposite, because negative sign is there. So certainly this will be 0.5. So 0.5 will be the highest value, 0.2 would be the lowest value, that is option B. The stamina level of a runner can be expressed as a function of their age. Okay, so basically I'm expressing the stamina level of a runner as their function of age, right? This function varies from person to person. The function varies from person to person. Suppose this function is identical for two sisters. Okay, the function is identical for two sisters. Okay, and it monotonically increases up to the age of 35 years and then monotonically decreases thereafter. Okay, identical, it monotonically increases. Let A1 and A2 denote their ages of the sisters on a particular day. Which of the following is correct about their ages on the day when they have the same stamina? Okay, so if they have the same stamina, right? So basically the function that they're talking about, it follows this curve. Stamina function, it essentially follows a Gaussian curve, right? So till 35 it is monotonically increasing, and after 35 it starts to decrease. This is the age and this is the stamina. They're telling me on a certain day they have uh, uh, let A1 A2 denote the ages of both the sisters on a particular day with A1 less than A2. So A1 is certainly less than A2. Which one of the following is correct? If they have the same stamina level. If they have the same stamina level, right? If they have the same stamina level, that basically means that this level must be same, right? And certainly they have told me that A1 is less than A2. So it could have been that both of them are of same age and they have the same stamina level, but they have already ruled that out. A1 is less than A2. So if A1 is here, where will A2 be? They have the same stamina level, A2 will be here, right? So I can see A2 is certainly greater than 35 and A1 is certainly less than 35. So A1 would be certainly less than 35 and A2 would be certainly greater than 35. So option B would be your correct answer of this question.
Yeah, so let's see the solution of this problem. Here, 5 symbols are there: x1, x2, x3, x4, x5. Probabilities are mentioned. You need to find out the best case coding efficiency. So when it is about best case coding efficiency, which coding scheme you need to use? There are two coding schemes, right? Shannon-Fano and Huffman. You are having Shannon-Fano and Huffman. Two coding schemes are there. When they are talking about best case coding efficiency, who will give the best case coding efficiency? Huffman will give. So whenever it is written best case coding efficiency, I have told you that for better results, although Huffman coding is complex, the circuit design will be complex here, but it will give you better efficiency. So when it is about best case coding efficiency, we will always go with Huffman coding. Okay, but let's just say some guy started from Shannon-Fano. We feel that he doesn't know whether Shannon-Fano will give best case coding efficiency or Huffman will give. So he started from Shannon-Fano. So what he would do? So he would start in this manner, that's at 0.4, 0.2, 0.15, 0.15 and sir 0.1. So let me divide in this manner, sir, because this will be 0.6, this will be 0.4. So 0, 0, 1, 1, 1. Here there are two rooms. So So 0, 1. Here there are 3 rooms, 0.15, 0.25. So again break it down, 0, 1, 1. And then again here break down 0, 1, 1. So this is the scenario he will be getting. So here 2 bits, here 2 bits, here also 2 bits, 3 bits and 3 bits. Right? Now h of x, can you find it out? Yes sir. H of x would be, so negative sign outward, log to 0.4 plus 0.2 log to 0.2 plus 0.15 log to 0.15 plus 0.15 log to 0.15 plus 0.1 log to 0.1. Right? So in that manner h of x you will be getting, which calculation I have already done. You can do it with your calculator. So answer would be 2.145. 2.145 bits per symbol we are getting. Bits per symbol. So this was the coding efficiency. And what is the average code word length? So if you do the calculation, 0.4 into 2 plus 0.2 into 2, 0.15 into 2 plus 0.15 into 3 plus 0.1 into 3. So average code word length would come out to be 2.25. Okay. And now if you find the coding efficiency 2.145 divided by 2.25, then he will get the correct answer actually. Not the correct, no, I guess it will get, it will be 95 something. Wait a second. 2.145 divided by 2.25. Yeah, 95.33. He would be getting somewhat around 95.33. In this coding scheme, he would be getting 95.33%, which would be a wrong answer. Okay, because we will see with Huffman, we will see that we are getting better efficiency. Okay, but some guy luckily he applied Shannon-Fano only. This is first guy who did in this manner. Other guy was, he also applied Shannon-Fano only, but this is how he did the division. How he did the division? So this was the scenario. Sir, here we also divided 0.6, 0.4. But sir, what do I do with this time? 0.4, 0.6. Right? So this is how he divided. 0, 1, 1, 1, 1. Here only one guy is there. Don't worry. Here 4 rooms are there. So we need to divide now 0.35, 0.25. So 0, 0, 1, 1. Both guys will be divided 0, 1. Both guys will be divided 0, 1. So now here if we see average code word length, 0.4 into 1, 0.4 plus rest all the probabilities are having length of 3. So 0.6 multiply with 3. Basically you do 0.2 multiply with 3, 0.15 multiply with 3, 0.15 multiply with 3, 0.1 multiply with 3. So what I did, 3 I have taken common, 0.2, 0.15, 0.15, 0.1. So what is the average code word length he is getting? 2.2. Okay, so what will be his coding efficiency? His efficiency would come out to be 2.2 divided by 2.145 divided by 2.2. 2.145 divided by 2.2. So here he will see that 2.145 divided by 2.2. So here he will see that answer is coming out to be 97.5%, which is correct. But again, if you want to avoid all this kind of scenario that sir, in this particular scheme I am getting better answer, here sir I am not getting better efficiency. If you want to avoid all these things, then there is only one guy who can help you, that is Shannon-Fano. So blindly go to Shannon-Fano. Okay. So this is just the playlist link. I just wanted to tell that you can study from here. I have given random variable, random process completely, threshold detector, quantizers, they are also available. Complete information theory is available. Complete coding is also available. Right. So a lot of content of communication system is available on YouTube. You can make the best use of it. And we are not blindly starting at let's start from Shannon-Fano coding. Why we need to do the source coding? What was the problem with the source coding that we were doing in digital communication? So in that manner we start. So surely you will love it. Okay, so you can study communication system. You can start your communication system from here. Yeah, so let's go to Huffman coding now. So what Huffman will do? Again, he will write down the probabilities in this manner only. 0.25, 0.15, 0.15 and 0.1. Okay. सही तो लिखा ना भाई. Yeah. Second one was 0.2. Sorry. This was 0.2. So adding both of them, it would become 0.25. So this 0.25 comes here. Rest all, this goes here, this goes here, this goes here, and rest everything is fine. 0.2, 0.15. Adding both of them, this would become 0.1. 0.35. This comes here, this goes here. 0.4, 0.25. Look, I cannot explain that, sir, how this method came. All these can be explained in comprehensive course, not in the solutions, right? If I keep on explaining, then solution would be of roughly around 50 hours, right? So I hope you understand this. So what we need to do, 0, 1, 0, 1, 0, 1 and 0, 1. So if I start for this particular guy, so how will I move? I will move in this manner. So what I am encountering? Only 1. For 0.2, how will I move? 0, 0 and 0. 0, 0, 0. For 0.15, 1, 0, 0. Right? 1, 1, then 0 and then 0. 1, 0, 0. Always we write down from LSB, right? And then for this guy, 0, 1, 0. 0, 1, 0. And for this guy, 1, 1, 0. 1, 1, 0. And you can see that any of the code is not the prefix of any other code. Like 1 is not the prefix of any other code, 0, 0 is also not the prefix. So yeah, this coding scheme is fine. And you can see that what will be the average code word length you will be getting. So 0.4 into 1 plus all the other code words are having the length of 3. So average code word length you will be getting same the way you did here, you will be getting 2.2. And the efficiency would come out to be 97.5%. So this would be the correct answer. Okay. So a lot of people would have clicked on this particular answer, which will be wrong. So the motive of this particular problem was that you should go with Huffman, not with Shannon-Fano, if they are asking about best case coding efficiency. If this question is coming in the examination, then they will never say that go with Shannon-Fano, because some guy can go with this particular method as well, and he can go with this particular method as well. So two possible answers are there, and both guys are correct only. Whatever Shannon-Fano said, he also followed the same thing. He also followed the same thing. It's just that he was getting a better coding efficiency because his division was different from this particular guy. Is that understandable to you? Okay. So yeah, best case coding efficiency means Huffman. Okay, then, and you can study communication system from here if you are preparing for 27, and if you just want to revise some topics or you want to make your topics better, then you can study for 26 as well. Okay, then yeah, let's move to the next one. Yeah, so let's solve this problem now. So what we need to find? We need to find small signal voltage gain. So usually when we used to find out small signal voltage gain, then V0 voltage used to be a node voltage. What I mean to say is that, let's just say this is a particular circuitry. Okay, let's just say this is V in, this is ground. Then they used to ask what is your small signal voltage gain. So here V0 was a node voltage, but now it is the potential difference, right? Let's just say this is V1, this is V2. So what is your V0 now? Your V0 is nothing but V1 minus V2. So what you are actually asked to find out? They are saying V0 by Vin you need to find out, but actually you need to find out V1 minus V2 divided by Vin. So this is your question. Okay. Now one thing I always say, drain and source have some toxic relationship. Always, if the question is coming on MOS, whether it is DC analysis or AC analysis, there would be some relationship in drain and source. You notice one thing, V1 is drain voltage, V2 is source voltage. Some relationship would be there. If you just keep on writing down the equation, then it will be difficult for you. But if you just see the circuit more carefully, what you would realize that, sir, if here there is I current, then sir, this I current will be divided into two parts. Let's just say this is I1, this is I2. Now sir, I1 and I2 both will be again added, and this current will also be I. Is that understandable to you? This current was I divided into two parts, again added, this current is also I. What does that mean? Sir, V2 could be written as, sir, we are doing the AC analysis, so they will be gone. They will be shorted, right? So what V2 would be written as? Sir, voltage drop would be somewhat like this. Current is flowing downward. So voltage drop would be somewhat like this. So V2 could be written as I into R0. And what about this, sir? Voltage drop could be written like this. So V1 could be written as minus I into R0. What does that mean? V1 equals to minus V2. There you go. Now your calculation will be very, very easy. So what is your target now? V1 equals to minus V2. So in place of minus V2, you can put V1. So now our question has become, we need to find out 2V1 by VE. This is our question now. Now what is V1? V1 is the node voltage, right? V naught is the potential difference, but V1 is the node voltage, V2 is also a node voltage. Now target is V1 by V in we need to find out, and then simply multiply with 2 and your job would be done. Just take care of one thing, they are asking magnitude. Okay. So let's get started. Can we see some equation here? Surely we can see the equations. This is minus V1. So can I apply the nodal at drain? Surely I can apply the nodal. I can write down the current. The current that is flowing outward. What is that current? V1 by R naught. Plus the current in the MOSFET. What will be the current in the MOSFET? We are doing the small signal analysis, right? So this will be shorted. This will become V in. This is your minus V1. So what will be the current here in the MOS? That would be, sir, GM V in minus V1. GM V in minus of minus V1. So what will be the current? Current would be GM VGS. So gate potential is V in and source potential is minus V1. So this will become plus V1 here. Plus there will be a current in this R naught path as well. I am applying the nodal here. So here one component of current is this, other component is this, and other component will be this. So what will be this current? V1 minus of minus V1. That means 2V1 by R naught. 2V1 by R naught. There you go. Job done. That's it. All the values we are given and our answer would be made now. So this is becoming 3V1 by R naught plus GMV1 equals to minus GMV. So what we are getting? 3V1 GMR0 V1 minus GMR0 V in. GMR0 value is given, that is 1. So from here V1 by V in we are getting as minus 1 by 4. So what will be the answer? Minus V1 by V in we are getting minus 1 by 4. Simply do the double, your answer would come out to be, gain is coming out to be simply the double of minus 1 by 4. Answer would be minus 0.5. Now I have sympathy for those people who have put the answer as minus 0.5. I have the sympathy, but only thing I can give you is sympathy only, not the marks. Because in the gate examination as well, it has happened a lot of time that they have given the common source configuration and they have asked you the magnitude. So always take care. If you are solving a problem of small signal voltage gain in the gate examination, you need to see whether they are asking the magnitude or the exact value. So magnitude we need to put, that would be 0.5. A lot of people would have put minus 0.5, I know. In a hurry, you would have put minus 0.5. But always take care. This thing has happened a lot of time. When I was a student, it used to happen with me as well. I used to put minus 0.5 as the answer. Okay, so always take care if they are asking magnitude or the exact value. Okay, so answer would be minus 0.5. More things we can learn here. You could have applied, what you could have applied here? You could have applied Miller's theorem as well. Like that would be complex actually, but I'm just telling one thing. Like if someone can think of it, this is the resistance R0, right? This is V1 and this is minus V1. Are you able to understand this point? So if I need to break this resistance, how I can break? From V1 to ground, I can break it like R0 by 2. This is your V1. And again, another R0 by 2 if I break, this is your minus V1. Now can you find out the potential of this point? Yes sir. V1 into R0 by 2 minus V1 into R0 by 2 divided by R0 by 2 plus R0 by 2. What it will come out to be? It will come out to be 0. So from V1 to ground, there is R0 by 2 resistance. From this V2 to ground as well, there is R0 by 2 resistance. So you could have applied the Miller's theorem here. Then you could have find out the voltage gain from here to here and from here to here. Right? This setup will be common source amplifier with the degeneration, and this setup would be common drain amplifier. Right? Although a complex, it would be a complex method, but I am just telling you that this is how you could have proceed. Well and good. Let's go to the next solution. Yeah, so this problem, I know a lot of people would have struggled here. I will try to give you the maximum of the concept, okay? Because the concept of ROC is not taught that much in depth. I know a lot of people study concept of ROC in a very surface level, whether it is for Z transform or it is for Laplace transform. If you need to see the in-depth concept of ROC, then you can go to this particular video. Okay, a very good video it is, 6 hours of video. There I have given the ROC concept for Z transform as well, Laplace transform as well. When we talk about Laplace transform, we talk about these poles, but we forget about s equals to minus infinity and s equals to plus infinity. When we talk about Z transform, we talk about Z equals to 0 and Z equals to infinity, right? But in the Laplace transform, we forget about these two guys, and these two guys are very important. This year or next year, whenever if they want to frame a good question from ROC, they will talk about these two eyes. In this question, the discussion is around these two people only, s equals to minus infinity and s equals to plus infinity. So in-depth concept, if you want to learn, already you know most of the things, you can spend 1 or 2 hours, you will be able to understand the in-depth concept of ROC from this particular video. Already you know most of the things, so let's get started now. Okay, so this is your h of s. Sir, where is the poles? Sir, poles I can see at -1, -2, -3 and -4. But I always say check at 3 points for sure. Minus infinity, plus infinity, and check at 0 as well. But 0 is surely not the pole. So let's not talk about 0. So we should always at least check at these 2 points as well. Sir, I could see the pole at -1, -2, -3, -4. But what about minus infinity and plus infinity? Are we having poles at minus infinity and plus infinity or not? So that we need to check. Right? So let's write down the h of s again, and then we will do the analysis. So h of s is e to the power s minus e to the power minus s divided by s plus 1, 1, 2, 3, 4. So sir, if I make the s plane, what I can see? Sir, I can see the poles at -1, -2, -3, -4. Now if someone is solving the problem right from here, then what he would do? He would say that, sir, this could be my ROC, so it could be anti-causal. Sorry, if this is your ROC, then sir, this would be causal, and if this is the ROC, then it would be anti-causal. And sir, if this is the ROC, this is the ROC, this is the ROC, that means it would be your non-causal. But you forgot to discuss about plus infinity and minus infinity. Can you find out the value of h of s at plus infinity? At plus infinity, what will happen? E to the power infinity, right? What will happen to this? 0. Infinity, 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 infinity by infinity. What I can do? I can apply L'Hopital rule, right? How will I L'Hopital rule? Look, s is going to infinity. That means s is very large. So this 1 can be ignored, right? 2 can also be ignored, 3 can be ignored, 4 can be ignored. S is going to infinity. I'm not putting the value of s. I'm just saying that if s is very large, then 1, 2, 3, 4 all can be ignored. So can I make, when your s is tending to infinity, then your h of s could look somewhat like this. If s is tending to infinity, this will go to 0. So I'm ignoring this guy. I'm only putting e to the power s. This is going to infinity. So let's have some patience here. But this will be left. E to the power infinity will be left for sure. 1 will be gone, 2 will be gone, 3 will be gone, 4 will be gone. Because s is very large. If s is very large, this will be 0. I don't need to write it down. If s is very large, then s plus 1 can be replaced nearly equals to s only. So all these guys will become s. This will also become s, 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 s. This will become s to the power 4. If I put infinity here, this will become e to the power infinity, which is infinity only, and this will also become infinity. So it is becoming infinity by infinity. Why I did so? Because now the expression is becoming much more simpler. Now I can apply L'Hopital rule. What does this rule says? That you keep on differentiating until you are not getting infinite by infinite form. So if I differentiate one time, what I will get? 4s cube, infinite by infinite form. Again I differentiate, what I am getting? 12s square. Right? Again I differentiate, what I am getting? 24s. Again infinite by infinite. Again I differentiate, what I get? 24. So after differentiating a lot of time, after differentiating 4 times, this is the scenario I am getting. Now here I need to put the limit of infinity. So if I put s tending to infinity now, if I put s tending to infinity, what I am getting? Infinity. That means in this particular expression, if you are putting s equals to infinity, you are getting your transfer function to be infinity. What is the definition of pole? What is the definition of pole? At the pole, your transfer function would go to infinity, right? Why you said -1 is a pole? Because if you put -1 in place of s, what will happen? This will go to infinity. If you put -2, it will go to infinity. If you put -3, it will go to infinity. If you put -4, it will go to infinity. So when I am putting s equals to infinity, then your h of s is going to infinity. What does that mean? If I put s equals to infinity here, infinite by infinite form was there, then I differentiated, I got to know that answer is actually coming out to be infinity. So when I am putting s equals to infinity, my transfer function is actually going to infinity only. What does that mean? That means s equals to infinity is one of the pole for sure. S equals to infinity is one of the pole for sure. So you said that, sir, -1, -2, -3, -4 are the pole, but x equals to infinity is also one of the pole. Is that understandable to you? Okay, so you forgot about this particular guy. Similarly, s equals to minus infinity will also be one of the pole. S equals to minus infinity will also be one of the pole. How is that so? You put minus infinity here, e to the power infinity, it would become, again infinity it would become, again you do the same thing, apply L'Hopital rule. This guy will be becoming 24, downward it will be becoming 24, upward e to the power minus s will be left. At e to the power minus infinity, this will be 0, so this will be gone. So upward e to the power minus infinity will be left, and negative sign will also be there, and downward 24 you will get. And now you put e to the power minus infinity here. In place of s, you put minus infinity. What you are getting? E to the power infinity. That means what you are getting? Infinity only. That means when you put s equals to minus infinity, then also it is becoming infinity only. So if your transfer function is becoming infinity at any point, that point would be known as pole. So when I put minus 1, minus 2, minus 3, minus 4, I am getting my transfer function to be infinity. That means these guys are the pole. This is also one of the pole, and this is also one of the pole. So we are having 6 poles here. These are known as finite pole, they are infinite pole. But infinite pole plays a very important role in terms of ROC. Minus 1, minus 2, minus 3, minus 4. These are the poles. Along with that, we are having a pole at infinity as well, and we are having another pole at minus infinity as well. At minus infinity as well. Now, what all ROC I can have? Sir, this ROC you can have. This ROC you can have. This ROC you can have. Sir, this ROC you can have. Sir, this ROC you can have. And sir, this region of convergence you can have. In all the region of convergence, 1, 2, 3, 4, 5. All are bounded, no? All the region of convergence are bounded by poles. This is the pole at infinity. This is the pole at minus infinity. All the region of convergence, all the ROCs are bounded by the poles. This is minus 1, minus 2, minus 3, minus 4. All these are bounded by the poles. That means here also you will get non-causal. Here also you will get non-causal system. Here also non-causal. Here also non-causal. Here also non-causal. Here also non-causal. So you can never get anti-causal or causal. You thought this would be causal. You thought, sir, this could be causal, but actually it came out to be non-causal only because of the pole at infinity, because of the pole at minus infinity. You thought, sir, this could be anti-causal, but it also came out to be non-causal. So all the systems, whatever the system that you are going to get from here, all will be non-causal. All will be non-causal. That means the system can never be anti-causal or causal. The system can be causal? No. If the system is stable, it has to be non-causal. So where the system will be stable, this will be stable. This will be a stable system. Why is that so? Because it is including the j omega axis, right? So if it is including the j omega axis, that means this will be the stable system. If this is the stable system, that means it is surely non-causal. So if the system is stable, it has to be non-causal. The system will be surely stable? No. Why no? Because, sir, if this is the ROC, unstable. This is your unstable. Unstable. This is also unstable. This is also unstable. And this is also unstable because they are not including the j omega axis. So from this particular expression, we can get 5 kind of systems. What we can get? 5 kind of systems. All will be non-causal and only one of them will be stable. So that's the conclusion you can make from here. From this particular expression, we can get 5 kind of system. All will be non-causal and one of them will be stable. So from here, this will also be gone. So answer will be B and D. I tried to give the maximum concept, but yeah, if you need more in depth, you can surely watch this particular video. The kind of depth you will get in this particular video, you have seen nowhere, neither in books nor in lectures. Okay, so like this is one of my favorite creation of signal system at least. Let's move to the next one. Yeah, this is very straightforward. So dual slope ADC circuitry you would already know. So first V in is connected, then V in will be integrated for T1 time, and then Vref will be integrated for T2 time, right? So how much is T2 time? T2 time is how much is T2 time? So what is the clock frequency? 50 kilohertz. That means what is the clock time period? Clock time period is 1 by 50 millisecond, right? And number of clock pulses counted during the deintegration phase was 750. So number of clock pulses, that means 750 clock pulses came. This is one clock pulse. Then this is another clock pulse. How many clock pulses are there? This is one clock pulse. This is two clock pulse. This will be third clock pulse. So 750 clock pulses were there. That means how much time did it take? So it took 750 multiply with 1 by 5 millisecond. So deintegration took this much of time. De-integration took this much of time. So T2 value you know, T1 value you know, Vref value you know. From there you can get the value of V in. That will come out to be 3 volt. Can we do? Shall I do the calculation? I think you can do it on your own. 20 millisecond. Vref is 4. 750 by 50. 150 millisecond. This and this get cancelled out, and you are getting this 2 0 and 0 60, and it is coming out to be, अरे भाई ये क्या हो रहा है, 30 volt or 3 volt. Wait a second, wait a second. $750 divided by 150. 150, okay. 1 by 50 it was. Okay, 1 by 50 it was. So yeah, so it would be 15 only. Okay, so you can do the calculation, it will come out to be 3 volt. Okay, it was 150 here. It was 1 by 50. I have put 1 by 5, so it would be 1 by 50, and this answer would come out to be 3 volt, which is very simple. Let's go to the next.
The transfer function of a linear time invariant system is given by this. The system is initially at rest and is subjected to a unit step input at t equals to 0. If y of t denotes the output of the system, then the value of dyt upon dt at t equals to 0 is equals to what? So y of t is the output of the system, and we are providing a unit step input, right? So in Laplace domain, what is the output? Because essentially what they are asking me, the initial value of the differentiation or the derivative of the output. So I certainly know that basically what they are asking me is to calculate the initial value of the derivative of the output, that is y dash of t. In Laplace domain, it is x s into y of s. That is what the value of the derivative in Laplace domain is. So essentially, can I apply the initial value theorem here? Certainly yes. Why I can apply the initial value? Because I can certainly observe that this is a causal system. Okay, this is a causal system. That's why initial value theorem will be applicable here, because the order of the denominator is greater than the order of the numerator. Okay, certainly, like this is an LTI, and I can see that this transfer function is causal. Okay, so yeah, that's why this Laplace transform, that's why this initial value theorem will be applicable. So what will be y dash of 0 plus the value? This will be equals to basically limit as s tends to 0, s into what? This is the Laplace transform, right? I have to do s into the Laplace transform of y dash of t, that is s into y of s, that is actually s into y of s. Okay, so this will be equals to limit as s tends to 0, s square into y of s, right? That is what the value is, right? Okay, so yeah, now what is y of s? Y of s will be basically, so I know the transfer function definition, g of s would be the ratio Laplace transform of the output upon Laplace transform of the input, y of s upon x of s. Now the input is basically unit step, so your y of s would be simply equals to uh, g of s by s, right? That is basically 3s plus 2 upon s into s square minus s plus 2, correct? Now we will apply the limits now. So if I multiply s square, what will happen? One s will be cancelled, one s still will be there, right? Yes. T equal to 0, applying the input. So this will be equals to basically, if I give s equal s tending to 0, so s square into my y of s, so my y dash of 0 plus s square into y of s into 3s plus 2 upon s into s square minus s plus 2. So essentially, obviously don't forget limit as, okay, sorry, but initial value theorem is not 0, right? It is going to infinity. Sorry, just I know you guys are screaming at me, sir, infinity hoga, infinity hoga. हाँ, so मेरे से भी होता है, right? Sometimes it happens. So I actually meant here infinity, right? Not 0. So how do you remember? So if I have 0 here, this will be infinity. If I have infinity here, this will be 0. That's how I remember the final value and the initial value theorem. Okay, sorry. Yeah. So 1s will be cancelled essentially, right? And of course s is tending towards infinity. If s is tending towards infinity, I will only consider the coefficients of the higher order terms in both the numerator and the denominator. I hope you know how to solve the limits. So this will be 3s, like the coefficient of s square here is 3, and the coefficient of s square in the denominator, that is the highest coefficient, highest order coefficient, that is 1. So 3 upon 1, this will be 3. So 3 will be your answer for the question.
Yeah, this is also straightforward problem. Usually we are comfortable with the base 2, base 8, base 16. So when I need to move from base 2 to base 8, what do? Sir, 8 could be written as 2 to the power 3. So what I will do? 3, basically, let's just say this is a number which is given in base 2. I need to convert it into base 8. What I would do now? Sir, 8 is 2 to the power 3. So 3 bits together in action I will take starting from LSB. 3 bits, 3 bits, and here also 3 bits. That means next bit would be 0. Starting from LSB, 3 bits at a time into action I will take. Now I will calculate its decimal equivalent. So what will be its decimal equivalent? 2, 1, 1, 2, 4. This is the scenario, right? So this will be 3. Now 1, 2, 4. This will be 7 and this will be 2. So this will be your base 8 expression. So similarly, we need to do for 3, 9 and 27. So what they are saying? Base 3, base 9 and base 27. 3 could be written as 3 to the power 2. 27 could be written as 3 to the power 3. So here I will take 2 guys into action at a time, and here I will take 3 guys into action at a time. So what is the number given? 2, 1, 1, 1, 0, 1, 2. Let's start writing from here. 2, 2, 1, 1, 1. Then 4 times 2. Then 1 times 1. Then 0. 3 times 1. And then 2. So for converting into base 9, what I will do? I will take 2 guys into action at a time. So 22, 11, 21, 22, 12, 10, 11 and 2. That means here 0. Now this is in base 3. What is the meaning of base 3? The first one will be 3 to the power 0, second one will be 3 to the power 1, and third one will be 3 to the power 2. So 1, 3, 9. So 1, 3 8, 1, 3, 4, 1, 6, 7. In that manner, you can keep on doing 8, 5, 3, 4, 2. This is what you will get. Okay, so this you can get. This will be the first option that would be correct. This option would be correct. And then which option would be correct? After that, you would see for 27 you need to do, that means 3 bits at a time you will take into action. 3, these 3, these 3, these 3 and these 3. So what is the different number here? Last number is also different only. So let's start from here. 1, 2, 2. So 1, 3, 9. So 9 plus 6 plus 2. So what you will see here, 17. So 17 we are getting in this one. So answer would be this, correct. Okay. So only like if your options are mentioned, you only solve for one time and you would be able to match the option. So answer would be option C. Okay. Let's go to the next question. I hope you understand this concept. This was the easy question only. Yeah. So let's see the solution of this problem. This is a good question. Okay. Very good question actually. So let me tell you one thing, like when we study normal incidents, in normal incidents what we study, that sir, wave will be normally striking the plane and then it will be reflected back. So sir, incoming wave, reflected wave, incident wave, reflected wave, sir, both superimposing will make the standing wave pattern. So this is what we study. Similarly in the transmission line as well we study that sir, in transmission line sir, there will be a load. Then sir, I will excite it with some voltage source, a voltage wave will come, then it will be reflected back. So this is how the voltage wave was coming, incident voltage wave, reflected back, both superimposed will make the standing wave pattern. So this is what we study in transmission line. In both of the cases, normal incidence was there, no? Normally wave, this is our load. You can call it plane of incidence or you can call it load as well. So in both of the cases, wave was coming, got reflected back, both superimposed, make the standing wave pattern. Right? We talk about that rope experiment as well, that on one of the node of the rope, what you will give? You will give a pulse. So from the wall, that particular pulse will come back, and if you keep on giving the pulses, what will happen? The wave will feel like a standing wave pattern. I hope you know what is standing wave pattern, right? But in normal incidents, we don't discuss it. Or do we discuss it? We discuss it in oblique incidents as well when we study waveguides, right? In waveguides, what really happens? The wave will be entering inside the waveguide at some angle. It will be making the standing wave pattern as well, and it will be traveling in a certain direction as well. So let's talk about it. So let's talk about oblique incidence now, where I have given this particular concept. If you want the in-depth of this particular concept, along with that you want to understand the actual meaning of total internal reflection. This is not the total internal reflection, that's sir, this is your rarer medium, sorry, this is your denser medium, this will be a rarer medium, then sir, the wave will be making an angle of your transmission angle could be 90 degree. So this is known as total internal reflection. This you used to study in 12th class, not in engineering. In engineering, if you want to study using the wave phenomena, then you need to study this particular video. Okay. So in this video, I have given good enough concept. Here I have talked about this standing wave pattern as well. Along with that, I have talked about this total internal reflection as well. But here in this video only, I will give you the solution of this particular problem. So let's talk about our scenario. What is the scenario? That sir, y equals to 0 plane is there. This is your y equals to 0 plane. That means this has to be y direction, right? Is that obvious? It could be x or it could be z, whatever it is, I don't care. Now wave is traveling in positive y direction. Just one second, guys. Yeah, so what I was saying, so wave is traveling like this, making an angle of 30 degree with the plane. Okay, here this line is wrong actually. Wave is traveling in positive y direction. This line is wrong. I will modify it. As of now, the test is not live, so I can modify this particular line. The wave is not traveling in positive y direction. No? Wave is making an angle of 30 degree with this particular plane. So language could have been better. I will modify the language, don't worry. Yeah, so it will be making an angle of 30 degree. Here it is making an angle of 30 degree. Now this wave has two components. First one is this, other one is this. This wave is having two components, no? Let's call this component as, since this is perpendicular to the plane, so I am calling it, this is your incident wave and it is perpendicular to the plane, so that's why I am calling with the perpendicular sign, and this let's call with the parallel sign. Now what will happen? It will be reflected back as well. Since it is reflected back, then it will also have two components. Reflected, parallel, reflected, perpendicular. In normal incidents or in transmission line, what was happening? Incident, reflected back. This guy got superimposed. What did it make? Standing wave. Reflected, incident. Superimposed, what it will make? Standing wave. But these two guys are in the same direction. What they will make? They will make the traveling wave. I hope you know these equations. Let's just say there is a wave traveling in a z direction. I am taking a random wave which is traveling in z direction. So can I write down the electric field equation in this manner? I am only talking about the phasors. Okay, I am only talking about the phasor form. So E naught e to the power minus beta z, and electric field is in there in y direction. So Ay cap. When it was reflected, then also the magnitude was E naught only. Okay, I am saying that magnitude was still E naught. Direction also did not get changed. Ay cap only. Now it is again traveling in z direction only. Same direction. Basically, you can change the magnitude here. Like you can call it E naught 1, you can call it E naught 2. And this is some other wave. Both are traveling in z direction. This is what I am saying. And electric field is dancing in y direction. Now what I can do? I can take e to the power beta z common. E to the power minus beta z as common. And this is the direction of dancing. Now what this could be? This could be some E naught value. Some E naught value e to the power minus beta z Ay cap. What is this? This is the equation of traveling wave. This was the equation of traveling wave. This was the equation of traveling wave. This is the equation of traveling wave. That means if two waves are traveling in the same direction, then they will make the traveling wave only. It is pretty obvious, no? Let's just say some wave is traveling like this. Then I add another wave which is traveling in the same manner. It might be having different amplitude. It could be having different direction as well. What do I mean by direction? Not the direction of wave. I'm talking about the electric field. Electric field can have different direction, but wave are traveling in the same direction. If both waves traveling in the same direction, they might be having different amplitude, but still they will end up making a traveling wave only, no? Right? And we have seen it, like it is pretty obvious thing. But traveling in opposite direction, they will make the standing wave pattern. How they will make? From the rope experiment, I can explain. From the equations as well, I can explain. So let's try explaining with respect to equation. So one wave is E naught e to the power y traveling in positive z direction. The other wave is having everything same. Okay, everything is same, magnitude same, direction same of electric field direction is also same, but the wave direction is different. This was traveling in positive z, this is traveling in negative z. So what I can do now? I can take, sir, E naught ay common, e to the power minus beta z plus e to the power plus beta z. What it will become? Sir, divided by 2 multiply by 2. So 2 E naught cos beta z ay cap. So your wave is the function of z. That means it is the function of space. If it is the function of space, what does that mean? It is the standing wave. It will surely have time term as well, right? I am just suppressing e to the power j omega t. This has been gone. That means we are talking about phasor form here. But in the phasor form, you got to know that it is actually the combination of both is actually becoming a function of space. Is that understandable to you? This will have maxima as well, this will have minima as well, right? Standing wave in a great manner we have studied. In transmission line we can study it, right? In transmission line on YouTube only I have uploaded a video. There we have studied about standing wave, how it is generated, what is the actual meaning, what is the mathematics behind it, everything we have discussed. So now this point is clear to you. What is the point that I wanted to tell? The point that I wanted to tell is that in this particular direction, in this parallel direction, parallel to the plane, what we will get? We will get traveling wave. Both combined, we will get traveling wave. But in the direction of y, it could be positive y, it could be negative y. In the direction of y, what I will be getting? I will be getting standing wave. So these are our first two options. First option says that, so there is no net propagation of total wave in medium 1 in the y direction, but a standing wave is observed. Yes, sir. In the y direction, this wave both combined will make the standing wave. And what about this? Sir, there is net propagation of total wave in medium 1 parallel to the interface, which is y equals to 0. What is the interface? This is your interface. So parallel to the interface, yes, there is net propagation, that will be your traveling wave. So propagation is there in parallel to the plane. It could be x direction, it could be z direction. I already know, sir, this is your positive y, but what will be your x, what will be your z, you don't know. So that's why I did not write down in the direction of x or in the direction of z, whatever it could be, right? So I just said that parallel to the plane. Is that understandable to you? So I hope it is understandable. Now we need to find out the phase velocity. What is the meaning of phase velocity? And what is the meaning of group velocity? Let's just say this is the wave I am having. This is the wave I am having. What will be the envelope of this wave? If you have studied communication or basic mathematics, if you have studied, then you would know that this is the envelope of your wave. Now, how this envelope is moving, that is decided by group velocity. Now, if I take a particle here, how this particle is moving, that is decided by phase velocity. You can go to YouTube and type phase velocity and group velocity animation. You will understand the meaning. But here only I am telling you this is the meaning of group velocity and phase velocity. Let's just say on this envelope I take this particular point. On the envelope I am taking this particular point. How this point is moving on the envelope, that will be decided by group velocity. On the wave, a random point, how it is moving, that is decided by the phase velocity. And I hope in waveguide you have studied that phase velocity could be greater than c, but group velocity will always be lesser than c. Because this particle is not an energy. No, it is not an energy. What is energy? This is the energy. These peaks are the energy. Less than c. So these are the energy. This is the actual energy. This particle is not an energy element. An existing energy element can never have velocity greater than c. But an illusion, what do I mean by illusion? Have you seen laser light? You might have seen laser light, no? So from the laser light, when you throw a particular light, what happens? On the wall, you will see a red dot. You will see the light as well, and you will see the red dot as well. This red dot is not an energy, right? When you move this light, let's just say I'm moving my laser light by a minute amount, what will happen? This red dot will move very fast, but light will reach later on. What is the speed of light? Speed of light is c. This red dot reached even before the light. That means this red dot is having velocity greater than light, but this is not a actual particle. This is just an illusion. Look, these detailed things you can get in the comprehensive course, but here I cannot explain all these things. But in waveguide, you would have surely seen, if you have studied, that phase velocity could be greater than c. Phase velocity is the velocity of particle, but group velocity is the velocity of wave packets, or you can say combination of all the waves. So group velocity shows the velocity of an actual wave, but phase velocity shows the velocity of a particle. And if the wave is only one, then phase velocity and group velocity would be same. And it has to be a plane wave as well. For plane wave, if there is only one plane wave, then phase velocity and group velocity will be same. Till the point of waveguide, we never talk about group velocity. We only say phase velocity only, because that was our group velocity actually. But when we go to waveguide, there what will happen? Standing wave pattern will also be observed, and traveling wave pattern will also be observed, right? So there packets of wave would be observed, all combined. One guy will show group velocity, other guy will show phase velocity. All these are actually quantum mechanics, okay? Quantum mechanics combined with EC, or not EC, only electronics. Quantum mechanics combined with electronics give birth to engineering physics. So when I was a student, I was actually very much interested in engineering physics, but I did not get a good JEE rank. So at my JEE rank, I was not getting engineering physics. Yeah, but a lot of people from engineering physics write down GATE examination. I know at least 5 to 6 people in GATE 2022 who was the AIR1 of EC. EC AIR1 was from engineering physics, Ram Balaji Bhaiya from IIT Madras. Okay, I have talked to him, like he was working with me only, we were in the same company. So he was a brilliant guy. He's a brilliant guy actually, like very down to earth. You discuss any doubt, he will, like, still I talk to him only. Like he's the first person when I feel like that I'm getting a particular doubt, I will be approaching him, especially in communication, especially towards the communication side. For analog, I have a lot of people, but for communication, or it might be signal system, for that frequency domain part, I will so surely approach him only, even today. So yeah, so engineering physics, so all this depth is not required for you. For examination purpose, what you need to understand, that your phase velocity could be greater than c, group velocity could be less than c. That's it. This is what you need to understand for your examination purpose. Is that understandable to you? Okay. How it would be greater than c? What is the meaning of phase velocity being greater than c? All you don't need to understand. If someone asks you, sir, what is the meaning of phase velocity greater than c? That means this is not the velocity of a physical particle. Okay. Phase velocity is just a velocity of the particle of a wave. So actual physical energy is this particular peak, not these particles. Someday later on, I will discuss it in detail. But as of now, let's go to our solution. What we need to find out? We need to find out the phase velocity. So if someone who is thinking that, sir, how the velocity could be greater than light? So sir, this should be the answer, but it would be wrong. Okay, what we need to find out? Phase velocity. What is the formula, sir? Omega by beta. But is this formula correct? Beta will have two components. This is your resultant beta. Making an angle of 30 degree here, that means this angle will also be 30 degree, this angle will be 60 degree. So beta is having two components. This component would be beta cos 60, and this component would be beta cos 30. This component is actually resulting in standing wave. This is the component which is resulting in traveling wave. No? Say yes or no? So here you will write down beta or beta cos 60. Beta cos 60. Like traveling wave, if I ask you what is the velocity, what is the phase velocity of standing wave? What is the phase velocity of a standing wave? This is how we represent our standing wave. Do you remember the animation which I gave when I was explaining transmission line? What kind of animation was there? Or you think about that rope experiment. What it will feel like that? It will feel like that, sir, this point will be going up, going down, going up, going down, going up, going down. If I ask you what is the velocity of this point in this direction? Standing wave, it is standing. It will feel like that the wave is standing. That means wave is not moving. According to you, wave is not moving there. So what you will say here? That sir, phase velocity is 0. So for a standing wave, phase velocity is 0 if it is not moving. Actually, it is moving. Like there was a forward traveling wave, there was a returning wave as well. Both combined make standing wave. So you feel like that the wave is standing, but actually there is a forward traveling wave. Actually, these two guys are there. No. In the standing wave which you are observing, there are two components going forward, coming backward. They are actually making the standing wave. So actually, wave is moving. So their velocity would be defined. This will have some particular phase velocity. This will have particular phase velocity. But if both combined, I ask you that what is the total phase velocity of this standing wave? You will feel like that, sir, one particle. Let's just say I talk about this particle is going up, going down, going up, going down, going up, going down, going up, going down. So what you will say? Phase velocity is 0. So for standing wave, phase velocity is 0. This component is not resulting into phase velocity. This is not resulting into a traveling wave. So in traveling wave, only this component is resulting. So in place of beta, I will write down beta 60. What I will get? Cos 60 is 1 by 2. So 2 omega by beta. What is the formula of beta? Omega by c and root epsilon r. So omega by c and root epsilon r. Simply I am putting the expression here. Omega by c. Wait a second. Right? Just put the expression here. 2c by epsilon r you are getting. So what it would be? Under root 2 of, because epsilon r is 2. Epsilon r is given, that is 2. So it would become under root 2 of 3. So 1.414 into 3. So under root 2 of 3 only you can do. And you will get the answer. 4.24. So what is the answer we are getting? This is the answer we are getting. 1 to 4 are the correct option. A great question. And I strongly recommend watching these videos, and some one shot video I also uploaded on transmission line. So people actually don't study in that depth. AIMT is like very underrated subject. And last year it was not asked in a good amount as well. So people are actually skipping AIMT. But some good concept, if I want to frame level best problem of EC question paper, then AIMT would be the first subject. Because in AIMT I can frame those kind of problems which could not be solved even by the educators. I am talking about the IT professor, okay? I am means when I am the question paper setter. Okay, when I am the question paper setter, then the guy can frame a lot of good questions from AIMT. Yeah, so this was the problem. I hope you would have enjoyed it. I hope you would have understood a lot of new things here. Okay then, and I would highly recommend watching this particular video. There I have explained by mathematics as well. Along with that, we are talking about TIR as well. Okay, yeah, thank you. Yeah, so let's see the solution of this one. So I know you might not have studied this particular concept. Okay, because you guys would be confused, sir, what is the meaning of direct band gap semiconductor? If I already know the meaning of direct band gap semiconductor, then what is the meaning of this recombination is radiative? Radiative recombination means it will be throwing light. Okay, non-radiative means it will be throwing heat. In direct band gap semiconductor, you would know that, sir, light is thrown. But if the process is 100% radiative, it is 90% radiative. Sir, what you are talking, we are not understanding anything. So we have uploaded complete EDC absolutely for free on YouTube. It is completely there. You don't need to watch the complete EDC. You have already studied it. You have studied it from a good resource. I appreciate it. But in optoelectronic devices, this particular lecture is there of 4 hours, 14 minutes. You don't need to watch it completely. Go to this particular timestamp. Here I will be discussing about direct band gap, indirect band gap. Like I have already discussed in basic semiconductor physics, but here I am again discussing it. So direct band gap, indirect band gap, what is the meaning of radiative recombination, non-radiative recombination? Sir, here energy band gap is 0.5 electron volt. You are giving 2 electron volt of energy. 5 electron volt is the gap. Sorry, 0.5 electron volt is the gap. We are giving 2 electron volt energy. That means particle will be reaching here. So when it is falling back, what is this transition is known as? Transition within the band. So this will release the heat. When the transition is band to band, it will release light. So only 0.5 electron volt. We will be getting the light corresponding to 0.5 electron volt out of 2. Total energy is, total power was 20 milliwatt. 20 milliwatt. Out of that, only 90% was radiative. And we will get the power corresponding to 0.5 electron volt only out of this 2 electron volt, because 1.5 electron volt will be produced in heat. So this will be your answer. There you go. You solve this particular calculation and you will get the answer to be 4.5 milliwatt. Okay, sir, how this came? All these things in 1 hour 3 minutes for different kind of conditions. I have taken direct band gap as well, indirect band gap as well, radiative recombination as well, non-radiative recombination as well. 4 questions, all the concept absolutely crystal clear it would be, and very high probability that it could be asked in GATE examination in near future because it is given in Niemann. Okay, in standard books this concept has been mentioned, so it could be coming any day in your examination. Okay, any day it could be coming, very soon it could be coming. Okay, so although the answer of this particular problem is 20 millivolt, 90% is radiative, I need to talk about the light. 0.5 electron volt only will result in light, and out of 2 electron volt. So 0.5 divided by 2, 90% is radiative only. If it was 100%, then this particular factor would not be there. Answer would have been 5 millivolt. But if someone has missed this 90%, he would have clicked on 5 milliwatt. But answer would be 4.5 milliwatt because of the 90%. Only 90% is there. Like out of from here, whatever the light should have been, like from here we will be getting the light, no? But only 90% of this particular component will result in light. 10% will still result in heat only. So if you are making the transition from band to band, you are expecting light. But 90% of the time you are getting light, in 10% you are getting heat. So you go to this particular video, you watch this particular portion. The concept will be crystal clear. Okay then, yeah. Let's move to the next one. Yeah, so let's see this one. This is easy question only. You need to find out the value of I. Okay. So what is I? I is minus infinity to infinity x of omega e to the power minus j omega t d omega. Can you see the? Can you remember this formula now? But here there was plus j omega t, right? X of omega e to the power j omega t d omega 1 by 2 pi. Well and good. Okay. So what do you need to do? 2 pi x of t equals to minus 1 you need to put. That's it. Right? 2 pi x of t, in place of t you need to put minus 1. And what is your x of omega? X of omega is nothing but sinc square 2 omega by sinc square 2 omega by pi. So from here can you find out x of t? Surely you can. And then just put t equals to minus 1 and your job would be done. So do you remember this formula? A triangle t minus center upon width of one side, that would be a tau sampling square omega tau by 2. When sampling should be converted into sinc, then what will happen? If sampling is converted into sinc, then what will happen? Sampling means sine omega and sinc means sine pi omega, right? So it would be divided by pi. So this would be sinc square omega tau by 2 pi. So what is the value of tau by 2 pi? That is 2 by pi. So value of tau is coming out to be 4. So a triangle t minus center, that would be 4a sinc square, in place of tau we need to put 4. So that would be 2 omega by pi. So this is the scenario we are getting. Sinc square 2 omega by pi, our criteria. A and A is getting cancelled out. So our answer is coming out to be 1 by 4 tri t by 4. Right? How it can be broken? It can be broken into 1 minus mod of t by 4. In place of t you need to put minus 1. So what you are getting? 1 by 4 into 3 by 4, and then you need to multiply with 2 pi. This will be your final answer. So let's do the calculation. 3 by 16 into 2 into pi. So 1.178. Answer is coming out to be 1.178. Okay, so simply you just need to know this particular formula. I hope you know it. If you have studied signal system, then at least you know this particular thing. Triangular function a tri t by tau, a tau sampling square omega tau by 2. We remember in terms of sampling we can convert it into sinc. So this was sinc given, we converted it into sinc. Then this is the scenario we were getting. We just compared it now. What we compared, that we need to get it tau by 2 pi should be equals to 2 by pi. So from there tau value we are getting 4. So again we put the value and we saw this expression we are getting. Our matter of concern is sinc square 2 by 2 omega by pi. So a and a was getting cancelled out. So answer, this is something that we are getting. So our x of t is, this is our x of t. So x of t was 1 by 4 tri t by 4. In place of t I need to put minus 1. This could be opened as 1 minus mod of t by 4. In place of t, I just put -1. So this will become 3 by 4. 1 by 4 into 3 by 4 multiplied with 2 pi. We are getting the answer of 1.178. So I am solving all the problems roughly because this is the solution video, not the concept video. No, so solution video it is, right? So we can solve it roughly as well. Let's go to the next. Yeah, this is very straightforward. Amplitude of the fundamental frequency component and average value of A, and A be the average value of the signal. So very straightforward question, very straightforward. So cos square t plus cos square 2t plus 2 cos t cos 2t. So what this would become? Cos square t, 1 plus cos 2t by 2, 1 plus cos 4t by 2, 2 cos A cos B. So cos A plus B plus cos A minus B. Cos A plus B, why I am putting 2 here? So 2 cos A cos B is cos A plus B plus cos A minus B. So what you are getting? 1 by 2 will become 1 cos t plus 1 by 2 cos 2t plus cos 3t plus 1 by 2 cos 4t. 1 by 2 cos 4t, 1 by 2 become 1 by 2 cos 2t, 1 by cos 1 cos 3t. So what you can see here, this is the average value. These will have 0 average value, 0 average value, 0 average value and 0 average value. So average value here is 1. So what is the value of A? That is 1. And what is the amplitude of fundamental frequency component? That is also 1. So H plus A, Himanshu Agarwal. Okay, H plus A, Himanshu Agarwal is 1 plus 1, 2. Right, so answer is 2. Okay, well and good. So here I will change the limit from 2 to 2 I will put. Okay, so answer is 2. Yeah, let's go to the next one. Okay, no need to make the solution video as well. Simply the Maxwell equation. This is the Maxwell equation, this is the Maxwell equation, this is the Maxwell equation. The only point is I just wanted you to revise the Maxwell equation. Along with that, I wanted you to remember the names as well. These were the Gauss law, del dot E, del dot B. When it comes to curl, so first curl was given by, electric field curl was given by Faraday, and this magnetic field curl was given by, first Ampere came into action, then Maxwell did the modification. Okay, and time varying magnetic field will result in space varying electric field. Time varying electric field will result in space varying magnetic field. That also is clear to you. So I just wanted you to revise the Maxwell equation. That's why I framed this particular question. Okay, let's go to the next one. Yeah, so looking at the concentration plot, what you can see, from this is your P side, this is your N side. From P side, some holes are being injected, and from here some electrons are being injected. What does that mean? It is surely forward bias. Directly it is visible, right? In reverse bias, the concentration plot would have been somewhat like this, but it is forward bias. The plot is like this. So this is forward bias, that's for sure. So there is no meaning of a reverse bias. Now what will be the supply? How would you find out the supply? For the supply, you can see that here the concentration is 10 to the power 6 and P and Xn value is given 10 to the power 9. So concentration from 10 to the power 6 to 10 to the power 9 it has become. What was the formula? So concentration at the edge of a depletion. What that would be? P and Xn. That would be equals to whole concentration at the steady state. So whole concentration in the neutral region at the steady state, e to the power applied bias divided by eta bt. Applied bias I need to find out, eta value I will take 1 by default if it is not given. Okay, so this value 10 to the power 9 equals to 10 to the power 6 e to the power Vi I need to find out, Vt value is given 0.0259. So from here Va value will come out to be 0.178. Let me check it again. 10 to the power 3 ln into 0.0259. So yeah, 0.1789. So what is the answer? Forward bias of 0.1789. Okay, and this also you can see here the increase is 10 to the power 3. So here also the same increase would be there because the applied bias is same only. No, whether it is P side or N side, for both of them the applied bias is same. This value is same, nativity value is same, and here it is 10 to the power 4. So 10 to the power 4 e to the power Va by nativity you would do. 10 to the power 4 e to the power Va by nativity you would do. So here also the increase will be 10 to the power 3 only. 10 to the power 6 to 10 to the power 9, 10 to the power 3. Right? It became 10 to the power 3 times. So this will also become 10 to the power 3 times only. So this will be your 10 to the power 7, which is also correct. And P, the electron concentration at the edge of depletion in P side. Okay, so that would be 10 to the power 7. Right? So if you know the concept, it was an easy question only.
let A be a non-singular matrix with real entries. Okay, so A is a non-singular matrix with real entries, and A and B are obtained by interchanging two of its rows. So B is obtained, the matrix B is obtained from A by interchanging two of its rows. Which of the following statements is slash R true? Determinant of B is equals to negative of determinant of A. Certainly this is true, right? If I interchange, so let's say if let's say this was alpha, beta, gamma and delta, this is my A. I'm just taking an example, okay? So they are non-singular matrix. It should be properly mentioned that they are non-singular square matrix. This will be mentioned in the question. I forgot to mention it. They will be non-singular square matrices. Okay. So if I swap the rows, you certainly know that determinant of B would be simply negative of determinant of A. This is a property, right? If A is invertible, B is also invertible. Is this true? Yes, this will also be true, because technically, like, it is, they have already told me that it is a non-singular matrix, right? So basically its determinant is not equal to 0. That means A will be invertible. So if determinant of A is not 0, determinant of B also will be not 0. Why? Because we know both the determinants follow this relation. Determinant of B is equals to negative of determinant of A. So if A is non-zero, B also will be non-zero only, but it will be negative. So option B is also correct, right? Now, if A is symmetric, then B is also symmetric. Is that correct? No. So let's say here A is symmetric matrix, right? So asymmetric basically means A equals to A transpose. So if I swap these two values, it will be same. So essentially my gamma and beta are same, right? That is what symmetric means. Gamma is equals to beta. In this particular example, I'm just taking an example. Now what essentially I'm doing is I am trying to change this, right? I am swapping the rows. This will become alpha beta. And now is this symmetric? So what is B transpose? This is my B, right? What is B transpose? B transpose is gamma alpha, and row will be changed to columns, right? To beta. So I said that gamma is equals to beta, right? So these two elements are same. Are these same? If they, how can they be same? They can be same only if alpha is equals to delta. Yeah, only if alpha is equal to delta, then only these two matrices will be same, right? But the condition that was set, if A is equals to A transpose, is gamma is equals to beta, right? So these two conditions are different. So certainly it will not be symmetrical. I cannot comment basically. Again, trace of A is 0, then trace of B also will be 0. Again, not correct. Here what is the trace? Alpha plus delta, that is equals to 0. Here what is the trace? Gamma plus beta. Is it equal to 0? I don't know. This condition is certainly true, but is this like, if this is true, is this true also? No, I cannot comment. So only option 1 and 2 will be correct. I will actually remove this non-singular part. Actually it should have been square matrix. Here non-singular is wrong, it should have been a square matrix. Okay, so yeah, that is the only difference that I will do. I will change the non-singular to square matrix. Okay, so option A and B will be your correct answer for this question. Consider the function as function belongs to real values only, defined by this. Which of the following statements is slash R correct? F of x is continuous over the whole real domain. Is that so? Yes, it is, right? So what we are doing, so what is my e raised to power x? E raised to power x is a function like this, always increasing, right? So for negative values of x, the function will reduce. E raised to power minus 1, e raised to power minus 2, e raised to power minus infinity is 0, and e raised to power 2, e raised to power 3, it will only increase. This is my e raised to power x. What about your mod of sin x? Mod of sin x. So your mod of sin x would be this, right? So essentially it will not include any negative values of x, right? It will just make it positive. That is mod of sin x. So if I'm multiplying these two, right, what is happening? So essentially you will have to plot a what do you call it? I forgot this envelope, right? Now because your function is always positive, you don't have to draw the mirror image of the envelope, only for the positive values of the envelope. So this is the scaling factor. So essentially your function is like this. The amplitude will increase, and it will keep on increasing, right? Like this. This will be your function. Okay. So just a rough drawing. Basically, it will exist from minus infinity to plus infinity. Hence, I can see at every point it is always continuous. There is no discontinuity. So f of x is continuous over the whole region. Option A is correct. F of x is differentiable for all real values of x. I can certainly say it is not differentiable, because you see the slope sharply change here, right? So there are sharp changes at x equals to pi, 2 pi, 3 pi, 0. So at multiples, integer multiples of pi, there are sharp changes. So f of x is not differentiable. F of x is periodic? No. This is periodic. This is not periodic. So I'm multiplying a aperiodic function with a periodic function. So certainly I will get a aperiodic function. F of x is bounded on R. This statement is again incorrect. It is not bounded, right? If you see, it is certainly not bounded, because at x equals to infinity, right, for all real values, it is also trending towards infinity. So certainly it is not bounded. So this is not bounded, right? So this is incorrect. So only option 1 will be the correct answer for this question. The transfer function of a system is given as this. In the state space representation of the system, the minimum number of state variables in integers necessary is. So the minimum number of state variables, right, or the order of the system matrix will always be equals to the actual number of poles of the system. How many poles I have? 3. So once for answering this question, just be careful. One thing, simply measure the number of poles. Yeah, you're done. So number of poles here is 3. So your answer is 3. In this case, the answer is 3. But just be careful, make sure there is no pole 0 cancellation. What do I mean by pole 0 cancellation? Let's say if the question would have changed, it was s plus 1, s plus 3, and here I would have had s square minus 1 into s plus 7 into s plus 9. So your answer at first glance would be 4 for this particular transfer function. But if you factorize, right, if you break this down into factors, it will be s minus 1 into s plus 1, and that s plus 1 will be cancelled with this. So make sure whenever you're answering this, there is no pole 0 cancellation. In this case, there is no pole 0 cancellation. So your answer would be 3.
Yeah, let's see the solution of this problem. So we will solve this question, but if you want to learn more on positive feedback, in OPAM you might have studied about Smith trigger, but if you want to learn more, if you want to study in a good manner, then you can refer this video. Okay, here right from the basics we are starting what is the meaning of positive feedback and how positive feedback would work in OPAM. Okay, so that you can watch in this video. Along with that, you can solve this particular question as well. You can simply type OPAM in positive feedback plus tangent analysis amazing question PrepFusion. You will get this video and you can solve it. This question was there in our Concept X All India mock test as well. We conducted our All India mock test in September, Concept X. I hope you have attempted that particular test. That test was also very good. So you can attempt that particular test. In that test as well, this question was given. So you can see this particular question. Okay, you can see the solution here, and along with that, you can learn more on positive feedback in a good manner. You can learn. Surely we will see the solution. Okay, so yeah, let's get started with the solution. But if you want to learn more, you can learn from this particular video and this particular video. So yeah, let's get started. So what is this circuit? Integrator. And what is this circuit? Smith trigger. Positive feedback is there, that means it is Smith trigger. Inverting or non-inverting? It is non-inverting. Why is that so? Because input will be connected to the positive terminal. So it is your non-inverting Smith trigger. Can you find out its threshold voltage? Upper threshold, lower threshold? Surely. So let's just say this input is VA. Output is Vout. Positive feedback is there. That means two outputs are possible, plus 5 volt and minus 5 volt. Right? Now let's just say if your output is plus 5 volt. If your output is plus 5 volt, then what will be your V positive input? If output is plus 5 volt, this diode would be on. So V positive would be 5 into 2 plus VA into 2 divided by 4. 5 into 2 kilo ohm plus VA into 2 kilo ohm divided by 2 plus 2, 4 kilo ohm. And that should be put equals to V negative, that should be put equals to 0. V negative is 0. So from here what you are getting? VA equals to minus 5. What does that mean? That is your lower threshold voltage. So your lower threshold potential is minus 5 volt. So we have find out lower threshold potential. What will be your V positive when your output is minus 5? When output is minus 5, this diode would be on. If this diode is on, then minus 5 into 2 plus VA into 1 divided by 2 plus 1, that is 3. So from here VA value is coming out to be 10. If I put that equals to 0, VA value is coming out to be 10. That means your upper threshold voltage is 10. So now I will be able to make the characteristics of this particular Smith trigger. So this particular block, which block? Now I can make the characteristics of this particular block. So now I can replace this particular block with something good. So what I am going to do is that I am going to make the characteristics of V0 versus VA. Upper threshold voltage came out to be 10 volt, right? 10 volt and minus 5. So upper threshold came out to be 10. This came out to be minus 5. So what kind of characteristics we will get? We will get a hysteresis, right? Now since it is non-inverting Smith trigger, that means at higher value you will get the higher output, right? And this hysteresis also we will get. Two kind of output you will get, plus 5 and minus 5. Sir, how all these concepts came into action? You need to study Smith trigger in a good manner, then you will be able to understand what I am doing here. And a lot of questions have been asked in previous year questions. Okay, since it is non-inverting Smith trigger, so at higher value you are getting higher output, at lower value you are getting lower output. Non-inverting, if it is non-inverting, what does that mean? The rotation will be anti-clockwise. Rotation would be anti-clockwise. And here both kind of rotation would be there. Here both kind of rotation would be there. Right? Well and good. So this is the characteristics. Why I have replaced with the characteristics? Because eventually I need to analyze this output only. No, output could be plus 5, minus 5. This output would be changing. Then I will be getting the oscillations. I need to find out the time period of the oscillations. So initially, what is the scenario? Initially, this capacitor is uncharged. This is having 0 volt. If this capacitor is initially having 0 volt, what does that mean? That means there will be negative feedback. So this negative feedback, this will make sure that this VA is becoming 0. So initially your VA is 0. If your VA is 0, what could be your output? Sir, if my VA is 0, output could be either plus 5. This is showing plus 5 volt, or output could be minus 5 volt. I don't know, sir, what would be the output. Either it could be plus 5 or it could be minus 5. You can assume anything. Let's just say I assume the output to be plus 5 volt. So initially I am assuming my output to be plus 5 volt. Now initially if the output is plus 5 volt, this plus 5 volt will go here. Now what this plus 5 volt will do? This plus 5 volt will drive 5 milliampere current here. Now this 5 milliampere current will be flowing through the capacitor. Now a constant current is flowing through the capacitor. What does that mean? That means capacitor will charge its voltage linearly. So what is the equation? That would be Vt by C or It by C, sorry. The equation would be It by C. So what is the current that is coming? Current that is coming is 5 milliampere with the time divided by the capacitance, which is 1 milli. So milli to milli is getting cancelled out, 5t. That means your current that is flowing is 5t ampere. So across the capacitor 5t ampere current is flowing. That means this voltage is actually going down, right? This is zero potential. The capacitor is getting charged in this direction. So voltage is increasing in here. That means this potential VA is getting down. That means VA is going in this direction, right? You are currently at plus 5 volt. When you will make the transition, when the VA becomes minus 5 volt. So when VA becomes minus 5 volt, what will happen? When this VA becomes minus 5 volt, what will happen? The output will make a transition from plus 5 to minus 5. When the VA becomes minus 5 volt, output will make a transition from plus 5 to minus 5. So what we are waiting for? We just need to make the waveform. How we will start making the waveform? We are making the waveform of V0. What we started with, sir, we assumed that output is plus 5 volt. We assumed the output is plus 5 volt. But till what point it will remain at plus 5 volt? It will remain at plus 5 volt until it is charged to 5 volt. Since it is charged to 5 volt, what will happen? This will become minus 5 volt. Since this is becoming minus 5 volt, what will happen is that output will make a transition from plus 5 volt to minus 5 volt. Is that understandable to you? Okay, this is how Smith trigger works. So this should be minus 5 volt. How much time it would take? What is the current? 5t ampere. So how much time it would take? To reach 5 volt, how much time it would take? It would take only 1 second. So in 1 second, the output will become from plus 5 to minus 5. Output was plus 5. In 1 second, it has become to minus 5. Now at minus 5, for how much time it will stay? Now if the output has become minus 5, what will happen now? if the output has become -5, output has become -5. This is charged to 5 volt now. Okay, this is the charge that capacitor is having. Capacitor is having 5 volt charge. Now output has become -5 volt. So what will happen now? This -5 volt will be exposed here. Now what this -5 volt will do? It will drive the current in this direction. What will be that current? 5 milliampere. Already the capacitor is having -5 volt. Now the current is flowing in this direction. When the capacitor was having -5, 5 volt, what was the VA potential? VA potential was -5 volt. VA potential was -5 volt. Now the current direction is changed. Now this is the direction of current. That means now the capacitor would charge in this direction. So what is happening? VA value will increase. So VA value is actually making a transition from -5 to this direction. VA value is increasing from -5 to this direction. It is moving. That means we are moving on this particular curve. When we are moving from -5 to this direction, -5 to 10, that means we are moving on this particular curve. So if we are moving on this particular curve, when it will make the transition? It will make the transition when VA is equals to 10. So if you want VA to be 10, if you want this VA to be 10 volt, what does that mean? How much voltage should be there? The voltage here should be 10 volt in this direction, because this will be 0 plus 10. So if you want this to be plus 10 volt, that means there should be 10 voltage. In which direction? From this node to this node, from right to left. From right to left, 10 voltage should be there. Initially we are having 5 volt from left to right. You want 10 volt from right to left. In this direction you want. That means you need to give 15 voltage. From +5 to -10 you require. That means you need to give 15 voltage. 15 voltage you need to give. What is the voltage that is appearing across the capacitor? That is 5T. You need to give 15 volt. That means the current should be flowing for 3 seconds. What does that mean? It will stay at -5 volt for 3 seconds. Then it will move to +5. Why it will move to +5? I want to make it for 3 seconds. So how would I make it? 3 seconds. Then it will move to +5. Why it is moving to +5? Let's see that. Because what has happened now? VA has become 10 volt. Just as VA has become 10 volt, from where to where we are making the transition from -5 to +10 volt. If we are making the transition from -5 to 10 volt, then what will happen is that from -5 to it will become +5. From -5 voltage to it will become +5 voltage. From -5 voltage to it will become +5 voltage. So now the output will become +5 voltage and the capacitor would have been charged to 10 volt. 10 volt in this direction. 10 volt in this direction. So now this is the setup. The scenario is understandable. Now your VA value has become 10 volt. This was your VA value. VA value has become 10 volt. VA value has become 10 volt, right? And output has become +5. This output has become +5. Now this output has become +5. This +5 will come here. This +5 will come here. Now what this +5 will do? It will again drive the current, but this time it will drive the current in this direction, which is 5 milliampere. Again the current will be flowing in the capacitor in this direction. If the current is flowing from left to right, that means voltage will be developed in this direction. So what will happen? This 10 volt will go down. 10 volt is going down. If 10 volt is going down, that means from 10 volt to you are moving to 5 volt. From 10 volt to you are moving to -5 volt. That means which curve you are following? This curve you are following. From 10 volt to you are moving to -5 volt. So voltage is going down from 10 to -5. That means you are moving on this particular curve. When it will make the transition? When VA becomes -5 volt. So when your VA will become -5 volt, you want VA to become -5 volt. What does that mean? That means you want 5 volt here. Right? Then only 0 -5 it will become -5 volt. That means from +10 to you need to give -5. From right to left you are having +10. You need from right to left, from left to right you need 5 volt. Right to left you are having 10. From left to right you need 5. That means how much voltage you need to give? 15 volt. For 15 volt, how much time it would take? 3 seconds. So another 3 seconds it would take. So till 3 seconds it will again remain there. And then again it will become -5. Again the same cycle will keep on going. So this cycle will keep on repeating. So after 1 second, here we took 3 seconds and then another 3 seconds we took. So what is the time window? 6 seconds. So this cycle will keep on repeating. So what is the time period? 6 seconds. Again, very tough to solve in the examination hall, but yeah, these kind of questions have been asked. I'm telling you, not this kind of setup. This is actually very tough, but from this kind of concept, the questions have been asked. In the examination, they will directly tell that it is a non-inverting Schmitt trigger. You should know how the characteristic goes. What is the meaning of this characteristics? How this characteristic came into action? So everything I have taught in this particular video. I know people study positive feedback, but they study in very, very rough manner, very crude manner. Okay, we need to study in a good manner. You can watch this particular video. You will be able to understand the core concept of positive feedback and how to study these kind of characteristics. Then the use of these characteristics will be there in this particular video. So if you want to learn something productive out of the AIMT, what is the meaning of All India mock test? That you should learn something productive. No, that's why I'm giving video solution. I could have given written solution, you would not understand anything. Video solution, we are making the questions, then we like this question you try finding out in any textbook. This has been framed by me. This question is made by me only. Okay, I took these values, I designed this particular circuitry. So you are not going to find it out in any textbook anyway. So I thought of it. Who knows, IIT professor may also thought of the same. In our channel, you would find in 2026 when they frame a very good question paper, I would see a lot of questions are already posted, which are coming in the future gate examination, which will be coming in future gate examination. So we are not preparing for previous year questions. We are preparing for future examination, right? You are not going to attempt the gate 124 question paper. You are not going to attempt gate 123 question paper. You are going to attempt 26 or 27 or 28. Is that understandable to you? So I think you can appreciate it. You can put a like. Okay. Yeah, I know this was a tough question. You might be getting frustrated, sir. I'm not getting marks. But there would be two kind of guys. One guy would be learning, other guy would be crying. So it's up to you in which category you want to fall in. Okay. Yeah. Let's go to the next. Yeah. So this is formula based question. Okay. Again, I would say a bit lengthy, but formula based again. Maximum power gain you need to find out. What is the power gain? Maximum power gain you need to find out. Maximum power gain you need to find out. So that is efficiency multiplied with the directivity. What is the formula of efficiency? Here radiation loss is not there. That means only transmission line losses would come into action. That means this would be 1 minus mod of gamma square. Can you find out gamma? ZL minus Z0 upon ZL plus Z0. So 73 minus 50 upon 73 plus 50. This is actually a very standard value. In a lot of questions, the same value is used, but I don't remember it. 23 divided by 73 plus 50. That would be 123. Right? So it is coming out to be 0.186. The neta value will come out to be, you do the square and subtract 1 from here, so 0.965. 0.965. That is the neta value you are getting. And then you need to find out that this is the neta value, we will use it. And directivity, we need to find out. So what is directivity? Umax divided by P radiated into 4 pi. Now interesting part is Umax only. A lot of people would have matched up in Umax. What they would have done? Sir, Umax, maximum value of sin theta is 2, sin cube theta is, sorry, maximum value of sin theta is 1, sin cube phi is also 1. That means Umax is 2. Umax is 2, which is wrong. You did not see the limit, no? Theta is only going from 0 to pi by 6. See the graph of sin theta. This is the graph from 0 to pi by 2. Where will be pi by 6? This will be pi by 6. So you are putting the value of pi by 2, but it is not even reaching there, no? Pi by 6 will have a value of half. So Umax will be, sin theta can have maximum value of half only. Sin cube phi is going to 0 to pi. This is how the phi is going. So it will have a maximum value of 1. So Umax is actually coming out to be 1. Okay. So this is where you matched up. This was the most important point. Umax is 1 here, not 2. This is from our class notes only actually. So Umax is 1, not 2. What we need to find out now? P radiated. So what is your P radiated? Sir, U theta comma phi, which is 2 sin theta sin cube phi. 2 sin theta sin cube phi into sin theta d theta d phi. So I will simply make it sin square theta d phi. Limit of phi going from 0 to pi, limit of theta going from 0 to pi by 6. So eventually we will have to solve this particular integration. So 2 comes here, 1 minus cos 2 theta, right, divided by 2. What we are doing? We have to solve this integration, no? Basically, this is 2, 0 to pi by 6. Theta value is 0 to pi by 6. Now what I am doing? 2 sin square theta. What is cos 2 theta? 1 minus 2 sin square theta, no? So it would become 1 minus cos 2 theta. So simply what I can do is that I can simply put it as, or let's put this 2 as it is. This would be 1 minus cos 2 theta divided by 2. Okay, dot d theta. And then we remember this value, 0 to pi sin cube phi dot d phi. Either you can solve it or you can remember the value. How would you solve it? Do you remember the formula of sin 3 theta? Yes. 3 sin theta minus 4 sin cube theta. So from here you can see that sin 3 theta divided by 4. This is the formula of sin cube theta. So basically sine cube phi you can take. So in place of sine cube phi, you can replace this particular thing and then you can solve it. The answer would come out to be 4 by 3. So this I have told you to remember. This particular integration I have told you to remember. I gave another formula as well. 3 minus 1 into 3 minus 3 we will not do, right? And then 3 into 3 minus 2. It was from 0 to pi by 2. So multiply with 2. Yeah, that's it. And this is odd. So multiply with 1. So do you remember this particular formula? That m minus 1, m minus 3, m minus 5 into n minus 1, n minus 3, n minus 5 divided by m plus n minus 2, m plus n minus 4. That particular formula I'm talking about. So from there you can see that 2 into 2, 4, 4 by 3. Yeah, the answer would come out to be 4 by 3. And I told you to remember as well. This particular expression I told you to remember, answer would be 4 by 3. Because in 99% of the problems, this will be used. So that's why this will be 4 by 3. 2 and 2 is getting cancelled out. Now what you are getting? 1 minus sine 2 theta. Sorry, what will be the integration? 2 and 2 is getting cancelled out. 4 by 3 is outside. Here the integration would be theta minus sine 2 theta divided by 2 from 0 to pi by 6. So what you will see here, pi by 3, pi by 6 minus sine pi by 3 divided by 2. So let's solve it now. Let me pause the video and I will solve it. Okay, because I'm a bit tired. So sine pi by 3 means sine 60 under root 3 by 4. So under root 3 by 4, which is 0.443 minus pi by 6 I need to do. Pi by 6 into 4 divided by 3. So 0.120, roughly around 0.120. This is the pre-radiated we are getting. Okay, surely what it is. Okay, so all the things we know. What will be the directivity? Sorry, what will be the maximum power gain now? Neta is 0.965, Umax is 1, 4 pi is there, and P radiated came out to be 0.1207. Okay, so you solve it, you will get the answer. 0.1207 multiplied, then multiply with 0.965, then multiply with pi, then multiply with 4, then you take a logarithm, then multiply with 10. So answer you are getting is 0.02 dB. Okay, so that's the answer we are getting. So P radiated we have find out, Umax we have find out, 4 pi we already know, Neta we have find out, 0.02 dB we are getting. If you have matched up here, then answer would be incorrect. Otherwise, this was a very straightforward formula based question only. Only good thing was Umax. Okay, let's move to the next one. Yeah, let's solve this question. Expression F is given, you need to find out the prime implicants and essential prime implicants. So A, B, C bar, A, B bar, C, A, B, D bar. So eventually we need to make the K-map. So let's make the K-map for A, B, C, D. So this would be A bar, B bar, A bar, B, A, B, A, B bar, C bar, D bar, C bar, D, C, D, C, D bar. Okay. A bar, B, C bar, A bar, B, A bar, B, C bar, A bar, B, C bar, right? Next, A, B bar, C, A, B bar, C, A, B bar, C. Next, A, B, D bar, A, B, D bar. Next, A bar, C bar, D, C bar, D, here is C bar, D, and then A bar, C bar, D, and this is the A bar. C, D bar, then B, C, D bar, and B, B, C, D bar. Okay, yeah, this is the scenario. So first we will try to make the biggest club. What will be the biggest club? Club of 4. This is the biggest club we are getting. If you have matched up here, then your answer would be wrong. Okay, this was the biggest point, that you can see the club of 4. If you can see the club of 4, any other club of 4 you can see? Absolutely not, right? So another pair of 2, another pair of 2, 3 implicants are there, 4 prime implicants are there, and 5 prime implicants are there. So 5 prime implicants we are getting. Now essential prime implicants. So I will go to 5 prime implicants we have got. Now what about essential prime implicants? So I will go to one club one by one. If I go to this club, I will ask you whether you are engaged with the other guy. Yes, he is engaged, but this guy is alone. That means this is a essential prime implicants. Here in this club, this particular guy is engaged with some other guy, but this guy is alone. So this is essential prime implicant. In this particular club, we have already gone to this club. No, this is the club of 4. Here we have already talked to this guy. So this was alone. So it is essential prime implicant. What about this one? He will say I am clubbed with this guy. He will say I am clubbed with this guy. So both of the guys are clubbed with some other guy. This is not essential. Here, in this particular club, if I go, so he will say that I am only clubbed with this guy only. So, and if I go to this particular club, he will say that I am involved with this one, and he will say that I am involved with this one. So in this particular club, both of the guys are involved with some other guy. That means this is also not essential. So only 3 are essential and 5 are prime implicants. So prime implicants, out of these 3 are essential. What is the meaning of essential prime implicants? You go to each club and ask them whether you are involved with some other guy or not. I went to this club. He said that I am involved with the other guy. He also said that I am involved with the other guy. That means if this relationship are not there, it wouldn't matter, right? If they both break up, then there is no issue. He will be involved with this particular person. He will be involved with this particular person. But if these 2 guys break up, then he will be alone. Who will be alone? He will be alone, right? So that's why this relationship is essential. This is also essential. This is not essential because both are involved. This is also essential. I could have gone to this guy as well. Now you will not say that, sir, another essential prime implicant is there. No, only one club. Basically, this club is essential. This particular club of 4 is essential. This friendship or relationship, whatever you can call it, that is essential. Relationship could not be of 4 people, right? At least in India. So relationship has to be of 2 people. So this you can call it as friendship club. So if this guy gets out of the friendship, no issue. If this guy gets out of the friendship, no issue. But this guy will be alone. This guy will also be alone. But they are of the same group only. So 1, 2, 3. So 5, 3 would be the answer. 5, 3 would be the answer. Okay, let's go to the next one. Yeah, so that's a decent question, I would say. But you should be able to solve it if you have enough practice. So this is your input wave having frequency of f in. This will have a frequency of f out. So f in, f out you need to find out, and then you need to tell the duty cycle of the output. Basically, you need to comment majorly on this. What is your input wave? That will be a clock with the 50% duty cycle. So you can simply make a clock. This will be my input. Okay, and positive is triggered, D flip flop I can see there. So positive is triggered, D flip flop is there. Right, now what is the scenario of D? Q plus is equals to, Q plus would be equals to D, which is equals to Q bar. So Q plus is nothing but Q bar. And eventually what is your output? Output is nothing but, let's call this as input AND gate with Q. This Q comes here, which will be AND with input clock. So input AND with Q. So input clock I have already made. This is my input. And can I make my Q now? Let's just say Q started from 0. If it started from 0, what will happen? This is the condition of toggling, right? Toggle condition is there. So at every positive edge, it will toggle. Toggle, 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 and toggle. Now AND of both of them, what that would be? That would be your output. So 0, 0, 0, 1, 1, 1. Then 1, 0, 1, 0, 0, 1, 0, 0, 0, 0, 0. So till this point, it will be 0 only. Then here 1, 1, 1, 0, 0, 0. There you go. Okay. So let's just say if this time period was T. So this time period would be 2T. So if this frequency was F in, so this frequency would be F in by 2. And what is the duty cycle? Only for this much of window it is on, and for this much of window it is off. What does that mean? Only for 1/4 of the window it is on. Is that understandable to you? Here duty cycle was 50%. If this point is, let's just say 0 second, 1 second, 2 second, 3 second, and 4 second. So this point is 0 second, this point is 1 second, 2 second, 3 second, this point is 4 second. So in the 4 second, only for 1 second it is on. What does that mean? Duty cycle is 50%. Duty cycle being 50% and frequency is half. Sorry. Duty cycle is 25%. Duty cycle being 25% and frequency is half. Frequency is half, duty cycle being 25%. Okay. Simple question. This should have been solved. These kind of questions should be solved. Otherwise, there would be very tough. It would be very tough for you, right? Yeah. So this question is based on the analysis of latches. right? So how to analyze a random latch? Like this is not a standard latch, no, this is not SR latch, JK latch, or whatever it is. It is not a standard diagram. So how would you analyze a random kind of latch? That we have studied in our lecture series. Okay, it is not available on YouTube sadly, but something I will do for you guys. I can open up some free trial. You can learn that particular method, or from this particular question only you will be able to learn the method. So here only I will teach you that how to analyze a random latch. Even if it is a standard latch only, then also you would analyze in this manner. So what is the meaning of latch? Latch means, sir, one output would be Qn plus 1. Let's just say this output is Qn plus 1. So other one has to be complement of this output. This is the meaning of latch. You could, sir, why you put P as Qn plus 1? I could have put Q as Qn plus 1. Yes, you can do that. Opposite also you can do that, and that you will do on your own. I will teach you for the analysis of considering P as Qn plus 1 and Q as Qn plus 1 bar. Okay. So if this is Qn plus 1 bar, then previous state would come here. So this state would be Qn, and this state would be Qn bar. If this is your Qn plus 1 bar, so this state would be Qn bar because this is the previous state, and this is the next state. Qn plus 1 is the next state, and this state would come here. So this state would become Qn, right? So can you write down the expression of Qn plus 1, or can you write down what is Q? Q is Qn plus 1 bar. That would be equals to B into Qn bar, right? B into Qn bar, because there is a AND gate. And what will be the expression of P? Expression of P would be A bar plus Qn bar, and then there is a bar. A bar plus this Qn bar goes here. So A bar plus Qn bar, and then there is another bar. So it would become A Qn bar to the bar, right? So AQn, it would become AQn. Is that understandable to you? Again, let me see. This was your A bar, this is your Qn bar. This was only the circuitry, no? Questions are written here. The circuitry is different, then whole solution would go wrong. Yeah, circuitry is same. Yeah, A bar plus Qn bar to the whole bar, AQn it is coming out to be. Okay, now what we need to do? We need to make the truth table. So how we would make the truth table? So input are A and B. Inputs are A, B. Truth table we are making, and outputs are Qn plus 1 and Qn plus 1 bar. What is this? This is your P, this is your Q. Input can take these values 0, 0, 0, 1, 1, 0, 1, 1. Now if it is taking value 0, 0, if A is 0, then P would be 0. If B is 0, then Q would be 1. If B is 0, this would be 0, Q would be 1. Now if A is 0, then P would be 0. If B is 1, then then Q would be Qn bar. So what you will put here? Qn bar? No, what you will do is that if you know one of the value, if you know one of the bit, then other bit has to be bar of that, no? So this will be 1 only. Sir, when I put 1 here, what I am getting? Qn bar I am getting. So here I will not put Qn bar. What I would do, if I know one bit, then what would be the other bit? Simply the bar of the other one, no? So that would be 0, 1. Is that understandable to you? Right? Let's just say if I had put here, what was the scenario? If you put B equals to 0, here you are getting a fixed value. Fixed bit you are getting. But if I am getting a bit in terms of Q or Q bar, then what I would do, I would not look at Q or Q bar. What I would do is that whatever the bit I am getting here, simply I will do the bar of it. This is how we analyze any standard latch as well. This is the way we analyze any standard latch, right? Next, 1, 0. So if I put A equals to 1, then what I am getting? Qn I am getting here. And if I put B equals to 0, so 0 into Qn bar, here I am getting 1. So what I would do? Here I would put Qn? No. Simply I would do the bar of this, because this is Qn plus 1 bar and this is Qn plus 1. So simply I will do the bar of this. So what I will be getting here? I will be getting 0 here. Is that understandable to you? Now if I put P equals to 1, what I am getting? If I put A equals to 1, so Qn plus 1 I am getting as Qn. And if I put B equals to 1, here I am getting Qn bar. Now in this scenario, I cannot comment on anything. Like this is also not a fixed bit and this is also not a fixed bit. So here I will be stuck that Qn plus 1 is equals to Qn and Qn plus 1 bar is equals to Qn bar. Is that understandable to you? This is how you would analyze. You will write down the expression PQ. One is simply Qn plus 1, other one would be the bar. Write down the expression, put the values. If one of the bit is fixed, other one will be simply the bar of it. So if your applied input is 0, 0, then output would be 0, 1. If it is 0 1, output would be 0 1. If it is 1 0, output would be 0 1. Now if it is 1 1, then what would happen? So previously what was the scenario, that this was, so this option is matching, this option is matching, this option is matching. Till this point you would know that, sir, this is the answer. But sir, now what it is saying, that it should hold. It should hold. So in the hold, sir, we should be getting 0 1 as the output. Sir, why you have put 1 0? 1 0 is also possible. Let me tell you how it is possible. 0 1 or 1 0 both are possible. So let's see. Let's just say this is A equals to 1, B equals to 0. What I have said, the delays of OR gate and AND gate is different. I did not say which one is larger. I just said that it is different. So when A was 1, B was 0. When A was 1, B was 0. Your outputs were 0, 1. Now for the next state, this one would come here. Can I remove all these things now? I am removing all these things now. So this is 0, this was 1. Now for the next state, when it is changed, this has changed to 1 and this has changed to 1. Right? For the next state, this 1 would come here and this 0 would come here. But you see one thing, delay of OR gate and AND gate is different. Let's just say this delay is more. What does that mean? If this delay is more, that means it would give the result late. So this 0 would have come late, no? And this would have come early. So this 1 would have reached here early on. Now 1, this has become 1, so this point would become 0. 1 added with 0, it would become 1, and here it would become 0. So immediately it would have become 0, and this 0 would have reached here. If this 0 reaches here, 1 multiply with 0, what that would be 0, 0 multiply with 1, your answer would be 1. So next state would be 0, 1 only. In this case, when the delay of this guy is more and the delay of this guy is lesser. Now we would do the opposite. Delay of this guy is lesser. What does that mean? That means this would have come early on. This would have come early on. This would have come early on. And this would have come late. So this 0 has come early on. That means this 0 has reached here very fastly. This 0 has reached here very fastly. So first this operation will take place now. Why is that so? Because this is having lesser delay. So this operation will take place. Now 0 multiply with 0, 0, 0, 0. If you do the AND operation, sorry, if you do the NOT operation, what you will get? 1. Now this 1 will reach here. Now here you are having 1. 1, you do the AND operation, what you will get? 0. 1 added with 0, what you will get? 1. 1, you do the AND operation, what you will get? 0. So yeah, this option is framed wrong. It will always be 0, 1. Output will always be 0, 1 only. Okay, I matched up here. I will frame the option in a, again I will frame it. This would be always 0, 1. Okay, 1 0, 0 1, 0 1, 0 1, always it will remain at 0 1 only. Is that okay for you? But how do you analyze it? Did you understand? If one delay is more, one delay is lesser. That means the delay which is more, that will give result later on. So the one which is giving result early on, that will reach first and will perform the operation. And then based on the operation, whatever the result that you are getting, that will come here. But here the point is, result is itself not even changing. If result is not even changing, that means output is always staying at 0 1 only. But in the gate POIQ, you would see that fourth option would be written 1 0 or 0 1. So there actually results were changing. But here I blindly framed the option that it would be 1 0 or 0 1. Actually result is not changing here. So output would always be 0 1 only. Okay, so 0 1, 0 1 and 0 1. So I will change it. So yeah, it would not take much time. In the examination, you would see that these three options are matching. You would click on this. In the explanation, it is taking much time. Okay. Yeah. So let's see this one. A very good question, I would say. Here, what you need to find out, inversion charge density you need to find out. And in the option, you would see that units are given in nanocoulomb per centimeter square. Okay. So what is the formula of inversion charge? That is, inversion charge is proportional to Vg minus Vt. And when you remove the proportionality sign, it becomes Cux Vg minus Vt. Okay, so Cux value I can find out very easily. Cux will be epsilon Ox divided by Tux. Oxide thickness is given, absolutely it is given. Every calculation I will do in centimeter. So epsilon Ox. So let's put the value. What is the value of epsilon Ox? They would have surely given it somewhere. That is 3.9 into 8.85 into 10 to the power minus 14 divided by, this is 5 into 10 to the power minus 8. right? It could be written as 5 into 10 power minus 6 centimeter. 5 into 10 to the power minus 6 centimeter. Answer would be coming in farad per centimeter square. Now you need to find out the value of Vg minus Vt. Applied gate potential would have been surely given. Yes, 2.2 volt. Now main task is find out the value of Vt. So what is the value of Vt I can put? So threshold voltage is given 0.6 volt. This is something that you need to put. No. Body effect is there, no? When VSB was 0, then it was 0.6. All the options are not framed smartly. You can see options are 100 and 200 directly. So even if you put Vt not only, then also you will match the answer somehow. Why is that so? Because options are not framed smartly, no. Because of the body bias, how much threshold voltage will increase? Not by very huge amount, right? So if you have just put Vt not only, then also you would have matched the answer. But yeah, looking at the options, but let's do the correct analysis. It would be simply Vt naught plus gamma under root VSB plus 2 phi f minus under root 2 phi f as well. So what I would require? I would require the surface potential. So what will be the surface potential? So 0.0259 Vt ln Na by Ni. What is the value of Na? Na value would have been surely mentioned somewhere. Na 5 into 10 power 10 and this is 5 into 10 power 15. So it would become 5 into 10 power 5 Na by Ni. Okay. 5 10 to the power 5 into 5 ln into 0.0259. So what it is coming out to be 0.3398. But it doesn't matter. I need the value of 2 phi f. So 2 phi f is coming out to be 0.679. So what is the value of Vt naught? 0.6 plus gamma. Vt naught is 0.6 only, no? Yeah, 0.6. Gamma is also 0.6. Under root VSB. Sir, source to body potential is given as 0.5 plus 2 phi f, which is 0.679 minus under root 0.679. So let's do the calculation. Plus 0.5, take the under root. You are getting 1.08 minus, again you do 0.679, take the under root and subtract it from 1.08. This value is 0.225, 0.255. Then multiply with 0.6 and then add it with 0.6. So eventually 0.753. Your threshold voltage is coming out to be 0.753. And you can sense that not very huge change is there. So if not very huge change is there, so Q inversion would simply be COX Vg minus Vt. COX value you can get from here. What that would be? 10 to the power minus 8. So 3.9 into 8.85 divided by 5. 6.9 into 10 to the power minus 8. 6.90 into 10 to the power minus 8. What is the value of Vg? Vg is 2.2 minus Vt is 0.753. 2.2 minus 0.753. So 9.98. That means 99.88. 99.88 nanocoulomb per centimeter square you are getting. Is that the correct answer? This option would be there. Is this correct? What kind of substrate is there? MOS cap is there, no? Metal, oxide, semiconductor. Vg potential positive you are applying. What it is? Na. Positive you are applying, what it will attract? Electrons. Right? It will repel the holes. Then because of the generation, what will happen? Electron layer will be framed here. And this electron layer would be called as inversion charge. That means charge would be negative. I told you not to mug up the formula. Just think about it, whether it will be positive or negative. P-type substrate is there, it has to be negative, no? So charge would be negative. So answer would be minus 100 nanocoulomb per centimeter square, not plus 100. So that would be the answer. Okay. Was a good question, a bit calculative, but yeah, you would be able to solve it. Let's move to the next one. Very straightforward. H of n is given y of 0, y of 1 value is given, you need to find out the value of x of 1. And x of n is a causal system. That means there will be x of 0 involved, there will be x of 1 involved, x of 2 involved, and all these points will be involved. And I know that y of n is nothing but x of n convolved with h of n. Can you find out the value of h of 0? H of 0 would be 1. Can you find out the value of h of 1? So that would be 1 by 4. Can you find out the value of h of 2? That would be 1 by 16. So x of 0, x of 1, x of 2. 1, 1 by 4, 1 by 16. So this will be x of 0, 1 by 4 x of 0, 1 by 16 x of 0. X of 1, 1 by 4 x of 1, 1 by 16 x of 1. I guess these two would be enough. So x of 0 would be equals to y of 0. X of 0 would be equals to y of 0. That means it would be it would be 1 by 2. And x of 1 plus 1 by 4 x of 0 would be equals to y of 1. Y of 1 value is given as 1. So this is 1 minus 1 by 8. Answer would be 1 minus 1 by 8. That means 7 by 8. So if you do 7 by 8, what you are getting? 7 by 8, 0.875. So answer would be 0.875, rounded off to 3 decimal places. Very straightforward, very easy. I don't think solution is required for this one. Okay, simply write down these values, x of 0, 1 by 4 x of 0, 1 by 16 x of 0, x of 1, 1 by 4 x of 1, 1 by 16 x of 1. This will be y of 0, this will be x of 1 plus 1 by 4 x of 0, that would be equals to y of 1. Okay, so put the value, you will get the answer. Yeah, so let's solve this question. Semiconductor is there, band gap of 1.5 electron volt. So conduction band is there, valence band is there, conduction band is there. Let's just say this is at 0 electron volt energy, so this would be at 1.50, or I can simply say that this gap is 1.50 electron volt, right? Now what they are saying that Fermi level is located 0.45 electron volt below the mid energy gap. Below, this is your mid energy gap, this is the mid level. I am not calling it EFI, I am not saying it is EFI, intrinsic Fermi level. No, why is that so? Because intrinsic Fermi level, what is the location of intrinsic Fermi level? Sir, mid gap only, EC plus EV by 2. Is that so? No, minus 3 kT by 2 ln NC by NV, not minus 3 kT by 2, minus kT by 2 ln NC by NV. Then, yeah, this is the formula. Now you know that NC would be proportional to Mn to the power, Mn star you can put, or Mn you can put Mn star to the power 3 by 2, right? Effective electron mass to the power 3 by 2. So eventually what will happen is that this is the mid gap, this is the midpoint, this is your mid, minus 3 by 4, this 3 by 2 will come upward, ln Mn star divided by Mp star. So what is the ratio of Mn star divided by Mp star? That is 1 by 10. That means your EFI is a bit upward. EFI is a bit upward here. This is your EFI. This is your actual EFI. This is your actual EFI. So from the mid gap, it is this much upward. 3 by 4 minus 3 by 4 kT Mn star divided by Mp star. So ratio is Mn star divided by Mp star is 1 by 10. So what answer you will be getting from here? That would be 3 by 4 kT is 0.0259 ln 10. Because Mn star divided by Mp star 1 by 10. If I take 1 by 10 reciprocal, then it would become 10, and this will become positive, right? So here we are getting 10 ln into 0.0259 into 0.75. So 0.044. This gap is 0.04472 electron volt. Now what they are saying, the Fermi level is located 0.45 electron volt below the mid energy gap. That means this is where your Fermi level is located for the semiconductor. So what do you think, what kind of semiconductor it would be? And it is how much below? It is 0.45 electron volt below. So what do you think, what kind of semiconductor it is? P type. So that means this option is gone. Now it is P type. You need to find out the electron concentration. What do you know? Do you know one formula? EF minus EFI equals to KT ln Na by Ni. Ni value I already know, and Na value I will be getting. EF minus EFI. What will be the gap? 0.45? No. EFI is 0.0447 above. That means it would be 0.45 plus 0.04472 electron volt above. That would be equal to 0.0259 ln Na by Ni. Na we need to find out. Ni is given. That is 10 to the power 5. You solve this, you will get the answer. Okay? And most probably, not most probably, 100% you will get this answer only. We can solve it as well. Plus yeah, so 1.97 into 10 to the power 8 into 10 power 5. That would become 10 to the power 8, 5, 10 to the power 13. So 2 into 10 power 13. Yes, this is the answer you are getting. Okay, so acceptor atom of 2 into 10 power 13. That would be the answer. Right? So you could have solved it. In a good manner, you could have solved it. Even if you had ignored this particular thing, no, then also you would match the answer. Because this is again not very large. Or there would be an issue. Let's see if there was an issue or not. I don't think there would be much issue because 0.45 divided by 0.0259. Take exponential. Yeah, 10 to the power 12 you would have got the answer 3.5 into 10 to the power 12. Then you would know that surely this option is more near. You would have clicked on this one. But yeah, if intelligently option could have been framed. If I wanted to frame a good option, here I should have put 3.5 into 10 to the power 12. Then it would have been, here I should have put 3.5 into 10 to the power 12. Then it should have been more interesting that here this would come into action. But now even if you are not taking into action, even if you are not taking this into action, then also nearly you can ask the answer. But again, this has some role. Okay, so what is the role? That is clear that EF minus EFI, that would be 0.45 plus 0.047472. Okay, so actually your intrinsic Fermi level was a bit upward, and in the practical semiconductor it would be a bit upward only, not in the mid. Why is that so? Because always the mass, effective mass of holes will be more than the effective mass of electrons. That means this value will be less than 1. If this is less than 1, that means this has to be positive, right? Let's go to the next one. Yeah, so let's solve this one. This is a good question again. How would you solve it? With the concept of, with some formula, or with some good concept? If you want to solve with respect to formula, you can solve it. But last year I made some video in our EC core capsule. You can see the videos are there on transmission line. There I told you how to solve the problems of standing wave patterns in the most efficient manner using the constant VSWR circle. Okay. So what I would do, first I would plot, as soon as I see the problem is based on standing wave pattern, only task would be that you plot your gamma L. How will you plot your gamma L? Sir, magnitude is 0.6, angle is minus 133.14 degree. So angle is minus 133.14 degree. So this is where I will get my gamma L. And corresponding to this, what I would do, I would make a circle. Corresponding to this, I would make a circle with this radius, taking this particular radius into action. So taking this radius into action, I have made the circle. So this angle is minus 133.14 degree. So what will be this angle? 180 minus 133.14. That would be 46.86 degree. Okay, so this is where I am starting. This is my y equals to 0. What is the meaning of y equals to 0? The end of transmission line, load of transmission line, where the load is connected. So this is the load, this is my y equals to 0. So this is where I am starting from. How do I move on the transmission line? This is how I will move. And on the transmission line, I will move clockwise. Right? Opposite I move, on the transmission line, I will move clockwise. What do I need to get? I need to get voltage maxima. Here I will get my voltage maxima. So how much angle I need to cover? So this is 48.86 plus 180 degree. So how much angle I need to cover? 48.86 plus 180. That means I need to cover 226.86. 226.86 degree angle I need to cover to get my first voltage maxima. Now working 360 degree is equivalent to lambda by 2. So working this much, how it will be equivalent to? Divided by 360 multiply with lambda divided by 2. That means 0.315 lambda. That means 266.86 degrees, 0.315 lambda. So that means your first maxima on this transmission line, the first maxima would be occurring. Here your V maxima is occurring. That distance would be 0.315 lambda away from the load. Now, what is the value of lambda? Lambda is nothing but C by F. Not C by F, Vp by F. Okay, what is the Vp? C by under root epsilon r. Under root epsilon r is 2. Phase velocity is C by 2. And divided by F, that would be 10 giga. 3 into 10 power 8 divided by 20 into 10 power 9. So what you are getting? 1.5 centimeter. 1.5 centimeter. So value of lambda is 1.5 centimeter. If you put 1.5 centimeter here, what you are getting? 0.472. 0.472 centimeter. So from the load at 0.472 centimeter, you are getting your first voltage maxima. Is that understandable to you? Again, let me do the calculation. 0.315 into 1.5. 0.472. So at 0.42 centimeter, here you are getting your first maxima. Then second maxima, where it will occur? 0.472 plus lambda by 2, because after lambda by 2, everything keeps on repeating. If you again work, everything keeps on repeating after lambda by 2. So what is the value of lambda by 2? That is 0.75. So 0.472 plus 0.75. The next one would occur at plus 0.75. 1, 2, 3. Then again plus 0.75. So till what point I can go? I have the length of 3 centimeter. I have the total length of 3 centimeter. So starting from 0.472, then I add 0.75. What do I get? 1.225. That means still I am on the length. Then I add 0.75 more. What do I get? 1.9725. I am still on the length. Then I add 0.75 more. What do I get? 2.7225. I am still on the length. Length is 3 centimeter. Now if I add 0.75 more, then there is an issue. If I add 0.75 more, then there is an issue, because length is 3 centimeter only, but here I am getting 3.4725. That means your fifth voltage maxima would be occurring at a distance of 3.4725, which is not even there. That means your voltage, how many voltage maxima you will get? 1, 2, 3, 4. So answer would be 4. So 4 voltage maxima I will be getting. Okay, so this is how I solve it. This is how I have taught our student, and this is how it should be solved. Like that, some formula 2 beta lambda equals to 2 n pi, those kind of formula if you apply, I cannot help. But this is the core concept. You understand the constant VSWR circle and how it goes, and this is how you do the analysis of transmission line. Any kind of problem you can solve. They can ask you when your voltage minimum would occur. Here it would occur. Current maximum would occur here. And when you will get your R maximum, here you will get the R maximum, here you will get the R minimum. What will be the value of R maximum? What will be the value of R minimum? All these things you can do. From here you can tell that when the angle will be 0, when the angle will be 0. Angle will be 0 at this particular point. So how much you need to work. So all these things you can do, right? Yeah, so let's move to the next one. Yeah, so let's solve this one. Xt is given. You need to find out the power of X. You need to find out the energy of Xt. So basically this is something we need to find out. X square t dot dt. So can I break the Xt in this manner? It can be written in even component and its odd component, right? Square dot dt. So what it could be written as, if I just open it up, a square plus b square plus 2ab, right? Now I will integrate separately. Now just let me know what this would be, even or odd. Even multiply with odd. Even multiply with odd. If you put minus t here, this will be as it is. If you put minus t here, minus sign would come out. So this would be a odd function, no? Now just simply think of it, no? Even function is a cosinusoid and odd function is a sinusoid. If you multiply both of them, what you will get? Cos t multiply with sin t. What you can do? Multiply and divide by 2. So sin 2t by 2. What is sin 2t? Odd function only. So even multiply with odd, you will get odd only. Very simple thing, right? Basic mathematics. Odd multiply with odd. What you will get? Odd. Sorry, what you will get? Even. Odd multiply with odd, you will get even. Sin t multiply with sin t. What you will get? Sin square t. In place of t, if you put minus t, what you will get? Sin square minus t. Sin square minus t would be minus sin of t whole square. what you are getting? Sin square t only. So in place of t, if you put minus t, you are getting the same function. What does that mean? It is even. And even multiply with even, surely you will get even only. So this is also even. So this is odd. Now integration of odd from minus infinity to infinity. Let's just say this is a odd graph, right? This is a odd graph. You integrate it. Positive area multiply with this is positive area, negative area, positive area, negative area. What will be the total area? 0. So this will throw 0. And what is the case of even? So this is a even graph. This is a even graph. So what is the area? Whatever the area you get in positive side, the same area you will get in negative side. So now how it can be broken? It can be broken into, this is how it can be broken. So it can be simply 2 into from 0 to infinity even square t dot dt plus 2 into from 0 to infinity over square t dot dt. Because this will be gone, this will be 0. Even square t dot dt from minus infinity to infinity. So it will be twice of it. So here 2 would come, here also 2 would come. Why is that so? Because whatever the thing that you are getting from minus infinity to 0, the same thing you are getting from 0 to infinity as well. Now this value is given as 3 and this value is given as 2. So 2 into 2 plus 2 into 3, what you are getting? 10. Straightforward. Again, very straightforward, I would say. This type of question has to be solved. In the examination, these kind of questions has to be solved. Okay? Even multiply with odd, that would be 0. And then even into even, that would become even. Odd into odd, that would also become even. Then area of even this would be 2, this would be 3. 2 plus 3 multiply by 2, answer would be 10. I think a lot of people would have solved it without using the pen as well. Without using the pen. They would know this would go to 0, they would be doubled. So simply answer would be 3 plus 2 multiply by 2, answer would be 10. Let's go to the next one.
The unit step response of a second order closed loop system exhibits a peak overshoot of 40% and a rise time of 1.92 seconds, right? Based on this information, which of the following is the most appropriate approximation of the transfer function, right? So simply they have given, like this is simply a formula based question, right? So they have given you the peak overshoot. Do you remember what was your peak overshoot percentage equals to? So your simple formula, peak overshoot percentage, was simply equals to e raised to power minus pi cot theta into 100, right? That is equals to your percentage peak overshoot, that is given as 40%. What is your rise time formula? Your rise time formula was equals to pi minus theta upon omega. What will come here? Omega d will come. Okay, how do I remember? So there are two things, right? One is the rise time, another one is the delay time. Okay, so your delay time would be, if there is d, right, omega d will not come. Certainly omega d will not come. Okay, so certainly in the bottom I will have omega n. If there is delay d time, omega t will not come, omega n will come. Now with omega n, we remember the pole zero diagram, right, of a second order system. So this, right, real part is zeta omega n and the imaginary part is omega d. So the real part is zeta omega n, right? So with omega n, zeta will come. I do remember, like there will be some in the numerator, there will be 1 plus 0.7 into zeta. Whether this will come with this formula or this formula, how do I remember? If I have omega n in the bottom, then zeta will come. Okay, that's all. This you will be able to remember, but whether it will come with in the TD formula or in the TR formula, how will you remember? You will remember it like this. So if I have D, I will write omega n, right? If I have D, I will write omega n. I will not write omega D. If I have omega n, zeta will come. So certainly this formula has been fixed. So once you remember this formula, automatically you know the other formula, right? It's very easy to remember the formulas, but which time will come with which formula, you don't know. So that's how you will remember these things. So this is my TR, this is my TD. Okay, so yeah, that's all basically. I hope you get the point. Now so the rise time is given, so these values are given, right? So first let me first compute. So here, remember here theta is in radians, right? So let me first calculate theta and then I will come back to the other part. So yeah, if I solve this equation, the first equation, this will be basically 0.4 ln and then inverse and then tan inverse. Okay, just hold on. 0.4 ln then divided by pi, then inverse, then tan inverse. So this is 73.74 in theta is equals to 73.74 degrees or in radians it would be pi divided by 180. So 1.28 radians. Okay, 1.28 radians. So now uh yeah, now what shall be the values here? What shall be the values? How do I solve the okay, so I got the theta, right? So here the rise time is given, that is 1.932. So from here I can get the value of omega d. Omega d would be pi minus theta, that is 1.28 radian upon 1.932. So this plus pi upon 1.932. So omega d is approximately 0.96. Now if you remember this pole zero diagram, right, this theta is the angle of inclination. So your omega n sine theta is actually omega d, the damping frequency. So from here I can easily calculate the omega n value, omega d upon sine of theta, right? So this upon sine of theta, so 73.74 of sine. Make sure you're properly in radians and degrees. So omega n comes out to be 1. So your the characteristics equation, right, of your transfer function ce would be s square plus 2 into zeta into omega n. So zeta, okay, zeta is cos of this, right? Zeta is cos of 73.74, that is essentially equals to cos theta, that is essentially equals to 0.28. How all these are derived, I've explained this in my full course. So 2 zeta into omega n is 1 into s plus omega n square, that is 1 square. So it is s square plus 0.56 s plus 1. So s square plus 0.561 s plus 1, that is present in option D. So option D is correct for this question. Find the particular integral of this particular differential equation. So it's very simple to find out the particular integral. So I will convert this. This will be d square minus 2d plus 1 into y equals to e raised to power x cos of 3x, right? So I need to find out the particular integral. So the pi, right? Y pi would be, this will be 1d square minus 2d plus 1 e raised to power x cos of 3x. Okay, so what we do is whenever I have exponential e raised to power x into some other function v of x, then I replace my d with d plus a. So I can take out the e raised to power x and this will be replaced, the denominator will be replaced with d plus a, that is d plus 1, because here a is 1. Okay, so d plus 1 whole square minus 2d plus 1 plus 1 into cos of 3x. Okay, so this would be equals to e raised to power x, this would be d square plus 2d plus 1, okay, plus 1 minus 2d minus 2 plus 1, that is minus 1. So automatically what will happen, this will be basically cos 3x and e raised to power x upon d square cos 3x. So what happens is we replace, if I have a sinusoid, we replace our d square with minus, if I have a sinusoid or cosinusoid of cos ax, will replace this with minus of a square. We'll replace d square with minus of a square. So this will be e raised to power x upon minus of 3 square cos of 3x. So basically your pi would be minus of e raised to power x cos of 3x upon 9. Okay, so this will be your pi, which is present in the, okay, they're actually yeah, particular integral is this, right, option B, but the general solution I have to find out the general solution, right? Also I have to so solve for the general solution. So yeah, so this is my pi. What is my cf, complementary function? So complementary function will basically be the roots of this equation, that is d square minus 2d plus 1, which is nothing but d minus 1 whole square. So basically my roots are 1 comma 1. So this will be e raised to power x into cos of, sorry, roots are real, right? So this will be c1 plus c2x into e raised to power x. Right? Whenever roots are real and equal, what happens is we write this c1 c2 into x, and here write whatever is the value of the root that will come in the coefficient of x with the exponential. So your general solution would be e raised to power x c1 plus c2x. So yeah, option C is also correct, and obviously particular integral will be this. So option B and C are correct answer for this question. Let f of R as R is defined by this, which of the following statements is slash R true? Right, it is like f belongs to all real values, x also belongs to all real values. The graph of f of x is symmetric about y-axis. So if a graph has to be symmetric about the y-axis, what needs to happen? The function must be even, right? If you see any function, uh, let's say your cos, right, cos x. So your cos x, all the functions, right, that you see that are symmetric about the y-axis, all of them are even. So if I replace x with minus x, right? So what is f of minus x? It is equals to minus x raised to the power of 4 minus x raised to the power of 2. That is same only because I see it is even, right? All the powers are even, and whenever the powers are even, certainly your function will be symmetric about the y-axis. So first option is certainly correct. The minimum value attained by the function is 0.5. For this, we will have to differentiate our function. If I differentiate my function dy upon dx, that would be 4x cube minus 2x, and this will have to equate equals to 0. That will give me two solutions here. So I can take x common. This will be 2x square minus 1. So x common. Okay, I can take 2x common. 2 will go anyways go away. This will be 2x square minus 1, that is equal to 0. So x can be, okay, I have got three solutions. X can be either plus minus 1 by under root 2, or x will be equals to 0. So let me differentiate this function again, that is 12x square minus 2. Now at x equal to 0, this value is negative, right? So your double derivative is negative at x equal to 0. That means you will get a maxima. Okay, x equal to 0, your double derivative is negative. That means you will get a maxima. So maxima, and at x equal to plus minus under root 2, your function is simply, your double derivative is positive. That means this will, you will get a minima here. Okay, so they are asking me the minimum value. So the minimum value attained by the function is 0.5. So let me replace my x right here, plus minus, because it won't matter because the function is even. So it won't matter whether I put plus or minus 1 by under root 2. So this will be whole square, that is 1 by 2, whole square, that is 1 by 4, minus 1 by 2, that is minus 0.5. Okay, so it is minus of 0.5, and they are telling me the minimum value attained is plus of 0.5. So certainly this is wrong, but let me draw the function once. Can you draw the function with me? So yeah, if I draw the function, this will be basically, if you see that the highest power coefficient is positive. So at x equal to plus infinity and x equal to minus infinity, the function would be somewhat like this. This will be the behavior of the function, certainly, like just like a quadratic, but it is a quartic. That's all. Okay. Yes. Will it be exactly like this? No. Actually, what will happen? The function will behave something like this. Now, because if you see, it is a quartic function, so there will be certainly 4 roots. Right? There will be 4 roots. Okay, there will be 4. Sorry, hold on a second. There will be 4 roots, right? So it will start from here. It will start from here. It has touched here once, and yes, this will be the behavior of the function, right? Because it is a quartic function, that means there will be 4 points, 4 roots, obviously, where it will cross the x-axis. Now I can obviously see these are the 2 points of minima, right? You can see these are the 2 points of minima, that is minus 0.5. So the function f of x has two distinct points of minima. Yes, these are the 2 points that we have already calculated over here. So this option is certainly true. The minimum value is actually minus 0.5, which is wrong. So which is yeah, minus 0.5, but here they have told 0.5, so which is wrong again. The function f of x is an odd function. It is certainly not an odd function, it is an even function. If it is symmetric, it will be an even function. Now if they would have asked maxima, so here you are seeing that x equal to 0, we are getting a maxima. What is this? This is a local maxima. Local maxima. Here, actually at x equal to 0, this graph is not proper. X equal to 0, this will be 0. Okay. Yeah, x equal to, okay, x equal to 0, yeah, x equal to 0, the value is 0. Okay. So you are getting a local maxima here. So basically it has two roots at x equal to 0. If you take x square common here, right, what will be x square minus 1, right? So basically you have two roots at x equal to plus minus 1, right? And the other two roots are at x equal to 0 comma 0. So you are getting a maxima, but this is maxima is not a global maxima, it is a local. Whatever you do in the differentiation, right, all these are computed locally. So it is a local maxima. Your actual maxima is here at plus minus infinity, which is infinity, right? So just be careful of this. In this case, option 1 and 3 will be correct for this question. The block diagram of a control system is shown in the figure below, and g of s is given. Determine the maximum value of the gain k such that all the closed loop poles of the system lie on the left of the vertical, sorry, this will be plus, there is a typo, left of vertical s equals to plus 2. Okay, this will be plus, this will not be minus, just a bit of typo here. Yeah. Now what do they mean by left of s equals to 2, real part s equal to 2? So s equal to 2 is this line, this is my s equal to 2 line, correct? So now if they want to see how many poles lie on the left hand side of this, with route I only will be able to comment about s equal to 0, right? So what if I change my s equal to 0? So what if I change my map my transfer function, right? What if I map my transfer function to z plane, where z equal to 0 is nothing but s equals to 2 plane. So this s equal to 2 plane can be mapped to z equal to 0, because if I apply my routes RH criterion on z plane, I will be able to comment how many poles lie on the left hand side of z equal to 0, right? I will be able to calculate the condition. So and z equal to 0 will be nothing but s equal to 2 in the mapped plane. So s equal to 2, right? So I can take my 2 on the other side, s minus 2 equal to 0, and I know this, right, is nothing but z equal to 0. So s minus 2 would be equal to z. So I can replace this here, right? I can replace what? I can replace s with z plus 2. Okay, I can replace my s with z plus 2 in this equation, so that I can map it in what equation? In the characteristics equation, because this is a unity feedback system, this is just the OLTF. So the characteristics equation would be 1 plus g of s equal to 0. So that would be equals to s into s plus 1 into s plus 2 plus k equal to 0. So let me replace my s with z plus 2. Let me map it. So this will be z plus 2 into z plus 3 into z plus 4 plus k equal to 0. Okay, this will not be that easy and simple to compute, but we will try our level best. So this will be actually z square plus 5z plus 6 into z plus 4 plus k equal to 0, z cube 4z square 5z square plus 20z, and yeah, this will be 6z plus 24 plus k equal to 0. So let me rearrange the terms again. Because it's a third order system, I will use my shortcut. Okay, you can totally compute the route table, but I will use my shortcut. So this will be, so I will have to essentially compute for the condition where all the poles are on the left hand side of z equal to 0. So let me rearrange them properly. 9z square plus 26z plus 24 plus k. So I know for the system to be stable, basically for this z plane, for all the poles to lie on the left hand side or the system to be stable, the internal product must be greater than the external product. So basically 9 into 26 must be greater than 1 into 24 plus k. Okay, you can use the route table as well, you will get the same condition, right? So here essentially what is your 9 into 26? So 9 into 26 minus 24, that is coming out to be 210. So your k would be 210. This would be your answer for the question. The Bode plot of the open loop transfer function is shown in the figure below. Determine the phase margin of the system. So nothing has been mentioned, right, regarding the system. So I will assume a unity negative feedback system. Unity negative feedback system. Okay, that is what I will assume. Now we will have to determine the phase margin of the system in degrees, right? So first of all, to determine the phase margin, what do I need? I need the phase of my OLTF at gain crossover frequency, and I will add that phase with 180. That will give me the phase margin of the whole system. Cool. So here I see that like at what frequency there will be, like the gain crossover frequency means the magnitude of the OLTF is 1, and in dB scale it is 0 dBs. So I see this is the omega GC, but I don't know anything regarding the transfer function. If I want to calculate this, I have to calculate what is my transfer function, what does my transfer function look like. So I see, first of all, as you have to calculate, and you can see omega GC can be computed from the this graph itself. We don't need to calculate the DC, like we don't need to calculate this value. Okay, I will explain what do I mean. So let us first briefly see what is happening. So I see initially I have two zeros because the plot starts from minus 40 dB per decade. So at s equal to 0, I will have, not sorry, not 2 0, 2 poles. At s equal to 0, I will have 2 poles. So this will be k by s square, and then I see the slope increase to minus 20 from minus 40. So this will be s by, there is a 0, right? That's why the slope increase omega z plus 1, and then again I see again the slope changes from minus 20 to minus 40. So this will be s by, again I will encounter a pole. So this is my OLTF. Now how do I know information regarding these points? So this particular informations will help me, certainly it will help me, right? So this is what, this is the slope of the graph, right? So, and remember your omega always is in log scale. So simply writing the equation of a straight line, what is the slope of this particular region from this to omega z? What is the slope? The slope is minus 40 dB per decade. So minus 40 dB per decade, right? So what is the change in y? Final minus initial, 18 minus 46. 18 minus 46. What is the change in x? Change in x is, remember 46 dB is at 0.1. They have given this point specifically, and I need to calculate omega z, right? So it will be, remember your x axis is in log scale, so it will be log base 10 final minus initial. Final position is omega z, initial position was 0.1. So with this I will be able to solve for omega z. Let us solve for omega z. So 18 minus 46 upon 40, 10 into 0.1. So your omega z approximately comes out to be 0.5 radian per second. Now similarly, I will use the same method to calculate omega p. I will use the same method to calculate omega p. So again, what is the slope in this region? Minus 20. Minus 20. Final minus initial. Final value 6 dB, initial value 18 dB. 6 minus 18 upon log of final minus initial. Now initial value is now my omega z. Initial value is my omega z, that is 0.5. So this will be equals to 12 by 20, 10 raised to power this into 0.5. So your omega p comes out to be 2 radian per second. Omega p is 2 radian per second. We need one more information. So we got our transfer function, right? We certainly got our transfer function, but I need the value. Either I need to calculate k, or I can directly see the graph itself what is the omega gc point, right? So we can calculate that. So again I will apply again the same formula. In this region, what is the slope? Minus 40. What is the final value? Final value is 0 dBs. Initial value is 6 dBs. So 0 minus 6 log 10 omega final omega gc upon initial, it is 2, right? This time the pole is the initial value. So this will be 6 upon 40, 10 raised to power this into 2. It is basically 2 root 2. Your omega gc is 2.82, or it is 2 root 2. So we got our omega gc, right? Now we can actually calculate. And you will say, sir, do I need the k? We don't need the k. For phase margin, we don't need the k. Why? Because we know omega gc. And when I calculate the angle, right, what happens? Simply this k is not used, right? The angle of k is 0, right? So yeah. So what is g of j omega? It will be k upon j omega whole square, that is minus omega square. It is s by omega z, that is j omega by omega z. Omega z is 0.5 plus 1 upon j omega by 2. J omega by 2, right? J omega by 2. Yeah. So we got our j omega. Now what is the angle? So what is the angle contributed by k plus k? K is a positive parameter. Nothing is mentioned. K is a positive parameter, and you will calculate k as well. It will come out to be positive because k is positive, right? You can see it is lying above 0 dB axis. K will be positive. Like we know k certainly is positive. Now k will contribute 0 degree angle, right? Now minus omega square will contribute how much angle? Minus 180, because I have a so this negative sign can go at the top, right? So this negative sign will contribute a minus 180 degrees of angle, plus tan inverse, the 0 will contribute omega upon omega z, that is simply tan inverse 2 omega minus tan inverse omega by 2. This is the angle contribute. Now what will be the phase margin? Phase margin would be 180 plus of angle, right? So this whole thing at what? At omega equals to omega gc. So my omega would be equals to omega gc, that is basically 2 root 2. 2 root, I'm just writing this in rough. So if you calculate this thing, approximately your angle will come out to be 25.26 degrees phase margin. Okay, so this will be your answer. 25.26 degrees certainly will be your answer. Now if you guys might have doubt, so sir, we don't need the value of k, is this proper or not? It is proper. So after writing down your this equation, right, you compute the gain of your OLTF at omega equals to 2 root 2, right? and from here you can solve what is the value of k. I will tell you what is the value of k. K value will approximately come out to be 2. How? So you write 20 log k is equals to 46 divided by what? So remember, we are calculating the gain at 0.1. So if I calculate the gain at 0.1, what will happen? These values will be ignored. These values can be ignored. This has been taught in the full course. So approximately the gain at 0.1 would be k upon omega square. That will be coming out to be equals to approximately 200 and omega is 0.1. So k will come out to be approximately 2. Okay, like that you can solve. Obviously you can verify whether this is actually the gain crossover frequency or not by computing the gain at the gain crossover frequency. So I think the discussion regarding this question is over. This was a good question. Answer would be 25.26.
Yeah, so let's see the solution of this problem. So here what is the scenario? Silicon semiconductor was there, intrinsic carrier concentration is given. In the sample what we are doping the boron atom. What is the meaning of boron atom? It will be acceptor or it will be donor. Other one is phosphorus. Phosphorus is donor. Boron is acceptor. Boron, carbon, nitrogen. Acceptor, nothing, and this is your donor, right? So boron is donor. So what is the value of Na? Na value is 10 to the power, sorry, boron is acceptor, no donor, boron is acceptor. So Na is 10 to the power minus 11, 10 to the power plus 11, and phosphorus is there. What is the value of Nd? 1.5 into 10 power 11. It is given that 60% of the acceptor atoms are ionized. 60% of this is ionized. What does that mean? What will be the value of Na plus? 60% of this. That means 0.6 into 10 to the power 10. And 10% of the donor atom, only the 10% of this is ionized. What does that mean? It will be 1.5 into 10 to the power 10. Is that understandable to you? 60% means here it would be 0.6 to the power 11 actually. Or you can say 6 into 60% of this. Can you find out the 60% of this? That would be 6 into 10 power 10. Very simple. And this would be 1.5 into 10 power 10. 10%, only the 10%. So it would be 1.5 into 10 power 10. So effectively, acceptor atoms that you are having is 6 into 10 power 10, and donor atom you are having is 1.5 into 10 power 10. This is the scenario. Okay. What they are asking, the semiconductor is working as a compensated p type or compensated n type. Who is more? Na is more. If you see, like, these are the doping, but out of this doping only 10% of donor was ionized and 60% of acceptors were ionized. What does that mean? Who is more? Acceptor is more. No, this guy is more than this. Na plus is more than Nd plus. What does that mean? It is compensated p type. So last option is correct. Next, what you need to find out? You need to find out the thermal equilibrium electron and hole concentration. So what you will find out, since it is compensated p type, so you can find out the thermal equilibrium hole concentration. What that would be? So that would be Na plus minus, I am not putting Na plus or this negative plus minus sign I am not putting. I am simply putting the formula. This is the formula. I hope you remember it. Na minus Nd by 2. This time you cannot ignore anything, right? Usually what we do is that, sir, directly we write down Na minus Nd. So that's the formula. But Ni value has to be much lesser than Na minus Nd. But if you see here, Ni is comparable. Ni is 1.5 into 10 power 10. So it is comparable value now. Since it is comparable, you cannot ignore it. So what will be the scenario now? Na is 6 into 10 power 10 and Nd is 1.5 into 10 power 10. 6 into 10 power 10, 1.5 into 10 power 10. So it would be 4.5 into 10 to power 10 divided by 2 plus 4.5 into 10 to the power 10 divided by 2 plus 1.5 into 10 to the power 10 whole square. Right? This is the scenario. Yes, sir. So now we need to take the calculator. So this will become 2.25 whole square, and then 1.5 whole square will be 2.25. So if I can do the calculation smartly, this will become 2.25. 2.25 whole square plus 1.5 whole square itself will be 2.25. 2.25. If I take the under root and then taking the under root, then 10 to the power 10 will come outside plus 2.25, because this will also become 2.25. So in one step only I have done the calculation and I am getting 4.95 into 10 to the power 10 centimeter cube inverse. This is my hole concentration. So 4.95 into 10 power 10, this is the hole concentration. And for here, what will be the electron concentration? That would be Ni square by P. What is the value of Ni square? 2.25 into 10 to the power 20 divided by 4.95 into 10 to the power 10. So simply take the reciprocal, multiply with 2.25. You are getting 0.454 into 10 to the power 10. So it could be 4.54 into 10 to the power 9 centimeter cube inverse. Next one, what you need to find out? Total current density you need to find out. So for that, what is given? Intrinsic silicon is having the resistivity. If resistivity is given, can I find out the conductivity? Yes. What will be the conductivity? Conductivity will be 1 by 50. And everything is given in centimeter. Okay, so this is the conductivity of intrinsic semiconductor. What does that mean? It is the value of Niq mu n plus mu p. Right? Now Ni value you have, Q value you have. From here you can get the value of mu n mu p. So let's try it out. Mu n plus mu p. Why I need value of mu n plus mu p? Because eventually what I need to find out? Current density. What will be the current density? What will be the formula of current density? That would be N Q mu n. J would be sigma E, right? So N Q mu n plus P Q mu P multiply with the electric field. This will be the scenario. So I have the value of N, I have the value of P. I will have the value of Q as well. I will have the value of E as well. I need the value of mu n and mu P. So that's my target. That's why from here I am doing it. Mu n plus mu P would come out to be 1 by 50 into 1.5 into 10 to the power 10. Sorry, 1.5 into 10 to the power 10. Yeah. And 1.6 into 10 to the power minus 19. So 10 to the power 9 will go upward. So 50 into 1.5 into 1.6. 5 into 1.6. And 10 to the power 9 would go upward. Reciprocal into 10 to the power 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it is coming out to be a very large value actually. Mu n plus mu p is coming out to be 8333333.33. Yeah. And what is the other thing is given? Mu n ratio mu p is given, that is holes to electrons. So mu n is twice of mu p. So from here I can find out the value of mu n. What that would be? Or first I will find out the value of mu p. So if I divide it by 3, then this would be 27777.77, and mu n would be 55555 6 times 0.55. Very strange values we are getting. Okay, so 1.6 into 10 power minus 19. Q I am taking outside. N into mu n. What is the value of n? 4.54 into 10 power 10. 4.54 into 10 power 9 will be multiplied with this into 4.54. So 2.52 I could have written it down in a better manner. Now what I am doing, like this calculation is very, I have done it in a very strange manner. Better way would have been there. This will be simply, let's do the calculation again, not a good way I am doing. 50 into 1.5 into 1.6. So 0.833 and 10 to the power 9 is there. Let's take 10 to the power 3 outside. So 8.33. 8.33 into 10 to the power 6. This is the scenario I am getting. So 8.33 into 10 to the power 6. Let's do it better. Okay. So this is 10 to the power 6. Mu n value would come out to be simply divided by 3. So 2.77 10 to the power 6, and it would come out to be 5.55 into 10 to the power 6. This is a better way. Now Q is outside, n value is 4.54 into 10 to the power 9, and this value is 5.55 into 10 to the power 6 plus, what is the value of P? Value of P is 4.95 into 10 to the power 10. 4.95 into 10 to the power 10. Mu P is 2.77 into 10 to the power 6. And then there is an electric field. What is the value of electric field? 3 volt per centimeter. Multiply with 3. So this is the answer we will be getting. Sir, why is so much of strange calculation? These kind of strange calculation have come in the examination as well. That's why I framed this kind of question. Okay, don't feel like that, sir, why you gave this strange calculation, because mu and mu P value 1350, 650, these values we have seen. But you are giving 2.77 into 10 power 6. Yes, because these kind of calculation have actually been asked in the examination. That's why. Okay, so 2.77 into 4.95. 2.77 into 4.95. From here you are getting 13.75. And what about this 4.54 into 5.55 plus 13.75? 10 to the power 10 will be outside, 10 to the power minus 9, then 1.6 into 3. 6 into 3. From here 10 to the power, this is 10 to the power 16, this is 10 to the power 15. Into 5.55 plus 13.75, 16.2697. So basically the scenario is 1.6 into 10 power minus 19. When you solve this particular thing, you are getting 16.2697 into 10 to the power 16 into 3. This is the scenario you are getting. Okay. Now you multiply with 3, multiply with 1.6. Again, like very rough calculation, but yeah, it is what it is. So 78.09 milliampere per centimeter square. So eventually answer is matching 78.16. But yeah, rough calculation was there, very rough calculation. I would say very, very rough calculation, but one or two question could be calculative, no, in the examination. I hope you are not much worried about it. One or two question could be calculative, right? So till this point there was not much calculation involved. Till this point it was easy. Till this point you should be comfortable. But then this calculation came into action. So it took me 12 minutes to solve this problem. So yeah, should I do something with this? Shall I remove this option? I will try to remove this one so that this question become easy. Okay, otherwise this calculation is taking so much of time. Otherwise, let's keep it. Okay, I will keep it. Okay, I will just simply keep it because I want people to solve some calculation things as well. So let's keep it there. Yeah, so this is the pulse shape that is given. You need no ISI condition. So for no ISI condition, what is the scenario? For the pulse shape, if you take the Fourier transform, then the Fourier transform should satisfy this condition. Which condition? This condition it needs to satisfy. That should be equal to constant. Is this condition correct? No. People actually forget the mode. Mode should also come. Okay. So mode of this should be constant. And n taking value from minus infinity to infinity. So this is the condition of 0 ISI. Is that understandable to you? Now what is the value of RS? What is the symbol rate here? Symbol rate is 4 kilo symbols per second. 4 kilo symbols per second. So what will happen? Sir, whatever this setup is there, or whatever this frequency spectrum is there, this is minus A, this is minus B, this is plus A, this is plus B, and this is the center. So center will be shifted to 4K. This center will be shifted to 4K. Center will be shifted to 4K. And then this center will be shifted to 4K. So what this point would become? Sir, minus B plus 4K, minus A plus 4K. So basically in that manner, this will be the scenario you will be getting, no? This is how you should fix it, so that it becomes constant. The total gain you want to be constant. So whatever the way it is increasing, the same way it should decrease, and the way it is decreasing, the same way it should increase. So you want everything to be shifted to 4K. This would be here, it is shifted to minus 4K in that manner, right? So if this point is 0 is shifted to 4K, so what this point would become? This point would become 0 is shifted to 4K, So this point would be shifted to 4k minus b. Say yes or no. Are you able to understand this point? 4k minus b, and what this point would be? This point would become 4k minus a. That means your 4k minus b should be equals to a, or you can say 4k minus a should be equals to b. If this is the condition that you are satisfying, then it would become constant. Let's just say if this is the scenario. If this is the scenario, after shifting, this has become something like this. Now what will happen? If you add these two waveforms, if you add these waveforms, what will happen? This is how it will go. And then here you will see that they are not perfectly cancelling out each other. No, basically 3t and you add minus 3t. 3t plus 2 and add minus 3t plus 2. What you will be getting? 4, constant value. So what will be the graph of 3t plus 2? The graph of 3t plus 2 would be like this. And what will be the graph of minus 3t plus 2? That would be minus 3t plus 2. So this is the graph of 3t plus 2. And the graph of minus 3t plus 2, that would be somewhat like this. Right? So they should be like perfectly cancelling out each other. Whatever the decreasing slope is there, the same increasing slope should be there. Basics of signal system. Okay. So what you are getting from here? So this condition should be satisfied. So a plus b should be equals to 4k, or from here as well b plus a should be equals to 4k. So what is the answer? 4. That's it. Simple condition, f minus nrs should be constant. What I will do is that I will just take its clone. This is having a center at 0. It will have a center at 4k, 8k, 12k, 16k, minus 4k, minus 8k, minus 12k, minus 16k. In that manner, I will simply add them up. When I add them up, I should get a constant value. That means decreasing slope here should be equals to increasing slope. What does that mean? That means this point should be common in both of them. So 4k minus b should be equals to a, or you can say 4k minus a should be equals to b. So from here what you are getting, this is what you are getting. A plus b should be equals to 4k, a plus b should be equals to 4k. So a plus b value is 4 kilohertz. So answer will be 4. All good? Let's go to the next. Yeah, passband communication is there. Bandwidth is, so band pass filter is there between 1 kilohertz to 4 kilohertz. That means what is the bandwidth? Bandwidth is 3 kilohertz you are using. What is the bit rate? 6 kilobits per second. And which scheme you are using? Raised cosine. And what is the value of 8qm? What is the value of capital M? That is 8. That means what is the value of capital N? That is 3. Raised cosine spectrum you are using, and it is band pass communication. Since it is band pass communication, so what should be the bandwidth? Bandwidth should be greater than equals to what? RB by 2, but in place of RB you will put 2RB. Why 2RB you are putting? Because it is band pass communication. Multiply with 1 plus alpha. This is the scenario. This was the scenario for 2 array scheme, but it is 8 array scheme. That means it will be divided by 3 as well. So I have taught a certain method how to solve these kind of problems, right? M array scheme, don't forget to divide by 3. RB by 2 we put, but here we will be putting 2RB by 2. Why 2RB? Because it is band pass, right? So everything is known now. You will be able to solve the problem. Bandwidth is 3 kilo. What is the value of RB? 6 kilo. 2 and 2 getting cancelled out, divided by 3. 1 plus alpha. What you are getting? Alpha is coming out to be less than or equals to 0.5. Okay. So alpha is 0.5. So answer would be 0.500. Understandable? Very straightforward question. Very, very straightforward. Bandwidth based question it was. Yeah, so linear bilateral network is there, current source is there, VT waveform you need to comment on. Look, if series combination is there, then there is no chance that you would be getting exponential response, whether it is RL circuit or it is RC circuit. Basically, if this is your RL circuit and you are saying that I am exciting a constant current source, so what will happen? What will be the voltage? V equals to L di by dt. So here voltage will be impulsive and here the voltage will be constant. So total graph will be constant plus impulsive. That means no way there will be exponential graph. And if it is a RC circuit, then RC circuit with constant current source, what will happen? It will charge the capacitor linearly. So this graph will be linear and this graph will be a constant value, right? So constant plus linear graph will be linear only. So no way you are getting exponential. That means only two ways are left. It has to be a parallel combination of RL circuit. So if it is a parallel combination of RL circuit or RC circuit. So if it is a parallel combination of a RL circuit, then what will happen? Initially, what does the inductor will say? I am driving 0 ampere current. So whole current will be flowing through the resistor, right? So initially it is driving 0 ampere current. Whole current is flowing through the resistor. That means there is good amount of drop across the voltage. So across the inductor, what that drop will be? Let's just say this is R, this is current I naught. So voltage drop will be I naught R. And at the steady state, what will happen? Inductor will say that I will drive all the current. If inductor is saying that I am driving all the current, what does that mean? It will be shorted, right? So voltage will go from I naught R to exponentially decreasing. It will start from I naught R, exponentially it will decrease. But this is the graph of exponential charging. That means which option is that? Parallel with the capacitor, and we can see it as well. If it was capacitor here, then what would have happened? Initially capacitor will say I am shorted, I will drive all the current. That means initially he will say that I am having zero voltage. At the steady state, what he will say? I will be open circuited. That means all the current will be driven by the resistor. So how the capacitor will develop some voltage? It will develop some voltage there. What that voltage will be? I naught into R. So from 0 to I naught into R voltage it is developing. From 0 to I naught into R voltage it is developing. So this much voltage it is developing, e to the power minus t by tau. With from here tau value I am getting 0.5. That means this will be minus 2t. Okay. And what will be the value of I naught? I naught value is given as 1. R value is given as 0.5. So R value is given as 1 as well. I naught value is given as 1. R value is also given as 1. So, okay. So voltage is not going to be 2 volt here. It is coming out to be 1 volt at the steady state. If, yeah, so it should be 1 volt there. This should be 1. Because at the steady state, what will happen? Parallel combination of R circuit is there, 1, 1. Yeah, so it should be 1. Here I will change the data. It should be 1. Okay. In place of 2, it should be written as 1. Otherwise, answer would be none of them. Because at the steady state, how much? This is 1 ampere current, no? At the steady state, capacitor will say, I will not drive any current. That means whole current will be flowing through the resistor. And resistor is also 1 ohm. That means how much voltage it will take? 1 volt. So at the steady state, it will take only 1 volt. We have written 2 here, which is wrong. So it should be 1. I will modify it. Okay. Yeah. So this question was easy only. Should have been solved very easily. Yeah. So what about this one? What is the Fourier transform of, what is the discrete time Fourier transform of signum m? So you are supposed to remember this particular data directly. Answer is minus j cot omega by 2. But if you don't remember it directly, then you can derive it. So how signum n could be written? Signum n definition is also given. So how you can write down signum n? So definition could be written in this manner. You can see the graph 1, 1, 1 and then minus 1, minus 1, minus 1. This is minus 1, this is minus 2, this is 1, 2, 3 and at 0 it is 0. So can you write down the definition? Surely I can write down the definition, sir. It should be written in this manner. Say yes or no. Is this correct? Yes, sir. And then in the negative side, sir, it should be written somewhat like this. Is this also correct? Absolutely correct. So this is how you can write down the definition. Understandable? Okay. So once you have written the definition, can you find out its Fourier transform? Yes, sir. What will be the Fourier transform of delta n? That would be 1. Delta n minus 1, it would be having e to the power minus j omega plus e to the power minus 2j omega plus e to the power minus 3j omega and so on. Now minus. What about this one? Delta n plus 1. So it would be e to the power j omega plus e to the power 2j omega plus e to the power 3j omega and so on. So a upon 1 minus r minus a upon 1 minus r. Understandable? Right? Simple formula I have applied, nothing else. A upon 1 minus r, which is e to the power minus j, e to the power minus j omega, and here e to the power plus j omega. Understandable? Very easy. Now what I can do is that I can solve this one. But what I can do, I would take e to the power minus e to the power. Let's solve this one only. So 1 by e to the power j omega I will write down. What I will get? 1 upon 1 upon e to the power j omega upon 1 minus 1 upon e to the power j omega. So 1 upon e to the power j omega minus 1. This is what you will be getting. Okay. But I need to write down in the same manner. So I am putting this particular thing. You can solve it 1 upon e to the power j omega, 1 minus 1 upon e to the power j omega. So e to the power j omega, e to the power j omega will cancel out. This will go here, e to the power j omega minus 1. Negative sign you can take outside. Okay, minus e to the power j omega 1 minus e to the power j omega. Now what do you see here? For minus sign I can take common, e to the power j omega 1 minus e to the power j omega. Now what you can do in this kind of situation, what you need to think, sir, e to the power j theta plus e to the power minus j theta, this is something I will try to make. So what I can do, e to the power j omega by 2 I can take common. So what I will get here, e to the power minus j omega by 2 plus e to the power j omega by 2. Did you understand this point? Minus sign is already outside. Minus sign is already outside. This is e to the power j omega by 2. E to the power minus j omega by 2. Multiply both of them, it will become 1 plus e to the power j omega by 2. Similar thing you will do downward. E to the power minus j omega by 2 minus e to the power j omega by 2. Understandable? Fine. Okay. This and this is getting cancelled out. Let's take this minus sign inside. What I am doing, I am taking this minus sign inside. So what will happen? This will become plus and this will become minus. I have just taken the minus sign inside. Why is that so? Because now I will do divide by 2 divided by 2. Why I am doing divided by 2? This will become cosinusoid. What this will become? Sinusoid. If I need to make it sinusoid, I need to multiply with 2j. That means here I will have to multiply with j. Now this j goes upward, it will become minus j. So now this is becoming cos omega by 2. This is becoming sin omega by 2. Cos omega by 2, sin omega by 2, what that will become? Cot omega by 2. There you go. So you are supposed to remember it directly. Minus j cot omega by 2. What is the Fourier transform of signum n? Minus j cot omega by 2. You should remember it directly. In the examination, it can be asked. Signum n will have minus j cot omega by 2 as its Fourier transform. Okay, let's move to the next one.
A negative unity feedback control system has the open loop transfer function. The root locus of the closed loop poles is plotted in the S plane. Let A denote the point on the real axis. So root locus is plotted and A denote the point on the real axis uh, where the asymptotes of the root locus intersect. So I hope you know what are asymptotes of root locus, and B be the point where the B with the point on the real axis where the root locus breaks away. So basically they're asking me what is the breakaway point and what is the centroid, because wherever the asymptotes meet, it is called as the centroid, right, of the root locus. So determine the value of the A minus B. So roughly if I plot the root locus, if you remember, we have three poles, S equal to 0. Let me first not plot A, we will get an idea about A later on. S equal to 0, S equal to minus 1, S equal to minus 2. Okay, now if I plot the root locus, so we don't have any zeros, right? What are the angles of asymptote? So angles of asymptote would be equals to 180 minus 180 divided by p minus z. So that is 3 into like integers, right? Odd multiples basically. So it will be this will be minus 60 minus 180 and minus 300, right? So minus 60 would be, hold on a second, sorry, so not minus, plus 68 plus, like we can use plus minus, does not matter, ultimately we get the same values. Yeah, it will be plus, right? Sorry, so plus 60 would be somewhere here, right? So somewhere here I will have asymptote, and my plus 300 would be, this is 180 and another 120, it would be somewhere here, basically minus 60 plus 300 is nothing but minus 60. So I have two asymptotes here, and minus 180 also I will have asymptote. So obviously we know in the real axis, if it's a normal root locus, right, not complementary, then we know at like root locus will exist if on the right hand side I have odd number of poles plus zeros. So of course root locus will certainly exist in this whole region, and in this region as well root locus will exist because I have odd numbers of poles and zeros. So basically I see this pole will terminate with this virtual zero with this asymptote, and these two poles will break away and basically terminate here. I exactly, yeah, I think it will be somewhere here actually. This point will be somewhere. I will exactly tell you why this point will be somewhere here, exactly here. Just You can draw the root locus, you'll see. Okay, so this, right, wherever the asymptotes meet is called as a centroid, and this centroid actually, that is equals to A in our case, right, the point that is equals to the sum of the poles. Sum of the poles, what is the sum of the poles? S equal to 0 plus minus 1 plus minus 2 minus sum of the zeros. I don't have zeros, so I'll put there 0 only. Don't know zeros I have. Divided by number of poles minus number of zeros. So number of poles I have 3, number of zeros I have 0. So essentially it is actually equals to minus 1. Okay, how to remember this formula? Very simple, right? Sum of p minus sum of z upon p minus z. I don't think you have to remember like how to remember. I have explained this in the RPYK course as well. Please visit, so please watch those videos. There I have explained this properly. So this is minus 1, right? Now, so my centroid or A value is minus 1. What is the breakaway point? For calculating the breakaway point, basically what needs to happen is your k is equals to what? So we have this formula, right? So the characteristics equation, that is 1 plus g of s, that is s into s plus 1 into s plus 2. This is my characteristic equation, that is equals to 0. So from here I get the value of k. K value would be minus of s into s plus 1 into s plus 2. And we know whenever there is a breakaway or break-in point, the value of k is either minima or maxima in the near neighborhood. It is a local minima maxima. This concept also has been taught in the RPOIQ course. So we will certainly calculate the different derivative of this. So let me first rearrange this. Minus sign would be outside. S into s square plus two s, right? Now I will differentiate this plus 6s plus 2, and now I will equate this equal to 0, that is the point of maxima or minima. So yeah, this will be minus b plus minus b square minus 4ac. So 8 into 3, that is 24 upon 2. So this will be minus 6 plus minus 12, right? Under root 12. So under root 12 will be 4 into 3. So 2 under root 3 upon 2. So this will be basically minus 3 plus minus uh, root 3. Now, of course, we will not choose the negative solution. Why? Because that point, I'm getting 2 points. One is 3 minus root 3, another one is minus 3 plus root 3. So if you see, minus 3 minus root 3 will be lying somewhere here. Do I have a breakaway point? No, I don't have any breakaway points. So anyways, you will have to draw the root locus. If you don't draw the root locus, you will not be able to eliminate this solution. So this is not correct. This is certainly correct. What is minus 3 plus root 3? So approximately minus 3 plus root 3 would be minus 1.26. Okay, hold on. That also does not make sense. Somewhere I'm making mistake. Just give me a second. Right. Just trying to check what is happening. Somewhere I'm making a huge calculation error. Okay. S plus 1 s plus 2. So s square plus 3s plus 2 s cube plus s3 square plus 2s. Now I will differentiate. This will be 3 square. This will be 6s plus 2. B square minus, oh sorry, 2a, right? 2a. Every time the coefficient here is 1, so be very careful regarding these mistakes. It is 2a, right? So just be careful, you can make this mistake in your exam hall. 2 into a, so this will be 2 into 3. Okay, don't make this mistake. Don't make this mistake. Okay, sorry. Yeah, now I think it is fine. So this is 6 actually. Is 6. So this will be minus 1 plus 1 by root 3. Okay, so minus 1 plus 1 by root 3 is one solution, and minus 1 minus 1 by root 3 is another solution. Now, again, the same reasons, I'll obviously ignore this -1 by root 3 because root locus does not even exist here, right? There cannot be any breakaway point here. So breakaway point will be only this one. So what is this value? Root 3 inverse -1, that is minus 4.22. This is my B point. And what have they asked? They have asked me the value of A minus B. A minus B. A is -1, right? So A is -1. So A minus B would be equals to -1 minus of minus 4.22. Hold on now. This is -1, this is plus, yeah, minus 0.577. Okay. So minus 0.577. This is your answer for the question.
Yeah, this question here you need to find out the maximum number of detectable and correctable error. So here there is new thing which you might not have studied, eraser. Look in the NPTEL playlist, this particular concept has been mentioned, eraser. It might not be there in your gate notes. If you have studied from this platform, it is completely available for free on YouTube. Coding theory, completely available. Okay, coding in communication system, completely 6 hours of video is available. Information theory is also there. You can study from there. If you don't know about eraser, then I am simply telling you one thing. If you want to know the detailed concept of eraser, you can study from the comprehensive course, which is available on YouTube. Okay. Now, if you want to know about eraser, then simply you would remember one thing, that eraser will just affect the D minimum value. Whatever the D minimum you are getting, now what they are saying, one eraser has occurred. That means whatever the D minimum we were actually getting, now the actual D minimum would become D minimum -1. Let's just say previously my D minimum was 3. So now my one eraser has occurred, so D minimum would become 2. So here I am writing down effective D minimum. Let's just say eraser is R. Eraser is R. Eraser is R. Before eraser, my D minimum was D min. After the eraser, the D minimum would become D minimum minus R. This is the effective D minimum you will get. It can be introduced in your examination. Why is that so? Because it is given in NPTEL, and this same question has been taken from the NPTEL assignment only. Okay. Now, if you know the D minimum effective, let's call D minimum effective as D star minimum. Okay, I am calling this as D star minimum. If you know D star minimum, can you tell what will be the number of error that can be detected? That would be D minimum star -1. That would be the number of error that can be detected. And how much error can be corrected? That would be D minimum star -1 divided by 2, right? But you just need to take the integer value, and lesser integer value you will take. Let's just say this value is coming out to be 1.5. So you will say one bit of error could be corrected. Okay. So less value we need to take. So our target is to find out, first I need to find out D minimum. Eraser value is already given, that is 1. So my target has become finding out D minimum. Using the parity checker matrix, can you find out D minimum? Surely I can find out. Using the generator matrix, can you find out D minimum? Surely I can find out. Using the parity checker matrix, can you generate the generator matrix? Yes, I can generate. So first way would be, method 1 would be that you make the generator matrix. How can you make the generator matrix? How can you make the generator matrix? So if I see here, these are my, if I look closely, this is the identity matrix here, and these are my parity bits. So parity bits transpose I need to take 0 1 1 1 1, I will be getting 0 1 1 1 1. Next 1 0 1 1 1 0 1 1, then 1 1 0 1 1 1 0 1, then 1 1 1 0 1 1 1 0, and then what I will do, I will simply make the identity matrix. Okay. Now here what you need to find out, minimum weight. Weight is 4. Weight is 4. Weight is 4. Weight is 3. So minimum weight is 3. That would be your D minimum. So D minimum was 3. What will be your D minimum star? Sir, one eraser has occurred. So D minimum would become 2 now. Effective D minimum would become 2. अरे भाई वेट 4 है ना यहाँ पे भी. This is also having a weight of 4, no? 1 2 3 4 1 2 3 4. Yeah, weight is 4. So this is 4 actually. This is 4. This is also 4. 4 minus 1. Effective D minimum has become 3. Right? So now maximum number of correctable error. what that would be? Sorry, detectable error, that would be 2. And how much correctable would be there? 2 divided by 2, that would be 1. So what will be the answer? 2 1. 2 1. Answer would be this one. Okay. From the H matrix as well, you can tell D minimum directly. How do you tell it? From the H matrix. First, you see that, sir, if there are two rows identical, sorry, two columns identical, is there any two column identical? No. That means D minimum cannot be 2. Then what you will say? Sir, I will XOR any two columns. If you do the XOR of 1 0 0 with 0 1 0 0, what you will get? 1 1 0 0. Do you get 1 1 0 0 anywhere? 1 1 0 0 1 1 0 0? No. Then what you will do? You will do the XOR of 3 columns. What you will be getting? 1 XOR with 0, XOR with 0, 1. 0 XOR with 1, XOR with 0, 1. 1, then 0. Do you get 1 1 0 0 anywhere? 1 1 1 0. Yes, sir. Here I am getting 1 1 1 0. That means XOR of these three guys is matching with this particular guy. So how many lines you have to take? How many columns you have to take? 3. 3 columns I have to take. That means my D minimum would be 4. If I had to take only one column, let's just say this 1 0 0 0 was matching with 1 0 0 0 somewhere. If this was matching, this 1 0 0 0 was, another column was this 1 0 0 0 only, then D minimum would have been 2. Okay, directly two columns are matching. If you take the XOR of 2, what you are getting? 1 1 0 0. So in place of 1 1 0 1, if it was 1 1 0 0, then your D minimum would have been 3. Two columns if you are taking, D minimum would be 3. If 3 columns you are taking, D minimum would be 4. If 0 column you are taking, that means one and other column is matching. Basically the point is this column, this column, this column and this column. If you take the XOR of all these 4 columns, what you will be getting? 0. 1 XOR with 0, XOR with 0, XOR with 1. What you are getting? 0. So 4 columns XOR you are getting 0. That means D minimum would be 4. 3 column XOR if you are getting 0, D minimum would be 3. 2 columns XOR if you are getting 0, D minimum would be 2. And D minimum can never be 1. Okay. D minimum can never be 1. So if you can directly sense, then from here only you would be able to tell that sir D minimum would be 4. Then you would be able to solve in this manner. So answer would be 2 1. Yeah, so let's see the solution of this one. So here, what is the scenario? What is this make before break switch? That means it will make the connection before breaking the other one. Okay, like if you are moving from A to B, then like basically the scenario is this inductor will be driving some current, right? Inductor will be driving some current. This is driving some current, right? Now you are saying that sir, I am breaking this connection. This is connection A, this is connection B. You are breaking this connection and you are connecting here. So there will be a time where the connection is broken. Like it will be gone from A as well, it will be not connected to B as well. Like when you have broken the connection from A and you are going towards B, so there will be one time where this current source will be open. What is the meaning of open current source? What is the meaning of open current source? There is no meaning of open current source. That means what is the meaning here? Make before break. What does that mean? That first it will make and then it will break. Is that understandable to you? So this is like, this will not be helpful in solving the problem. But conceptually, if I need to frame the problem correctly, then I need to use make before break switch. Understandable? What is the meaning of make before break? That first it will make the connection and then it will break it. So current source should have some connection, but this is not necessary with voltage source. If this is the condition, you are happy with that, there is no problem. Voltage source could be open, but current source open, what does that mean? You are saying that here 5 ampere current is there, and since it is open circuited, you are saying that 0 ampere current should be there. So 0 ampere, 5 ampere doesn't make any sense, right? So that's why make before break switch. Yeah, so now what is the scenario? At t equals to 0, this is connected to A. It will be connected for 1 second. Then what will happen? Inductor is exposed to a constant voltage. What will be the current it will be developing? 5t by L, right? Constant voltage means current would be Vt by L. That would be 5t ampere for 1 second. So current would be built up t from 0 to 1. So current that would be built up is 5 ampere. Now the current that has been built up here is 5 ampere. Now the switch has moved to point B. Now this is the scenario. 1 Henry, then there is a resistance 1 ohm, and then there is 2 Henry. Okay, the current here is 5 ampere. So what you did here, you applied Laplace transform. If you apply Laplace transform, that means you did not study from this platform. You should study from this platform as well. Or if you have studied from gold educators, then you might be applying Laplace transform as well. But you can solve it in time domain as well, because it is a first order circuit. If it is a first order circuit, it can be solved with the time domain analysis as well. What is the scenario? This inductor will say that I will drive 5 ampere current. What this inductor will say? He will say that I will drive 0 ampere current. He will say that I will drive 5 ampere current. Both are in series. Both are in series. One is saying 5 ampere, one is saying 0 ampere. Both guys are in series. What does that mean? That means they will have to shake the hands, or they have to conserve the energy. So what will happen? They will immediately change their current. Okay. You will say that, sir, in the inductor, immediate change in the current cannot take place, but it will take place, because there is infinite voltage, or there is impulsive voltage. How impulsive voltage, all these points I will not explain now. In the comprehensive course I have explained. So there will be immediate change in the current. 5, 0. So immediate change. This 5 will come to what? L1 I naught, 5 into 1. L2 I naught, 2 into 0 divided by 2 plus 1 divided by 3. So this 5 will come down to 5 by 3 ampere. And this will also, from 0 to it will go to 5 by 3 ampere. So this 5 by 3 ampere will be flowing in the circuit like this. 5 by 3 ampere. So this is the current that has been set up at 1 second. Just as the switch is, all this has happened in 0 time. Just as the switch has moved to point B, all these things has happened. So what is the value of IT you are getting? What is the value of current at 1 second you are getting? That is coming out to be minus 5 by 3 ampere. And at the steady state, what will happen? What will be the value of current? What is the value of this current at steady state? At the steady state, both of the inductor will say that, sir, we will be shorted. At steady state, both of the inductor will say that, sir, we will be shorted. If both are shorted, this is 1 ohm resistance. Both inductors are shorted. So how much voltage is there across this resistance? So 0 volt. That means how much current it is driving? 0 ampere. So how much current will be flowing through the inductors? 0 ampere. So at steady state, this current would be 0. So you are going from minus 5 by 3 to 0. From minus 5 by 3 to 0 you are going. But you started at 1 second. What is the value of tau? Both are in series. So both will be added. So L by R, tau value is 3. You started at 1 second. So minus 5 by 3. This is the equation of your IT. Minus 5 by 3 e to the power minus. Started at 1 second. Started at 1 second. You need to find out the inductor current at 3 seconds. So 3 minus 1, that would be 2 divided by 3. So this would be your answer at t equals to 3 seconds. So minus 5 by 3 e to the power minus 2 by 3. Minus 0.855 ampere. This is the answer we are getting. So this is the answer we are getting. Okay, minus 0.855 ampere. Understandable? All good? How did you check the direction? Sir, this was 5 ampere, then it became 5 by 3 ampere. Now the current will be flowing in this direction only, no? Previously, when 5 ampere was there, it was flowing like this. Then it became 5 by 3 ampere. So it will flow in the same manner. Understandable? So basically this 5 ampere has developed some current in this particular inductor. So it will flow in this direction. The current direction will not change immediately. From 5 to 5 by 3 we are going. In this direction only. So this is how I can define the direction of current. Okay, well and good. Yeah, let's see the next. Yeah, so you can call it mathematics or you can call it communication, whatever you want to call it. So random variable x is given. This is the condition that has been told, and fx of x is the CDF of x. Which of the following statement are true? So what condition have been given? Let's see the condition that has been given. This is the condition that has been given. So what this could be written as? So this could be written as fx of minus 3. What about this? So let's just say, sir, I try to make this particular thing. But sir, this is not anything, right? Sir, CDF is probability of x taking value lesser than equals to x. So sir, here I need equal sign. So can I do something like this? If you put a equal sign, that means you need to subtract the probability of x equals to 3. Understandable? Did you understand this point? If you put the equal sign here, that means it was actually probability of x less than 3. But if you are taking lesser than equals to 3, that means you need to subtract this probability of x taking value equals to 3. Understandable? Very easy. 1 minus probability of x taking value lesser than equals to 3 plus probability of x taking value equals to 3 would be equals to fx of minus 3. Now this could be written as fx of 3. So what you are getting, probability of x taking value equals to 3 is coming out to be fx of minus 3 plus fx of 3, and this one goes here minus 1. So this is the answer you are getting, which is the first option. So first option is matching. Now what about probability of mode of x greater than 3? Probability such that mode of x is taking value greater than 3. Probability such that mode of x is taking value greater than 3. What does that mean? That means x should be less than minus 3 and x should be greater than 3. Understandable? I hope this is clear to you. X should be less than minus 3. That means mode of x would be greater than 3 and x should be greater than 3. X should be less than minus 3. Doesn't suit to me. What I would do? So I need less than equals to sign. No, I need less than equals to sign. So what I would do is that probability of x less than minus 3, this I can do, minus probability of x taking value equals to minus 3. Understandable? Or can I do anything from here? No. So can I write it down in this manner? Probability of x less than equals to minus 3 minus probability of x taking value minus 3. And probability of x taking value greater than 3. What I can do? 1 minus probability of x taking value lesser than equals to 3. Is that understandable to you? X taking value greater than 3. That means apart from 3, all the values will be taken. X taking value lesser than equals to 3. That means all these things. So from 1 minus this probability, if I subtract, I will get this particular scenario. I will get this particular scenario. I hope it is clear. So what is this? Fx of minus 3. What is this? Fx of 3. This is your fx of 3 plus 1 minus probability of x of minus 3. So let's see what options are saying. Options are saying something else. We are getting something else. So let's see what we can do. So let's keep this one as it is. I can do something with this. Probability of x taking value minus 3. Probability of x taking value 3. This probability was fx of 3, fx of minus 3, fx of 3 plus fx of minus 3 minus 1. So can you let me know what will be the probability of x taking value minus 3? What that would be? In place of 3, you just put minus 3. So this will be minus 3. This will be plus 3 and minus 1. So this particular thing would be equals to this. So from here what I can get? This is your fx of minus 3 minus fx of 3 plus 1 minus, here what I will put? Fx of minus 3 minus of fx of 3 plus 1. So this and this is getting cancelled out. What you are getting? 2 minus 2 fx of 3. So 2 into 1 minus fx of 3. This is the answer we are getting. 2 into 1 minus fx of 3. There you go. This is also matching. Okay. Did you understand this point? So just whatever that is given, just keep on writing it down. Something will match up for sure. I just needed to eradicate this guy. I eradicated this guy from the last thing that I derived. So this is how I can eradicate it. Let's go to the next one. Mode of x less than equals to minus 3. Sorry, mode of x less than equals to 3. Probability such that mode of x less than equals to 3. What I can do? X taking value less than equals to 3 or x taking value greater than equals to minus 3. Understandable? Mode of x less than 3. Can you solve it? Yes, sir. If x is greater than minus 3, that means x is minus 2. So minus 2, if you put 2, will be less than 3. So that is fine. So this is fine for me. This is fx of 3 only. So no issue here. But problem is with this guy. So can I write it down in this manner? But probability of x greater than minus 3, have I encountered it somewhere? Did I encounter it somewhere? Okay, did not encounter it. So let's go by this method. So is this fine? Probability of x taking value greater than equals to 3. greater than equals to minus 3. That means 3 is also included. Greater than equals to minus 3. So can I write it down in this manner? 1 minus probability of x taking value less than minus 3. Right? All these values. Now fx of 3, let's not do anything with this. Let's not do anything with this as well. But here we will do something. I am writing it down in this manner. Is that understandable? Is that fine for you? Probability of x taking value equals to 3. Right? So what we are getting? Fx of 3 plus probability of x taking value plus probability of x taking value 3. Directly you would have written down from here to here. Probability of x taking value greater than equals to 3. What that would be? 1 minus probability of x taking value less than equals to minus 3. But here what you have subtracted? You have subtracted the probability of x equals to 3 as well. That you need to add up. Right? So that I have added up. So directly from here to here you would have written. Now fx of 3 it is. This is minus fx of minus 3 plus 1. What is this particular thing? So this particular thing you can copy from the first one. Fx of 3, fx of minus 3 minus 1. Fx of 3, fx of minus 3 minus 1. So this and this is getting cancelled out, and 1 is also getting cancelled out. But what they are saying here, 2fx of 3 minus 1 is the answer. Probability of mode of x taking value less than equals to 3. So let's just say x should be less than equals to 3. Okay, fine. X should be greater than equals to minus 3. This is how I cannot break it. It should be between minus 3 to 3. I cannot break it that it should be less than 3 adding up with greater than minus 3. That is wrong actually. But here I could have done it. That greater than 3, because here nothing is common, no? This is 3, this is minus 3. This I could have done. Less than minus 3, greater than minus 3. But here I will explain you, but I myself did some error here. This is 3, this is minus 3. So it should be in between. Look, the point is mode of x less than equals to 3. That means x should be between minus 3 to 3. And mode of x greater than 3. That means x should be greater than 3 and less than minus 3. So there is nothing common here, no? Greater than 3, minus 3. So both guys are independent to each other. So directly you can break it down in plus sign. Something like this. But here I cannot break it down in plus sign like this. So this is whole wrong. What I will have to write down? I will have to write it down in this manner. In what manner? That this is how my x should be. So how it can be broken? Probability of x taking value less than equals to 3 minus probability of x taking value less than minus 3. Now this is fine. Understandable? X taking value less than equals to 3. Everything would be included. But I need between minus 3 to 3 only. What does that mean? I need between minus 3 to 3 only. What does that mean? That means all these probability should be gone. So here I am writing down probability of x taking value less than minus 3. If I put less than equals to sign here, that means probability of 3 is also gone. But I need the probability of minus 3. If I put less than equals to sign here, that means from here probability of x taking value equals to minus 3 is also gone. So what I need to do, here I will have to add probability of x taking value equals to minus 3. X taking value less than equals to 3, that is fine. Minus taking value less than equals to minus 3. That means probability of minus 3 is also gone, but you would need minus 3. So that's why I have put a probability of x taking value equals to 3 as well. Equals to minus 3 as well. Understandable? So what is this? Fx of 3. And what is this? Fx of minus 3. And what will be probability of x taking value minus 3? From here, fx of minus 3 plus fx of 3. Fx of minus 3 plus fx of 3. Fx of minus 3 plus fx of 3 minus 1. Minus 1. So this and this is getting cancelled out. Answer is coming out to be 2fx of 3 minus 1. Answer is 2fx of 3 minus 1. 2fx of 3 minus 1. Well and good. Okay. So 1, 2, 3, 3 options are matching. But this was wrong. Here I was getting 2fx of 3, which was wrong. Okay, then yeah, let's go to the next. Yeah, so that's like, this is also a very good question. So mean of xt is 0. Okay, and x of omega is defined. So mean of xt is 0. What does that mean? That means variance of xt would be equals to simply the power of xt. Can you find out the power of xt? Yes, sir. How will I find out? Simply do this particular analysis. You will get the power of xt. What that would be? Sir, 5 by 2 tan inverse omega by 2, right? 5, 1 by 2 would come outside. Yeah, tan inverse omega by 2 from minus infinity to infinity. Tan inverse infinity pi by 2. So it will become pi here. So 5 by and 1 by 2 pi was also should be divided. Okay, whenever omega goes inside the integration, never ever forget dividing by 2 pi. So here I forgot to divide by 2 pi. That's what I was thinking, that somewhere something is going wrong. So divided by 2 pi. So 5 by 4. What is the power of xt? That is coming out to be 5 by 4. 5 by 2, 1 by 2 tan inverse omega by 2. This is the condition that you are getting. Then you put infinity infinity. So this will become pi. 5 by 2 multiplied by pi divided by 2 pi. So 5 by 4. This is the power that you are getting. This is the power of xt that you are getting. That is 5 by 4 watt. Okay. Now you need to comment on yt. Variance of yt you need to comment. So in the problem of random process, if summation is given, always prefer opening up the summation. Okay. Always open up the summation. So how will you open up this summation? Sir, y of t would be equals to 1 by 3. Put k equals to minus 1 here. So what you are getting? X of t plus 1 plus x of t plus x of t minus 1. This is how I will open it up. Now you would know that, sir, what will be the mean of yt? Mean of yt. Sir, mean of x of t plus 1, that is 0, 0, 0, 0, 0. Now in a hurry, what people would do? Sir, power of yt would simply be, sir, 1 by 9 and power of this, power of this, power of this. What that would be? Expectation of x square t I have given, that is 5 by 4. Then what will be the expectation of x square t plus 1? It is independent of t. That would also be 5 by 4. And then next one would also be 5 by 4. So 5 by 4 multiply with 3. 3, 3. What they would do? 5 by 12. And then they will calculate the answer, which will be 0.416, which is 0.42. 0.42 watt. And they will click on this option, which is wrong. You are in a hurry. That's why you did it wrong. What you are supposed to find out? Expectation of y square t. So do the y square t, no? Where you did the square. Look, 1 by 3 square, that would come out to be 1 by 9. So let's keep it outside. Do the square of these guys. A plus b plus c whole square. What it is becoming? A plus b plus c whole square. What that would be? A square plus b square plus c square plus 2ab plus 2bc plus 2ca. So a square plus b square plus c square plus 2ab plus 2bc plus 2ca. This is the scenario you are getting, right? So this is the power of y, that is coming out to be 1 by 9. Expectation of x squared t plus 1, what that would be? 5 by 4, no issue. Plus this will also be 5 by 4, no issue. Plus this will also be 5 by 4. You forget about these guys. What that would be? 2 into rx of, what is the difference? 1 plus 2 into, what is the difference? Rx of 1 plus 2 into, what is the difference? Rx of 2. There you go. This is the answer. So did you comment on this Rx? So the point is, you are given x Sx of omega, which is 5 upon omega square plus 4. From here, you need to find out Rx of tau now. And then you need to put these values, Rx of 1, Rx of 1, Rx of 2. Is that understandable to you? So find out Rx of tau. Do you remember e to the power minus a mod of tau? What that would be? 2a upon a square plus omega square. Value of a is 2. So e to the power minus 2 tau. That would be 4 omega square plus 4. Okay. This 4 comes here, this 5 goes here. This would be 5. Okay. So Rx of tau is coming out to be 5 by 4. Rx of tau is coming out to be 5 by 4 e to the power minus 2 mod of tau. So this is the scenario. So what will be the value of Rx of 1? That would be 5 by 4 e to the power minus 2. And what will be the value of Rx of 2? That would be e to the power minus 4. So what will be the answer you will be getting? Power of y. 1 by 9. 15 by 4 plus 4 times, because 2 Rx of 1 plus 2 Rx of 1. So 4 times Rx of 1. What that would be? 5 by 4 into e to the power minus 2 plus 2 Rx of 2. This is Rx of 2. So 2 into 5 by 4 into e to the power minus 4. So this is the complete answer. So let's do the calculation. E to the power minus 2 plus minus e to the power minus 2 multiply with 5. So 0.6766. What about this one? 5 by 2. So 4 plus minus multiply with 5 divided by 2 plus 0.6766 plus 15 by 4 divided by 9. So 0.4969. This is the answer we are getting. So roughly around 0.5 watt. Okay, so answer would be 0.5 watt. A very good question. Okay, very good question. So the problem is, like, in a hurry you can do this particular thing. That's why I forgot about this Rx of 1, Rx of 1 and Rx of 2. So from Sx of omega you are supposed to find out Rx of tau as well. That is coming out to be 5 by 4 e to the power minus 2 tau. Then you should have solved this problem. Okay, let's move to the next one. Yeah, so I hope this question you should not be looking at the solution. Either you can remember by the concept or you can remember by the trick as well. What I have said, continuous will always result in aperiodic. Discrete will always result in periodic, and vice versa. Periodic will always result in discrete, and continuous will always result in, and aperiodic will always result in continuous. Only one thing you need to remember, and rest all will be remembered on your own. If you just remember cap, continuous will result in aperiodic. Now where discrete will go? Continuous and discrete both are opposite to each other, so discrete will result in periodic. Now vice versa, aperiodic will result in continuous and periodic will result in discrete. Basically both goes like forward and backward, both scenarios are there. So just remember cap. Continuous will result in aperiodic, aperiodic will result in continuous, discrete will result in periodic, so periodic will result in discrete. So what is the first thing? Discrete plus periodic. So discrete will result in periodic and periodic will result in discrete. So discrete plus periodic will be periodic plus discrete, which is correct. Next one is continuous plus periodic. Continuous plus periodic. So continuous will result in aperiodic and periodic will result in discrete. Continuous will result in aperiodic, periodic will result in discrete. Periodic will result in discrete. So aperiodic plus discrete. Wait a second. Continuous, okay, it was continuous plus aperiodic actually, but there will be option of continuous plus periodic as well. So continuous plus periodic will result in discrete plus aperiodic. Okay, now continuous plus aperiodic. So continuous will result in aperiodic and aperiodic will result in continuous. So continuous plus aperiodic will be continuous plus aperiodic only. And what about D? Discrete plus aperiodic. So discrete will result in periodic and aperiodic will result in continuous. So periodic plus continuous. So A, B, C, D all are correct. So just remember cap. That's it. Continuous will result in aperiodic. Now Both are opposite of each other. So continuous, so discrete will result in periodic, aperiodic will result in continuous, and periodic will result in discrete. That's it. Very simple question, very straightforward. अरे यार वीडियो पहुंच ही नहीं हुआ क्या?
For a real parameter alpha, consider the system of linear equations. Right, alpha into x plus y equals to -1, x plus alpha y equals to 1. Right, alpha is a real parameter. Depending on the value of alpha, the system may have no solution, a unique solution, or infinitely many solution. Which of the following statements is correct? Okay, depending on the value of alpha, there exists exactly one value of alpha for which the system has no solutions. So do remember what were the conditions. This is a non-homogeneous equation. If it is a non-homogeneous equation, right, then what were the two conditions? Like there were three cases, right? If my rank of A is equals to rank of B, rank of A colon B, and it is equals to the total number of variables. How many variables I have? 2. Then certainly I will have unique solutions. If my rank of A is equals to rank of B, A colon B, but it is certainly less than n number of unknowns, then we have infinite solutions, right? Infinite solutions. And if rank of A is not equals to rank of B, A colon B basically, then we have no solutions. Which condition are they talking about? So they are telling me there exists exactly one value of alpha. There exists exactly one value of alpha for which the system has no solutions. Is that so? So for exactly one value of alpha. So what is what is A colon B? If I form the matrix, let me use a different, yeah. So A colon B would be simply alpha 1 1 alpha, and this is -1 1. -1 1. Okay. Now here what shall I do? I want exactly no solution, right? If I want no solution, let me try to make 0. So if I add the row 1 and row 2, this will be alpha 1 1 plus alpha 1 plus alpha. This will be 0 0. So I can take this 1 plus alpha common. Okay, this is essentially making, okay, I want to make them not equal to each other, right? So I want this rank to be higher than this rank. Okay, how do I choose? Let's not think about this. I will do this later. Let's think in terms of here. So what is the rank of A colon B here, right? So basically I can see I have, if my alpha is any value, right? Alpha, if alpha is 1, then this and this row are different, then certainly rank is 2. If alpha is 0, then also rank is 2. So essentially what is happening, what is the determinant of this particular matrix? Only 2 cross 2 matrix, that is alpha square -1, right? When it can be 0, it can be 0 at alpha equals to plus -1, right? Okay, yeah. So I see for whatever values of alpha, right? So for alpha equals to -1 here, if I put alpha equals to -1, what is the rank of A colon B? That is equals to 2, right? Rank of A colon B is 2. But when alpha is this particular values, by rank of A, what is the rank of A? Can you tell me what is the rank of A? It is actually equals to 1. Why? Because if I form the matrix A, it is this, right? Let's say when alpha equals to 1, it is 1 1 1 1. So I have only one independent row. Or if you choose -1, right, then also you see I have only one independent row. So certainly when your alpha is equals to plus minus 1, your rank of A is 1 and your rank of A colon B is certainly equals to 2. So they are not equal, certainly you will have no solutions. But what are they telling me? There exists exactly one value of alpha. Is that true? No, it is a real parameter and there exists two values of alpha, right? Two values. So there exists two, not one. So this statement is certainly incorrect. There exist infinitely many values of alpha for which the system has no solution. Again incorrect, because there exist two values of alpha for which there are no solutions. For any other values of alpha, right, your rank of A will be 2 because the rows will be independent. Rank of A will be 2, which will be equals to rank of A colon B. Hence that is not true. There exists exactly one value of alpha for which the system has unique solution. Again incorrect. There exist infinitely many solutions of alpha, right? Because in many values of alpha, because for unique unit rank of A equals to rank of A colon B. So if your alpha is not equals to these two values, then this will always be true, right? This will always be true. So there exist uh, infinitely many solutions. There exists exactly one value of alpha for which the system has infinitely many solutions. There exists exactly one value of alpha for which the system has infinitely many solutions. So if it is required to have infinitely many solutions, right, that basically means, okay, it needs infinitely many solutions. So that basically means alpha 1 1 plus alpha, this will be 1 plus alpha, this will be -1 0, right? So basically uh no, that is not possible, right? So alpha, so if alpha is equals to -1, okay, hold on. So at alpha equals to -1, I observe a certain thing. Oh, alpha equals to -1, this is getting to -1 1 -1, and this is going to 0 0 0. Oh, okay, we have to be very carefully, right? So alpha equals to -1, the rank of A colon B is actually 1 because I only have one independent row. I was wrong here. This statement was wrong, right? I was telling at alpha equals to plus -1, the rank of A colon B was 2. I was wrong because I did not check it properly. Okay, so whenever you're doing ranks, make sure you check it properly. So make sure you try to make this whole 0, then only you can say surely, right? Okay, I was wrong. So actually I was wrong. So at alpha equals to -1, right, A colon B's rank is 1 and your rank of A is also 1. So actually you have infinitely many solution at alpha equals to -1. So there exists exactly one value of alpha for which you have infinitely many solutions is correct, but there exists one value of alpha for which the system has no solution. This statement is also correct because alpha equals to 1, certainly the rank. What is the rank? If I put alpha equals to 1 here, right, what is the rank? It will be 1 1 1 1 -1 1. So rank I can directly see it is 2 because these two rows are independent. But if I put -1, I was wrong actually. Previously I just checked. If I put -1 here, this will be 1 -1 -1 1. So essentially, right, if I multiply a negative with the second row, I will get the first row, right? So that's all. So actually this statement is also correct. There exist infinitely many values for alpha for which no solution. No, this is again wrong. There exists one value of alpha. No, there exist infinitely many values of alpha. So option 1 and 4 are the correct answer for this particular question. Evaluate the surface integral where S is the surface in three-dimensional space defined by this. Okay, the vector field is given by this, and n vector denotes the outward unit normal to the surface S, right? Yeah, so basically they are asking me to compute this surface integral, right? Okay, uh given by this surface. So what is this surface? Do you understand what is this surface? So I see this is z square. Z square is greater than x square plus y square. X square plus y square. So this surface is nothing but z square is greater than or equals to r square. If I assume, like, let's say x square plus y square is some radius of a circle, it is r square. So if I draw the 3-dimensional space x, y, z, right? So basically, if I assume x square plus y square is nothing but a circle, right? So my z square must, if let's say I am at here at z equal to 0, so your r must be 0 because z square must be greater than r square, so r must be 0. Let's say I am at z equal to 1. If I am at z equal to 1, so basically your x square plus y square basically must be less than 1 square, that is 1. So basically if I am at z equals to 1, so your radius of the circle should be less than 1, right? If I am at z equal to 2, your radius of the circle should be less than 2. So what is happening, as I am moving up or down, it does not matter, your radius of the circle is increasing. So with deviation in z, the radius of the circle is increasing, right? So essentially I can say your z actually will always be greater than or equals to the radius of the circle. Is that so? So basically your z and the radius of the circle follows a linear relationship. Do you remember which certain shape has that linear relationship? So I have here, then again as the radius increases, z also increases. As the radius increases, z also increases. So this I have taught in my full course. This is the shape of a cone. Okay, this is the shape of a cone simply. Okay, shape of cone, right? Okay, this is the shape of a cone, right? So that's the thing here. So actually they are asking me to compute this surface integral over the cone, because your cone, basically the radius of the cone is varying from 0 to 3, right? So what we can do, we can actually compute, so we can use the divergence theorem, right? If I have to compute uh, surface integral, I can use the divergence theorem because it is a closed surface. It is a closed surface, right? I have to compute the integral from here. So it is a closed surface. So I can use divergence theorem. That will be the volume integral of del dot f dv. So volume integral in the xyz coordinate, this will be del dot f. So if I differentiate with respect to x, this will be 4 only, divergence, plus differentiate this with respect to y, that is 0, differentiate with respect to z, that is 0. So this is actually 4 triple integration of dv is simply 4 of into v, where v is the volume of the sphere, sorry, volume of the cone. What is the volume of the cone? It is pi r square h by 3. So 4 into pi r. Okay, so what is your maximum value of the radius? That is 3, right? R is 3. 3 square into h. What is the height? Height of the cone, maximum height is 3, right? Yes, 3 upon 3. So this will be actually 9 into 4, that is 36 pi. What have they asked? They have directly asked me to calculate the answer in integer. Okay, 36 pi. This will be 36 into pi. That is 130. This will be your answer for the question.
Yeah, so let's solve this particular problem. So supply is given, supply is having some noise. Okay, the word that is written suppress, that means noise only. So this is the noise component we are having. This is the noise component. We need to find out how much of the noise component will be coming at the output. This is what you need to find out. So what is this? This is a small signal. This is your large signal. This is your DC and this is your small signal, right? So you need to find out how much of this portion would be coming at the output. This is the problem. Okay. So eventually I will have to do the small signal analysis, and in the small signal analysis I would require the GM value. And if we require the GM value, what is GM? GM is IC by VT. So I would require the collector current. If I require the collector current, what does that mean? That means I need to do the DC analysis as well. So without looking at much of the problem, one thing I can sense that I need to do the DC analysis. So eventually I need to find out the potential here. The potential because of this small signal. I look at the option 30 millivolt, 60, 90, 120. Very far apart. What does that mean? That means I can take the approximations. Whatever the approximation I want to take, I can take that particular approximation. to make my calculation easier. Because see the options very far apart, right? It's not that 60, 58, 62, 64, then there would be a problem. But they are very far apart. I can take approximation, any approximation I want. So first I will have to do the DC analysis. For DC analysis, why I need to do the DC analysis? I need to get the collector current. So if I need to get the collector current, if I do the DC analysis, this will be open circuited, this will also be open circuited, right? Then what will happen? This is 5 volt, AC voltage will be gone. We don't even know about this V in. There might be some DC voltage, there might be some AC voltage. Most probably it will be AC voltage only because capacitor bypassing we have done. That means it would be a AC voltage only, but capacitor is there, so this particular portion will also be gone. So if you draw the circuit of a DC analysis, then this is how it will look like. Resistor, then there is a resistor, then there is this BJT, then there is a resistor, and then there is a resistor, and then there is supply. This is how the circuit will look like. Is that understandable to you? Surely it is understandable, right? So there is no use of this particular portion, there is no use of this particular portion as well. So what will happen? This 5 will directly come here, 30, 20 kilo, this will become 2. This is having a drop of 0.7, right? So this will become 1.3. Now this point is becoming 1.3 volt, that means how much current it is driving? 1.3 divided by 2.6k, that means 0.5 milliampere current it is driving. So just by looking at the screen only, I can tell that my IC will be 0.5 milliampere. If this is your IC, then what will be your GM? GM will be IC by VT, 0.5 divided by 25, what that would be? 1 by 50, or you can say 0.02, right? 1 by 50 is nothing but 0.02. So this is your GM value, or 20 millisiemen you can call it, 20 millisiemen. This is your GM value. I needed GM value only. Now what I need to do? I need to do the AC analysis. Now effect of, sir, this is also AC voltage, no? So what you will do for this one? I need to see the effect of this guy only, no? I need to see the effect of this particular voltage. So if I need to see the effect of this particular voltage, I will consider only this voltage only, not this one. So this will also be shorted. Is that understandable to you? Capacitor will be short circuited, this will also be short circuited. This is the scenario, right? And this 5 volt will be gone. So basically what kind of a circuit you will see? So 30 kilo ohm would be there, 20 kilo ohm would be there, then 100 ohm would be there, then there is this BJT ground. Why directly ground? Because this is shorted, no? And this node is connected like this. So this is the circuitry we are getting. 30k, 20k, 100, V0, and this is 6k. And here the small signal surplus voltage, let's call it V in, which is equals to 0.1 sine 100 pi t. 0.1 sine 100 pi t. I need to find out V out. So I can sense that V in minus V out divided by 6k. Let's just say this current is I, equals to I, right? V in minus V out divided by 6k equals to I. Can I find out this current in terms of V in? If I am able to find out, my job would be done. So this is your V in, this potential is also V in. What will be this potential? What is the parallel of 120k? 100 parallel with 20k. It would nearly come around 100 only, no? It would nearly come around 100 only. Now someone would say that, sir, here beta value was 100. Why you did not consider about base current? Base current I did not consider. Why is that so? Options. I can take my approximation, whatever the approximation I want. Here also I am taking approximation that 100 parallel with 20k will be almost 100. Almost 100. So can you write not 100k, it would be 100. So can you write down this particular potential? Let's just call this potential as VA. So what will be your VA? VA will be 100 divided by 100 plus 30k. 100 plus 30k. That is also approximately equals to 30k only. So again approximation I am taking 30k. Multiply with V. So this is the VA potential I am getting. Now this is your base potential. Now someone would say that, sir, do the analysis, find out the R pi. R pi, what will be the value of R pi? R pi would be, sir, beta by GM. beta value is there, GM value is there. GM value is 20 millisiemens. So sir, answer is coming out to be 5 kilo ohm. I don't care. I will not care about R pi value as well. Why is that so? Because you can see sense from here, 30k parallel with 100k, that would come out to be 100, 100 parallel with 5k. Again, it is roughly around infinity only. Compared to 100, it is infinity only. 100 and 5 kilo ohm, very large. So I will not care about R pi value as well. You can see the options, no? So R pi also I will take infinity. R pi also I will take infinity. So now simply this has become like I am MOSFET circuitry. You know the GM value. What will be the current here? Sir, GM, let's call this as gate. This is your source. GM VGS, that would be the current. Source potential is 0. Do you know the gate potential? Yes, sir. What is that? Gate potential is 100 by 30k into V in. So can you write down something now? V in minus V out. 6k into current I. What is that? GM into VGS. What is VGS? 100 divided by 30k into V in. What is the value of GM? GM is 0.02, or let's just put it GM only here. So V in minus V naught. So 20 into 0.02 into V in. So 0.4 V in. V in minus V naught. V naught is coming out to be 0.6 V in. So V naught is nothing but 0.6 V in. Now what is V in? V in is 0.1 sine omega t. So 0.6 into 0.1, what that would become? 0.06, or you can call it 60 millivolt sine omega t. Now what is this? This is the amplitude that they were asking. So what will be the answer? 60 millivolt. Okay, all the approximations, and never ever ignore that DC analysis of BJT. Someone would say that sir, BJT is not important. DC analysis is important, and this kind of AC analysis is also important, where you can take R pi equals to infinity. Because if R pi equals to infinity, then BJT equals to MOS for small signal analysis. For small signal. So 101% I am sure if they are asking small signal analysis of BJT, they would put R pi equals to infinity in your examination. If R pi is infinity, your job is done. BJT would become MOS only. If BJT equals to MOS, MOS analysis we already know. It's just that GM value I need to find out. That means I need to do the DC analysis, because GM value is IC by VT. So IC value I need to find out. Okay, job done. Let's go to the next one. Yeah, so this is simply based on the setup analysis. You need to analyze the setup and tell the final UT expression, then which of the following statements are true. Okay, so this expression they are calling as YT. What they are saying, YT is nothing but mt.st. YT is mt.st. So you need to comment on YT as well. You need to comment on UT as well. UT is already given. Now let's talk about ST. What you can comment about ST? ST is even or odd? Odd. Surely it is periodic as well. Along with that, it is half-wave symmetry as well. Because whatever you get at 0, same you get at t by 2 as well. So it is half-wave symmetric as well. Right? Along with that, 1 by Tp equals to Fc. That means it is having a frequency of Fc, fundamental frequency of Fc. So if these are the scenarios, what does that mean? It is having 0 DC value, 0 DC value. Also, it is having frequencies Fc, 3 Fc, 5 Fc, and so on. So can you write down the ST expression? Yes, sir. ST expression. Along with that, it will have sinusoid or cosinusoid. Since it is odd, what it will have? Sinusoids only. So it will have sinusoids. So, sir, sine omega ct, some amplitude would come. What is that amplitude? I told you to remember. 2 into peak to peak value of the waveform. What is that? 2 divided by pi. Only for symmetric square wave, I ask you to remember 2 into peak to peak value divided by pi. Only for the square wave. 2 into peak to peak value divided by pi. That's it. So what is the answer you get here? 4 by pi. Next, it would be sine 3 omega ct. What will be the amplitude? Plus minus sign alternatively will come. 4 divided by pi, but here there is 3, so 3 would come. Again, plus sign would come. Divided by pi, here what you will write down? Sine 5 omega ct. Here there is 5, so 5 would come. Then plus minus 7 pi sine 7 omega ct. So this is your ST. This is your ST. This is the ST you are getting. That will be multiplied with MT. So YT is MT multiplied with ST. Now what is your MT? MT is a simple sinusoid, I guess. Did they write down anything about it? Generated by a diagram, let yt is passed through bandwidth output of the signal. That FC FM bandwidth of the message signal. FM W, here W should be written, no? Here in place of FM, W should be written, right? Because W is the bandwidth of the signal, no? Yeah, W is the bandwidth of the signal. So FM equals to W. Okay? FM is equals to W here. So 1 kilohertz is the frequency. Basically, MT is a baseband signal. MT would have been a baseband signal, which is having a maximum frequency of 1 kilohertz. This is what they are saying. This is your M of F. This is the scenario. Okay? This is your M of F. Right? So what they have said, bandwidth of W, where W is the bandwidth of the message signal. W is the bandwidth of the message signal, which is baseband. So I will change the language of this question. It would be clear to you. Okay? Yeah. So the scenario is MT dot HT. That means what will happen? This baseband signal is having a center at 0. Right? When it is multiplied with HT, it will move to FC, it will move to 3FC, it will move to 5FC, it will move to 7FC. So if you make the waveform of Y of F, how it would look like? Center will move to FC. What is the value of FC? 100K, right? 100K. So this point would be 100K. This point would become 101K. This point would become 99K. Then this is 3FC, 300K. 300K. Next point would become 299K. This point would be 299K. And this point would be 301K. In that manner, it will keep on going. So what all frequency components you are having? 98 kilohertz they are saying. The spectral component 100 kilohertz is present in YT. The spectral component which are absent, okay. The spectral component at 102 kilohertz is absent. Yes, at 102. Where is 102? This is 102. 104 is absent. Yes, 104 is also absent. 98 is absent. Yes, 98 is also absent. And 96 is absent. Yes, 96 is also absent. All these spectral components are not present in Y of F. But 100 kilohertz is present. Yes, 100 kilohertz is present. 100 kilohertz is present. That means yes, this is present. Okay, they are saying that 100 kilohertz is also absent, but 100 kilohertz is not absent. Okay, 100 kilohertz is present. Now, second, what they are asking, what should be the pass band gain of the filter? So, what is the filter we are using? Filter that we are using is centered at FC and having a bandwidth of 2W. So, this filter you are using. What should be the pass band gain? So that your YT is MT dot sine 2 pi FCT. Basically, only this much component should pass. Only this component is passing. So only if only this component is passing, then what will be your final output, which is they are saying as UT. So your final output UT would become MT multiply with 4 by pi sine omega CT. But you don't want 4 by pi in the output, right? 4 by pi is not there. That means the pass band gain here should be pi by 4. Because pi by 4 multiply with 4 by pi, what it will become? 1. That means here pass band gain should be pi by 4. There you go. So what will be the answer? Pass band gain should be pi by 4. So 1 and 4 are the correct option. Okay. Pass band gain should be pi by 4 and spectral component 100 kilohertz is present. Rest all are absent, but 100 kilohertz is present. Okay. So this should be remembered that what is the amplitude? 2 into peak to peak value divided by pi. Okay.
Consider Cauchy's theorem for complex integration. Let P be a simple closed contour lying entirely within a simply connected domain Q. Okay. So it is lying in the domain Q, simply connected domain Q, for the complex integral fz dz. Which of the following statements is / r true? Okay. Do you remember what does Cauchy's theorem tells you? Cauchy's theorem simply tells me that if there are no poles, that are lying inside my contour, then that means my integration, right, this closed line integration along the contour P would be 0. That is what my Cauchy's theorem tells me. Cauchy's residue theorem is different. You will have to compute the residue there. Okay. Cauchy's theorem cannot be directly applied to conclude that this is equals to 0 when your fz equals to 1 by z cube and P is the unit circle. So if P is a unit circle, that basically means inside the contour 1 by z cube, right, I have z equal to 0, which is a repeated kind of pole which is lying inside that. So Cauchy's theorem alone will not be able to directly conclude what is the integration that is equal to 0. We'll have to use Cauchy's residue theorem. So yeah, this statement is correct. They're telling me it cannot include. So it is correct. We cannot conclude that. Okay. If fz is analytic in Q, then fz integration of this, right? Okay, entirely within a simply connected domain Q. Closed line integration of fz dz equals to 0 for any simple contour P in Q. So if the contour P is lying in the domain Q, and if in the domain Q fz function is analytic, then certainly if it is analytic, there are no poles, like it is basically continuous, right? Intuitively you can understand. So yeah, this will be always 0. This will be always 0. That is certainly true. Okay, if it is analytic, it will be 0. So we don't have any problems. To conclude that this integration is equals to 0 for any simple closed contour P in Q, the function fz must be analytic in Q. Is it true? Is it always true? No. Why? Because yes, if your function is analytic in Q, right, then certainly this integration will be 0. That is stated in the option B. But if it is not analytic in Q, right, or in the contour P, which is lying in the domain Q, you will compute the residue, and your residue, right, for a particular pole can be equals to 0, and that can also cause this integration to be 0. So it's not like this will be 0. If this is 0, then certainly your function is analytic. No. Even if your function is not analytic, still this integration can be 0 if the residues come out to be 0, or the sum of the residues come out to be 0, right? Sum of the residues are coming out to be 0, then also this integration can be 0. So this statement is incorrect. Now this integration is not equal to 0 when your fz equals to 1 by z cube, since the function is not analytic at z equals to 0. Again, here, right, nowhere they are mentioning what is the curve they have chosen. So it may be that the curve that they have chosen, yes, it is not analytic in 1 by z cube. That is certainly true. At z equal to 0, it is not analytic. That is true. Okay, because there are poles, there are repeated poles. But I don't know what is my P, right? What is the contour P? So P may be this contour that does not include z equal to 0. So here I can use my Cauchy residue theorem because it does not lie in the pole. So if it does not lie in the pole, if there are no poles inside my contour, then I will simply use Cauchy theorem, and Cauchy theorem states that it will be 0. So in this region it is analytic, right? So yeah, this is not equal to 0, but you will have to get the information regarding P. They have not provided you with the information of P. So this statement is incorrect. So here option 1 and 2 will be your correct answer for the question.
Yeah, very straightforward question. Again, based on Smith trigger. So what will be this potential here? V in by 2. What will be this potential? V naught by 2. What kind of Smith trigger it is? Inverting or non-inverting? Input is applied to the inverting terminal. So it is inverting Smith trigger. Since it is inverting Smith trigger, can you make the characteristics? Yes, sir. I can make the characteristics. How the characteristics would look like? Sir, first I need to find out the upper threshold and lower threshold value. So can I find out the upper threshold and lower threshold value? Yes, sir. You just need to equate V positive with V negative and get the value of input. So V negative is V in by 2. What is V positive? V positive is V naught by 2. So V in equals to V naught we are getting. Now V naught can take only two values, plus 15 and minus 15. What does that mean? V in value either could be plus 15 or minus 15. What does that mean? Your upper threshold voltage is plus 15 and your lower threshold voltage is minus 15. Okay. So this is the scenario. Now can I make the characteristics? Yes sir, surely I can make the characteristics now. There will be hysteresis between plus 15 and minus 15. So there will be hysteresis between plus 15 and minus 15. And what kind of Smith trigger it is? If I am drawing V0 versus V in. So what kind of Smith trigger it is? It is your inverting. That means at higher voltage you will get the lower output, and at lower voltage you will get the higher output. Since it is inverting, so how it will move? Clockwise. Inverting Smith trigger clockwise, and here both direction. This is minus 15, this is plus 15, right? Now V0 is always equals to V in absolutely baseless. V0 is only having two values, plus 15 and minus 15. Okay. For V in greater than 15 volt, V0 will always be minus 15 volt. For V in greater than 15 volt, V0 will always be two kind of values will be there, plus 15 volt and minus 15 volt. So for V in greater than 15 volt, V0 will always be minus 15 volt. Yes, that is correct. When the input is changed from plus 20 volt to 10 volt, plus 20 to 10, this will be plus 20 to 10 volt. From plus 20 to 10 you are going. That means you are moving in this direction. You are moving in this direction. That means you are following this particular curve. This curve you are following. So if you are following this particular curve, 20 to 10 you are going. If you are following this particular curve, that means your output will remain at minus 15 only. It is not making transition. It will make the transition at minus 15 volt. So output will make a transition? No. But when the input is changed from 20 to 10 volt, the output remains at minus 15 only? Yes. So from 22 at minus 15 it will make the transition. No, you see this characteristics. At minus 15 it will make the transition. Right? So you should be able to read the characteristics. If you are able to read the characteristics, if you are able to draw it, then there is no issue. You will be able to solve this kind of problem. B and D would be the answer. Very easy, very straightforward. Yeah, so we need to determine Y40. So simply we need to analyze the setup and our job would be done. So this is empty, this would be CT. This is your XT which is passing through a square law device. So what will be your Y1T? Y1T would simply be MT plus CT whole square. Okay, that would be your Y1T. Then there will be a band pass filter, then a multiplier, whatever it is. So first let's talk about the filters. Filters, there is a band pass filter having a bandwidth of 2W and centered at F0. Centered at F0 having a bandwidth of 2W. So this point would become F0 plus W and this point would become F0 minus W. So this is having a bandwidth of 2W, right? Centered at F0. Along with that, F0 is greater than 3W. What does that mean? That means this point is surely greater than 2W. This is what they are saying. And this point is surely F0 is greater than 3W. That means this point is greater than 4W. I don't care about this particular point, although I don't care about this particular point. But this point is surely greater than 2W. This is what they are saying. Okay, right? So let's see the analysis. What will be your Y1T? Y1T would simply be M square T plus C square T plus 2MT CT. So can you draw the frequency spectrum of M square T? Yes, sir. It will be, I don't know the structure, but it will be between minus 2W to W. What about C square T? C square T will have a DC value. C square T cos square 2 pi F0 T. Then it can be broken into cos 4 pi F0 T divided by 2. So it will have a DC value. It will have a DC value and another frequency component at 2 F0. Now what about MT dot CT? This will be shifted to frequency F0. This will be shifted to frequency F0. So this point would become F0 minus W. This point would become F0 plus W. And that will be passed through a band pass filter. Along with that, this 2W and F0 minus W will not overlap as well. So this particular portion would pass. That means MT dot CT would pass. Only MT dot CT would pass. So Y2T is nothing but MT dot CT. There you go. Nothing else got passed. This much got passed. And all the filters are having a passband gain of 1. This would also be there. Yeah, all the filters are having a passband gain of 1. That means only this much component passed. There was no amplification, no reduction. MT dot CT got passed. This also did not pass. This also did not pass. This also did not pass. Only MT dot CT got passed. So your Y2T is MT dot CT. Now that is multiplied with cos 2 pi F0 T. And from there what you are getting? Y3T. What is Ct? Cos 2 pi f naught t. Ct was cos 2 pi f naught t. Again multiply with cos 2 pi f naught t. So this will become square. So what you are getting? 1 plus cos 4 pi f naught t divided by 2. So you are getting mt by 2 plus mt cos 2 pi 2 f naught t divided by 2. So mt by 2 will have a frequency spectrum between minus w to w, and this will have a frequency spectrum between frequency spectrum centered at 2f naught, 2f naught minus w, 2f naught plus w, right? Centered at 2f naught, 2f naught minus w, 2f naught plus w. But what we are having? We are having a low pass filter. Low pass filter with the bandwidth of a low pass filter having a bandwidth of w. That means what will pass? This much of portion would pass. So what do you think? What will pass? This portion would pass. So this particular portion would pass. So final output, which is y4t, what that would come out to be mt by 2. This would be the final answer. Is that understandable to you? y4t is mt by 2. How did we do the analysis? Is that understandable to you? Mt dot ct was passing. Wait a second. 2 mt dot ct was passing. No? A square plus b square plus 2ab. This is what I was thinking. 2 mt dot ct was passing. 2 mt dot ct was passing. So here also 2 was there. A2 was there. A2 was there. So this became empty only. So there was this problem. Okay. 2 mt multiply with 1 by 2. So mt plus here also 2 will not come. Basically from the low pass filter only this much component would pass. If only this much component is passing, there is no issue. If this much component is passing, that means answer would be empty, not mt by 2. So here blunder I was doing 2 mt dot ct was there. No, a square plus b square plus 2ab, 2 mt dot ct. So 2 mt dot ct was passing, this was passing. Then multiply with cos 2 pi f naught t, cos 2 pi f naught t. So what you are getting? Mt only. Okay, so mt plus this component which will not pass through the low pass filter, only mt component would pass. So final answer will be mt. So your y4t is nothing but mt. Okay, let's go to the next.
If x and y are identical independent binomial random variables, if the experiment is repeated thrice, okay, so remember your x and y are binary meaning either they can take two values, so either it can be x equal to 0 or it can be x equal to 1. Now they are binomial random variables, right? I hope you know what is binomial, like they follow binomial distribution. Now if the experiment and they are independent, both x and y are independent, they are identical but they are independent. Now what they're telling me that the experiment is repeated thrice, so n in the binomial distribution is thrice, remember this, right? And the probability that x equal to 0 is given to be 2 by 3. So what is the probability that x equal to 1? It is a binary random variable, it will be 1 minus 2 by 3, that is 1 by 3. The probability that the matrix this that is never orthogonal, the probability that the matrix is never orthogonal, right? Now do remember what was the condition for orthogonality. Your condition for orthogonality was p into p transpose will be equals to I, right? So what is p into p transpose? X by root 2 y by root 2 minus 1 by root 2 1 by root 2. Now p transpose would be what? P transpose would be equals to x by root 2 minus 1 by root 2, sorry, I'm doing the transpose, y by root 2 divided by 1 by root 2. So that is my p transpose basically, right? So we got this. We will multiply these two together and that should give me the identity matrix. So if I multiply these two, this will be x square by 2 row into column, right, plus y square by 2, that should be equals to 1, that is one equation. X minus x by 2 plus y by 2, that should be equals to 0, right? This is the other equation, right? I'm multiplying the first row and the second column. Then again coming back to the second row, this will be again minus x by 2 and plus y by 2, that again will be equals to 0. That is the same equation as this equation, right? And this final one will be the same basically. Oh no, sorry, this will not be the same, this will be 1 only, right? We'll get 1. So we get two equations. What are the two equations? X square plus y square equals to 2 and x is equals to y. So if I replace, let's say, my y with x here, right? So basically your x would be equals to 2x square would be equals to 2. So your x can be plus minus 1. Now as my uh, variable is random, right? So either it can be x equal to 0 or x equal to 1. It is a binary. Binary means it is either 0 or 1. So if it is 0 or 1, that basically means we cannot take negative values. We'll either take plus 1 and 0, right? So basically our x needs to be equals to 1, and of course this condition must also be satisfied, that is our y also must be equals to 1, right? So x is equals to 1, y is equals to 1. That is the condition for the matrix to be orthogonal. But what are they asking? They're asking me it is never orthogonal. So what is the probability that it is never orthogonal? So what is the probability of success? Probability of S. It will be 1 minus probability of failure, right? That it is orthogonal. Let's assume it is orthogonal, right? If I subtract 1 from that, then I will obviously get it is not orthogonal. So it will be, what is the probability that it is orthogonal? Both x and y must be equals to 1. So what is the probability that x is equals to 1? X equals to 1 is 1 by 3. So it will be basically 1 by 3 into 1 by 3, right? Because y also has to be 1, right? That's why they are independent. I can simply multiply the two probabilities. So it would be 8 by 9. Now remember, this is the probability for the matrix to be never orthogonal, but this is only in the scenario where my n is 1, right? But I am repeating this experiment thrice. So of course, now using the formula of binomial distribution, it is NC P, the success, right? Or NCR, P raised to the power of R Q into n minus R. So I am repeating this thrice, and I never want orthogonal, right? I always want success. I don't want orthogonality any time. So I always want it to be orthogonal only. So out of the 3 times, I want all of it to be not orthogonal. I want all of the time for my matrix to be not orthogonal. So it will be 3 only. R will be 3. 8 by 9, probability of success raised to the power of 3, and obviously this will be 1 by 9 raised to the power of 0. So this will be 8 by 9 whole cube. Okay, and if I calculate 8 by 9 whole cube, this would be 0.7. This would be the answer of the question.
Now for this one, you should be comfortable with the WBFM. This is the example of wideband frequency modulation. Okay, so can you find out the value of beta? First, let's find out the value of beta. So what I will do, I will have to integrate this m of tau. So when I integrate, this 2 pi kf would remain as it is. Beta is nothing but the maximum value of phase deviation. When you integrate this, 10 goes here and divided by 16 pi would come, and maximum value of sinusoid would be 1 only. So answer would come out to be kf into 10 divided by 8. Beta would be kf into 10 divided by 8. What is the value of kf? Kf value is 10, so 100 by 8. So answer is 12.5. So value of beta is coming out to be 12.5. Okay. Now whatever the output of this FM modulator is there, that is passed through a again band pass filter having center frequency of 2k 2 kilohertz, which is actually the carrier frequency as well. Is that so? No, this is 400 pi t. No, this should be 4000 pi t actually. Okay, here there is an error. This I will modify, don't worry. This would be 4000 pi t. No, this should be 4000 pi t. Then only you will get 2k. So this should be 4000 pi t, not 400 pi t. So 2 kilohertz. Okay. Now 2 kilohertz with the bandwidth of 62 hertz. That means this will be 31 hertz and this will also be 31 hertz. Right? This is the scenario. Bandwidth of 62 kilohertz means from the center this would be 2k plus 31 and this would be 2k minus 31. Now you know one thing, how your ut could be written. Ut can be written in WBFM. How it can be written? So summation n going from minus infinity to infinity AC Jn beta. What is the value of AC? 10. Jn beta cos omega c plus minus n omega mt, right? That means it will have a frequency component of fc plus minus n fm. What is fm? Fm is 8 hertz. Fm equals to 8 hertz. And what is the value of fc? Fc is nothing but 2 kilohertz. So it will have a frequency component of 2 kilohertz plus 8, 2 kilohertz plus 16, 2 kilohertz plus 24, 2 kilohertz plus 32, and similarly in the negative side as well. So which all will pass? This will pass, this will pass, this will pass, but this will not pass. That means along with that, it will have frequency component of fc as well. Don't forget fc as well, because if you put n equals to 0 here, it will have a frequency component of fc as well. So fc will also pass, this will also pass, this will also pass, and this will also pass. This is associated with j naught beta, this is associated with j plus 1 minus 1 beta, j plus minus 2 beta, and j plus minus 3 beta. So all these will pass. Eventually what they are asking? They are asking you the power of output signal. So what do you think, what will be the power of output signal? That would be the AC square by 2. That means 10 square by 2, AC square by 2, multiply with j naught square beta plus j1 square beta plus j of minus 1 square beta. That would be twice of j1 square beta plus twice of j2 square beta plus twice of j3 square beta. All these values are mentioned. You just need to put the values. This will be 50. You put the values 0.15 square, twice of 0.17 square, twice of 0.17 square, plus twice of 0.11 square. So 0.17 square multiply with 4 plus 0.15 square plus twice of 0.11 into 0.11 into 50. Yeah, 8.115, 8.2 what you are getting. 8.2 what you are getting. Same question is there in our class notes as well. Same question is there. Ditto same. Like almost same, it's just that some data are different. Right? So from the band pass filter, how much components are passing, that component you need to write down. From here you know the power as well. It is simply the carrier power multiply with j naught square beta plus j1 square beta plus j2 square beta plus j3 square beta and so on, and similarly in the negative hand side as well. But complete power is not passing. Only few components are passing. What is that? J1, J0, J1, J2, J3. Same in the negative side as well. J of minus 1, J of minus 2, J of minus 3. Then you wrote down the power of all of them. You got the answer 8.115. 8.115 watt. Okay. So there is this error that I will modify. So answer is this one. Okay. This error I will modify. Yeah, so you need to find out the energy stored in the capacitor C. You need to find out the energy stored in this capacitor. What will be that energy stored? Sir, half CV square. Right? Half this capacitor CV square. So answer would be V square. So you just need to find out the potential across this capacitor. This is your question. And then do the square. So what I will do? Sir, I can see that 2 1 2 1 2 1 it is being repeated. That means if I say this is my C equivalent, then this would also be my C equivalent only. Right? So my circuit can be replaced somewhat like this. 2, 1, and this is your C equivalent. This is C equivalent, this is 2 farad, this is 1 farad. Right? And C. So C equivalent is coming out to be 2 farad in parallel with 1 plus C. So 2 into 1 plus C divided by 3 plus C. So from here I can directly sense that value of C will come out to be 1. How I can sense it? If I put C equals to 1 here, 1 plus 1, 2. 2 and 2 in parallel would become 1 only. So 1 and 1, that is matching. So value of C is coming out to be 1 farad. So from here I can replace the circuit. This C is actually 1 farad. Okay. So now what is the scenario I am having? 2 farad and 2 farad. This is the scenario that I am having. And applied voltage here is 11 volt. So this 11 volt will be divided equally. This voltage will become 5.5 volt. So that means this much of portion is getting 5.5 volt. So here what potential you are getting? 5.5 volt. So 5.5 volt, this is your capacitor C which is 2 farad. Now then again there is 1 farad. And after this here, what is the total capacitance? This is also C only. So this particular setup can also be replaced with 1 farad. And here the voltage was 5.5 volt. Basically, I started from here. I got to know that across these two nodes, I am getting 5.5 volt. Now this is 2 farad, and here also equivalent is also 2 farad. So 5.5 volt, 1 plus 1, this will become 2. 2 and 2 again equally divided. So here what will be the potential I will be getting? And I need the potential across these 2 farad. So what that potential will be? 5.5 divided by 2. 5.5 divided by 2. I just need to do the whole square. That's it. So 5.5 divided by 2, do the whole square. 7.562. Answer would be 7.56. That's it. 7.56 joule. This is the energy that we are storing. Half CV square, value of C was given. I need to find out the potential. For finding out the potential, I find out the equivalent. That came out to be 1, 1, 1, 2. Potential half divided. Again potential half divided. Again in that manner it will be half, 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 half divided. So this became 5.5. This also will be 5.5. Half CV square applied. I got the final answer 7.56 joule. Let's go to the next one. Yeah, so in this problem, what we need to find out? We need to find out the average power absorbed by the resistor. So what is the average power absorbed by the resistor or dissipated in the resistor? What is that? I average square into R. No, a lot of people do this error. It is not average, it is RMS square. Okay, this is the correct formula. So average power dissipated across the resistor is I RMS square into R. So Q graph is given, Q versus T. I can find out the current graph, and then I need to find out its RMS value, not the average value. Okay, so RMS value I need to find out. So can I draw the current graph? Yes, sir. What will be the current graph? Sir, I is simply dq by dt. I is simply dq by dt. So simply differentiate, you will get slope is 1, here also slope is minus 1, in between slope is 0. So if I draw the graph, plus 1, slope is 0, then slope is minus 1. Then again the same graph will keep on repeating. So this is the graph which will keep on repeating. Value is 1, value is minus 1. Okay, this is 0 second, 1 second, 2 second, 3 second. This is your IT graph versus T, which will keep on repeating. So how will you find out the average? Sorry, how will you find out the RMS? Average is 0. Average is 0. So someone would say that, sir, power dissipated would be 0. No, RMS I need to put. So in signal system we studied 1 square into 1, 1 square into 1 divided by its time period. Okay, so this is the power. If I need to take the RMS, do the under root. So this is your IRMS value we are getting, which is under root 2 by 3. In signal system we learned it. So what will be the average power dissipated? 2 by 3 square into resistance 3. So answer is coming out to be 2 watt. That's it. Okay, so average power dissipated is 2 watt. Okay then, yeah.
For what frequencies the circuit resonates, right? So basically they're asking me the resonant frequency. You know, for resonant frequency, essentially your whole circuit should behave as purely resistive. So how can I make it purely resistive? So like, of course you can solve it using the longer method. That's not a problem. If I observe something here, that this L and this C are in series, so somehow if I make this short circuited, this whole branch is neglected, right? So if this whole branch is short circuited, essentially your circuit is purely resistive. So what needs to happen to short circuit this branch? Omega into L, that is 1, minus 1 by omega C must be equal to 0. So L is 1 and C is 4. So this will be 4 omega equal to 0. So your omega square equals to 1 by 4, that is omega would be equals to 1 by 2. So omega equals to 1 by 2, that is 0.5 would be your correct answer for this question. Now few students may have this doubt that what if omega equals to 0, because at omega equals to 0 this upper branch will be short circuited. You are technically correct, but of course omega equals to 0 is not a condition for resonance, because omega equals to 0 basically means DC, and at DC we don't see any resonance. We see resonance only when your frequency is not equal to 0, right? So this is certainly not your answer. Your answer is only omega equals to 0.5 radians per second, that is option C. Each parameter of a two-port network containing only resistive elements is shown. The capacitor voltage Vc at t equal to 2 would be equals to what? Okay, so basically initially the capacitor voltage was 5 volt, and at t equal to 0 I'm closing this switch. It is all a resistive network. Okay, then at t equal to 2, what will be the value of the capacitor voltage? So what I have to do, I have to convert this whole thing, right, network, into a single resistive element. So the h parameters are given, right? So I can use the h parameter and this value to find out the value of V1 over I1. If I am able to find out V1 over I1, that will be the R equivalent. So I can replace my whole circuit with R equivalent. So from that I can use the capacitor discharging equation to find out the capacitor voltage at t equals to 2 seconds. Okay. So let me first write down the h parameters. Do you remember what was my h parameters? So I used to have V1 equals to h11 into I1. That was constant. Then I used to have V2 because h12 was the voltage gain. So this will be h12 V2. This will be, I have chosen I1 and V2, so only I2 is left. This will be again h21 I1 plus h22 V2. Okay, so I can replace, like each parameters are given, so I can replace it. So this will be V1 into I1 plus h12 into V2. h12 is 2, so 2 into V2. I2 equals to h21 into I1. h21 is minus 2 into I1 plus h22 into V2, that is 2 V2. Okay, one more thing is there, that V2 by I2, right? V2 by I2 is basically, because this is negative, remember, like V2 is equals to minus 2 I2 into 2. Okay, because I2 is in the opposite direction, right? So V2 is equals to minus 2 I2 into 2. So I2 would be equals to minus 2 I1 and V2 is minus 2 I2. So this will be minus 2 I2. So from here I can get the value of I2. I2 would be minus 2 by 5 of I1. Okay, so I can replace my, oh, can I replace? Okay, I can, so what is my V2 then? So V2 is minus 2 I2, right? So this will be 4 by 5 I1. V2 is 4 by 5 I1. So I can replace it over here. This will be V1 I1 plus 2 V2, that is 8 by 5 I1. So this would be V1 by I1 equals to 13 by 5. Okay, so 13 by 5 is my R equivalent. We got the value of R equivalent. Now what we have to do, we have to simply use the equation, right? What is the voltage equation? VC, it will be VC of 0, that is 5 into e raised to power minus t upon tau. Tau is simply R equivalent into C. What is C? C is basically 2 farad. C is 2 farad. So your time constant tau would be 26 by 5. Okay, so this will be 5 e raised to power minus 2 upon 26 by 5. Okay, so if I, this will be 10 upon 26 exponential into 5, approximately it will be 3.4. Okay, so this voltage will be 3.4 volts. So your capacitor voltage at t equals to 2 would be 3.4 volts. This will be your answer for the question. A single precision floating point number as defined by IEEE 754 standard consists 32 bits arranged in the following fashion. 1 bit is for the sign. The exponent field contains 8 bits with a bias of 127. The fraction or the mantissa F field contains 23 bits. And its normalized number form, it lies from 1 E to 254. The value represented is this. Among, like, this is the representation, right? If this is my bit, right? They have already told me what is the representation. Although this is a standard, but they're already defining, they're already telling you this is how the number will be represented. How does it mean? So basically this will be minus 1 raised to the power of s into 1 dot f, right? Where f will be the, basically what is f? F will be this mantissa, right? They have told you f is the mantissa. 23 bits. So how can I write it? Let me show you a very basic example. So let's say I have only 2 bits of mantissa and 2 bits of exponent and 1 bit of sign. So let's say in binary I represented it like this: 0 1 0 and then 1 0. That's it, right? So how can I represent this in my decimal format? Okay, how can I represent in my decimal format? So first bit is sign bit. So they told me -1 raised to the power of s, right? So that is -1 raised to the power of 0, the sign bit, into 1 dot f. F is basically the mantissa, right? That is 23 bits. That is 2 bits here, right? So that would be, what is 1 0? Sorry, f comes last, right? Sorry, f comes last, mantissa comes last. So let me change the numbers here so that you'll be very clear. So f is coming last, as you can see, mantissa is coming last, first exponent is coming. So what is mantissa? 1 1. What is 1 1 in decimal? 3. So this will be 1.3 into 2 raised to power, ignore the bias for now, just without the bias I'm telling you, exponent is what? Exponent is 2. So this will be 2 raised to power 2. Cool. So what will be your actual number? This will be 1.3 into 4, that is 5.2. So this will be the number. If you want to learn more about floating point representation, please go and watch this video. It's like 4.5 hours video. Although in this question, right, everything is given to you, you don't even need to watch the video, and that is what I'm expecting as well. In gate examination, if they're asking something from COA, right, they will ask you something very basic, that if most of the data will be given to you in the question, you will have to just think at the exam hall, how can I solve it? So most of the things are given here. Although if COA, if you are studying COA, you are expected to know about this, right? Even if you don't know, still you will be able to solve this question. So even after explaining this part, if you still have some doubts left, make sure you go and watch this video. Complete floating point representation has been explained in a very lucid manner. So in the difference here is just we have a bias exponent. So whatever will be your exponent, right? Let's say your exponent, you're computing it to be 250. So this will be e minus 127, that is 250 minus 127. There is a reason why we do this. So that has been explained in the video. I am not explaining here. So simply they're asking me what can be the largest floating point representation number, right? What can be the largest? So of course the largest would be when mantissa bits are all 1, right? So this will be the highest number, and I'm multiplying with the highest exponent, right? Then only the number will be largest. But please keep in mind, they have given you the range. So your exponent can only go from 1 to 254. So exponent cannot be equal to 0 and exponent cannot be equals to 255. Although it is 8 bits. So with 8 bits we can actually make it 255, but we don't make it 255, basically all ones. There is a reason, those are called as reserved numbers, and again that particular concept has been taught in this video. But for us, they are just defining the normalized numbers, and the range is also given. So I will choose the maximum value of E and maximum value of mantissa. So for mantissa they have not given any condition, for E they have given a condition, that is maximum value can be 254. And do you know what is 254? 255 is all ones, right? There will be 8 ones, 8 times. 254 will be this minus 1. So basically the last bit will be 0. I'm subtracting 1. So this 0, right? This is my 8 bit number. All ones, then 0. That's it, right? So basically 4 ones, then 3 ones and 0. So this is my mantissa, that is equals to 254. Sorry, not mantissa, exponent. So 4 ones and 3 1 and 0. So certainly this will be my answer, and they are asking me largest number, not smallest. So sign bit will be 0 because largest mean more positive, more larger. So sign bit will be 0, and mantissa can be all ones. They have not given me any range of mantissa, so I am safe there, right? So mantissa can be all ones. So option B will be your correct answer for this question.
Yeah, so you guys are done with the KillerX examination. You have seen the solutions as well, and I hope you have spent roughly around 3 to 4 hours or 4 to 5 hours in analyzing this question paper. This was my requirement, this was my suggestion as well, that you see each and every question and understand that what I can get from this particular question paper. Okay, and this is how you should be analyzing your question paper. Now roughly around it's at 7 p.m. Okay, at 7 p.m. we are going to come live on YouTube. on this channel only, on our PrepFusion channel. We are going to come live on YouTube and we will be discussing about the question paper. Like what was the marks of topper, what was the difficulty level, and based on your marks, where do you stand? Whatever the queries that you are having, you can also ask that particular query as well. So at 7 p.m. we are going to come live. Okay. I hope you have enjoyed the session. I hope you have enjoyed the question paper as well, and you are confident enough for the next examination. When is our next examination? Our next examination will be on 25th of January. Okay, and then the next would be on 1st of Feb. This is Booster X and this is your Replica X. So let me tell you one thing. This was the toughest examination of all. Booster X will not be that tough. Replica X, I am not telling you the level. Replica X I will make. Although this question paper was also made by me only and Anish sir as well. But for Replica X, we are not telling the level. Replica X means it will be gate replica. So no level will be disclosed. But this was KillerX. It was on the tougher side, I can tell. But Booster X will not be on that tougher side. Okay. This question paper was roughly like you can say gate 2023 electrical. Gate 2023 electrical. Or you can say gate 2024 EC. Or you can say gate 2025 IN. So here you would see that AIR1 was getting 63 or 66 marks. I guess 66 marks. Here AIR1 got 63 marks. AIR1 I am talking about. And here like AIR1 was like very good student. So let's not talk about AIR1, but I remember the marks of in gate 194. Whose marks I remember? Like I remember here like again in 60 plus marks you were getting under 100. This was the scenario. 60 marks under 100 was the scenario. So this was that kind of question paper. Now it might happen that in 2026, who knows, EC paper question come out to be on the same side, like 70 marks rank 1. This may also happen. So that's why KillerX. You need to analyze this question paper. You need to see what maximum you can get out of this particular question paper. And you can comment down as well your reviews, sir. What was the level of the question paper? Because we have personally set up all the problems. No, it took a lot of time. We are spending at least 7 to 8 days in just making this question paper and solution. 7 to 8 days only for this one question paper. Okay, so setting up the question paper, then analyzing it, then all these things, everything we are doing. So you can comment down that, sir, yes sir, the level was pretty good. And I don't think any coaching institute anywhere you are going to get this kind of question paper. They will hire some ranker, they will make the question, they will put it there. But efforts were involved here. I hope you are able to appreciate it. Okay then, so let's meet at 7 p.m. and we will discuss everything about this KillerX All India mock test. Okay, and let's meet in the second All India mock test, which will be taking place on 25th of January. Okay, yeah, thank you very much. Happy learning.